Welcome to App.js 26. It is so good to be back here for another year. How many people are here returning? Nice. Let's give yourself a round of applause. And I'm guessing there are some new faces.
Yeah, and now show hands if this is your very first time, just like me. Big round of applause.
Wow, there's a lot of you. Welcome,
That's
welcome,
nice.
welcome. Well, I feel like you did that just to give yourself a round of applause, so. All right, let us get started. First and foremost, we want to make sure that you know who we are. So let's introduce ourselves. Your MCs for today will be helping guide you through the different amazing pieces of content and the speakers that you actually came here to see. So I'll start with me. My name is Nathaniel Okenwa. I'm a developer evangelist at Twilio, but I spend a lot of my time working with React and specifically building apps for communications.
And my name's Kevin Lewis. I'm a developer advocate at Appify. We are the world's largest marketplace of tools for your AI agents and applications.
Fun fact, actually, we went to university together. We've been spending a lot of time, but honestly, we only see each other at tech events, which is hilarious. And I'm sure there are lots of people in this room. Maybe you have friends or colleagues who you haven't seen in ages. So make sure while you're here, you take the time to go and see some friends and maybe make some new ones. Maybe you can even grab a beer with them later.
Absolutely. And if you haven't already got it, you should probably get the app for this event. You can go ahead and download it. The app has a few things which you will find useful today. Firstly, the up-to-date agenda. There have been a couple of small changes over the last couple of days for this event, and you can use the agenda within the app as your source of truth. So do make sure you do that. You can also use the app to favorite sessions that you want to come back to later, and also to share contact information with new and returning friends.
Cool. All right, couple of things that you maybe have missed. This is the main hall. This is going to be reserved for talks and stuff. So while you're in here, you're going to be doing lots of applause, giving the speakers all of the energy and attention that they deserve. But you may also want to network, not just with yourselves, but also with the sponsors, and we really would love you to do that, and that's just behind in the sponsors area. You've probably already seen some of them, probably had your eyes on some swag that you want to take home. And so make sure you go and enjoy them, go and check out all of the sponsors that we'll have today. And there is even a balcony upstairs with some bean bags if you maybe need a little bit of a nap, or you just want to lie down, and then also some coffee and drinks throughout the day. One little notice, a curtain is not soundproof, as most of us engineers probably understand. So the one thing we do ask from you is if there is content, a speaker on this stage, while you're over there, have fun outside. It is a bright, sunny day, so you can network outside, you can chill outside. There's lots of nice seats that are over there for you. But we just ask that when there is content on the stage, we don't necessarily do too much talking in the back.
Just keep your voices down a little bit. There's also the restaurant, which you can go ahead and chill out in.
Cool. All right. We're going to be giving you much more information throughout the day because we know it's a lot to download before the coffee's really kicked in the morning. So we are going to get started with the day. Why do you think we do that? All right. First of all, before we do that, are people excited? I mean, nah, they don't seem excited.
Rubbish.
Imagine we were to actually get the first speaker out and that was the
it.
reception.
I know.
Okay, should we try again?
We should.
All right. How many people are excited? All right, that is much better. But I think we can do better because there's a lot of people who are at home watching this, and I don't know about you, but I love giving people FOMO. I want them to feel like they're really missing out, like we're having the best time. All right, so one more time. Are we excited? Yeah! Nice. All right, I think we are ready for the next speaker. Now, the next speaker is the co-founder and head of engineering at SWM who helps put on this event and does an amazing set of talks for us today. We're going to see their faces quite a lot. And they are also very, very deep in the React Native world and have contributed and produced lots of amazing libraries and tools that people probably in this room use a lot. So, to give us our keynote to start off the day, I'd like everyone to give a massive 10 out of 10 round of applause to Krzysztof.
When was the last time you flew in a rocket? And when? Bear with me, because I have a good reasons to believe we're flying one right now. React Native, from the beginning, was built with productivity in mind. We ship apps to 2, 3, or even more platforms from a single code base. With fast refresh, we click save on a file and see the results on the screen instantly. We can fix bugs in production using over-the-air updates by using a single command, instead of waiting hours or days for the review. Have JavaScript running on a mobile app, rendering truly native views. How cool is that? React Native quickly proved that it can take off the ground. It proved that you can use it to build great quality, true native mobile apps. But it wasn't as it is today from the liftoff. I work at React Native core team at Facebook when the project started over 10 years ago, and I remember it all. Performance wasn't great. The asynchronous bridge has its issues. You had to debug through some tab open in the Chrome browser, and native modules or animations just wasn't perfect either. Bridge, Chrome debugger, native module systems, those were important pieces that accelerated React Native at the beginning. But in the long run, they were just slowing us down. And just like rocket boosters, without fuel, are dead weight. We had to let them go. We swapped JSC for Hermes. We adopted new architecture, get rid of the bridge. We swapped the Chrome debugger to proper DevTools. At Software Mention, we built libraries like Reanimated, Gesture Handler, and Screens to fill the gaps in native navigation, animations, and interactions. And while doing all that, while flying this rocket, completely unaware, we built a perfect environment for the next era of building software, for the AI. AI is the second stage booster that gives us all a huge acceleration in productivity. We just need to point it in the right way. So if we were building Swift or Kotlin app 2 years ago, this is how your typical iteration would look like. So you would spend some time coding, and then you would build the app, maybe go get a coffee while it's building, and then check if it works and if it looks the way it was supposed to. So we would repeat that over and over, working on a single task in the future. But now with AI, the proportions are changing. Coding is no longer the dominant part. AI splits out thousands of lines of code within a second. The bottleneck becomes the verifying part, which we'll address later in the talk, and also the building, but not in React Native. With the fast refresh, we can just get the updates instantly on a screen. So you have fast refresh, and your AI agent has it too, can use it too. So fast refresh in the AI era matters more than ever before. Say you already publish your app, and it's in the store, you often start planning the next releases and updates. So you'd spend some time on working on new features or fixing bugs or improving the quality of your app. And once you have your version ready to submit, you submit it to the App Store or to the Google Play Store. And then it may take hours or days to review and even more time before the users actually get the app installed. Finally, you can collect the feedback from the users and start this process all over. But with AI, we see that it is much easier to contribute, and in most of the projects, the pace of those sprints has increased. So you are now ready to send updates more often, and again, the publishing step becomes a bottleneck all of a sudden. But not in React Native. We can publish a lot of the updates over the air using a single command. So we're back to our React Native rocket, accelerated by AI. But as you may know, it is a special kind of a rocket, because we can moderate it, we can swap out parts as we move along. This is not typical for rockets, right? So let's now take a look how we at Software Mention improved this rocket since the last App.js last year. Some time ago, we started thinking, what's a good new library that we can build for React Native? We quickly figured that building libraries is not necessarily where we can make the biggest impact. With so many people at Software Mention having a ton of expertise in React Native, we thought that we're in a very good position to not just improve the libraries for our users, but to improve React Native core for everyone. Building libraries is cool, and you get this quick gratification. You publish the new package, and you get thousands of likes on Twitter. While contributing and maintaining the core may not be perceived as too exciting. So we have a few folks from the React Native core team on the audience today. So please give them a round of applause for their hard work on keeping this rocket flying. In the past year, we set up a special collaboration with Meta and the React Native team that allowed us to contribute more. So in the past 12 months, our team at Software Mention landed over 280 commits to React Native across many different projects. So let's see some highlights. So while we haven't contributed directly to Hermes, at least not significantly, we had helped in setting up the build infrastructure and the opt-in mechanism for Hermes v1. A year ago, Hermes v1 was the only actively maintained version of Hermes, while people in the community were using a dated and unmaintained version. Hermes v1 brings a ton of improvements, and as it is actively maintained, we should expect more improvements in the future. So it was obvious that we wanted to have this for everyone to use. We helped bring Hermes to the open source initially as an opt-in in version 82, and eventually as the default engine in 84. The shared animation backend project aims to bring some parts of from reanimated and parts and ideas from reanimated into React Native. This way, it allows us to optimize the animation engine as it now lives closer to Fabric and can integrate with parts of the renderer that just wasn't accessible from the outside. The best part of it is it doesn't just make reanimated better, it also is used by the original React Native animated and unlocks new possibilities in the future. Finally, the stability projects. Last year at App.js, Alex Hunt presented the results of the JS Stable API projects. In a sense, it allows us to extract a complete API surface as one TypeScript definition file. This way, allowing us to have more control what should be public or private in the interface, and also understand when a change that we land in the core can be breaking. A few months ago, we started working on ideologically similar thing for the C++ API. We're at the stage where we have a complete definition of the whole React Native C++ API surface with a goal of reducing it to minimum that is necessary for libraries and out-of-tree platforms. This will help us avoid breakages for libraries or projects like React Native for Vega OS while we move towards React Native 1.0. Of course, you cannot use React Native without a framework. We've been working with Expo for many years now. Nowhere it is more visible than right here at the conference, that we've been running together with Expo since 2019. So let's take a look at our team's contributions to Expo. In the past 12 months, we landed over 750 commits to Expo monorepo across many different projects, smaller modules. So here's like the overview of the different projects that we contributed to, but let's also discuss some highlights. Expo Brownfield is a library and CLI that streamlines the process of incorporating Expo into React Native brownfield apps, meaning apps that weren't started as a fresh React Native project or Expo project, but want to add React Native and Expo to their existing native code base. Expo Widgets lets you render platform-native widgets using Expo UI components. You can render widgets for home screen, for live activities, or for the dynamic island. And finally, we work on improving the Expo module's core system for Android, both in terms of build time, where we see over 60% reduction in the build time, and also in the runtime, where improvements speed up the startup by 20 to 30%. Of course, while contributing to React Native and Expo, we're not abandoning our own libraries, and we are not stopping working on new ideas. Last year, we published a major release, Reanimated 4, that among other things added support for a new CSS compatible animations and transitions API. Later, we extracted worklets from Reanimated, allowing for worklets to be easily used in context of other than animations. We also added bundle mode to worklets. Yesterday, we published version 4.4 that adds core animation support to CSS animations in Reanimated. It allows for a number of commonly used animation types to be offloaded from the UI thread to a renderer server, making the app feel smooth even under heavy load. And we're also working on CSS pseudo-selectors support that just didn't make the cut this time, but will be available soon. React Native Screens is an unsung hero of the navigation libraries. So whenever you're using React Navigation or Expo Router, the native navigation components are provided by Screens. Screens makes it possible to use native stack, tabs, or models. Last year, we spent a lot of time bringing in support for all the new features that were brought by the iOS 26. But we don't stop there. We added support for more APIs, like the bottom accessory and the split view. Listen to Kacper talk in the afternoon today to learn more about screens. Detour is our open source and free service recent project that helps with handling deferred links. When you open a deep link on your phone, it navigates to your app, and then the app can handle it from there. But if the user doesn't have the app installed, the link is lost. Detour helps with handling such links, so it provides open source SDK and free service to help users reach the right screen when they eventually install your app. You may have seen this Jelly slider demo before. We built it with TypeGPU, and it was even featured on Google I/O last week. TypeGPU enhances WebGPU via TypeScript, but it isn't just adding types to WebGPU APIs. It's much more. It uses TypeScript to extract the data shapes when communicating with the GPU, reducing the boilerplate and risk of data and misalignment. It even allows you to write shaders in TypeScript. Recently, we added first-party support for React and React Native, so you will hear more about it in the afternoon from Ivo, and maybe even sooner. Enrich is a family of libraries that support rich text rendering and editing. It supports all sorts of crazy features like the GitHub flavored formatting, mentions, LaTeX, and more. If you need this sort of component in your app, you can go wrong with Enriched. And finally, Aaron Repo. It isn't actually a library, but a configuration plugin. It improves build speed of your app by injecting into the build pipeline. So when you use some libraries in your app, Aaron Repo plugin swaps the build process such that instead of building the libraries from the source code, it uses a pre-built libraries that we host on Maven. Aaron Repo just went out of beta, and if you're using Expo, it just takes one line to use it, so I encourage you to try it. Finally, in the last part, I wanted to talk about the AI-specific improvements that AI-specific investments that we're making in the React Native space. React Native Executors is a library that allows you to run local models in React Native. It supports all sorts of different models, from language models, vision models, multimodal models. And I know that there is a common perception that local models aren't very good. They will never be as good as the state-of-the-art models from the major libraries, labs, but they improve at a similar pace. So local models that you can run today are much better than the ones available a year ago. And specifically for when you have very specific needs and can adjust the model to your needs, they are really good in many cases. So, but you don't need to trust me actually on that. You can just try the app that we published last year. It's called Private Mind. This is an app that's available on the App Store and Google Play Store. And just try it. It showcases the React Native executors. You can run different models. It's basically it works like as a clone of like a chat app. So you can test all those features there and test different local models. Finally, and the last project is Argent. Argent is a tool that allows your AI agent, whenever it's Claude Code, Codex, or Cursor, to autonomously iterate on complex mobile development tasks. It isn't just about controlling the device or taking screenshots. It can inspect the view hierarchy, notice and understand errors, read logs, access the debugger, profile native code, profile and analyze data from the React profiler, and also can see the network activity coming from your app. It is a tool that almost every mobile engineer at Software Mention adopted on day one, and also one of our fastest growing new projects. I personally use it every day. It is very good. You should try it. I'm really proud of the work that we've done in the past year and what the team shipped in the past year. We're very lucky to be in a position where we can contribute so much to the community. And as a software house and consultancy, the work that we do for our clients is what lets us understand where we can make the impact. It is that work that it is thanks to that work that we can have first-hand experience using the tools we are building, and it is thanks to our clients that we can fund this work. In the past year, we had worked with over 100 different clients, and I wanted to at least showcase a few. We are honored to work with so many awesome, forward-thinking companies and people. Those are just a few highlights, but we have a bunch more people from the companies that we work with today at the audience, so I wanted to take this opportunity to say thank you.
What should I do?
One more thing. It wouldn't be App.js without new releases. And so today, we're proudly presenting version 3 of Gesture Handler. This is a major release, first one after 2 years. It's built with the new architecture in mind, allowing for more ergonomic APIs from the user perspective and better performance. It ships with revamped buttons components that better incorporates the native platform behavior. And it has a straightforward migration path from V2 or even V1. So if your app uses Gesture Handler directly, you can easily benefit from updating even today. And if you are not using Gesture Handler directly in your app, I still recommend you check out the buttons components as they are a great alternative to touchable or pressable from React Native. And there is something more. So last thing for today is another launch, and we finally are launching our own bottom sheet library. You can install it from as double mentioned React Native bottom sheet, and it is a bottom sheet library that just works. It has feature compatibility with the beloved bottom sheet from Gorham. The main idea behind our approach was to build the bottom sheet using platform-native primitives, while making it very customizable. So it hides all of the complexity around scrollable or resizable content, and it can work in inline or modal modes. The bottom sheet was built in collaboration with Gobi, which apps recording you're watching right now. Yeah. This is everything that I have for today. Thank you.
Thank you, Krzysztof. I'm just going to stay here and just be hanging. That was awesome. Let's give it up for Krzysztof one more time. Your lives even easier getting announced on stage. Now, I know some people, you may be tempted, you want to get your laptops out. I can see a couple people in their laptops already. Don't worry, it's okay, I don't judge. You may want to download and try out some of these libraries already. But before you do that, we have more amazing content with maybe even more announcements, you never know, coming up. So I would say stick around for the next session. But before we do that, I did want to shout out a couple of really, really important groups of people that have helped make today happen. So you're going to need to do a little bit of clapping. Don't worry, it's just a bit of practice for the rest of the day. But I'd like to first say a big thank you and I'd like us to give a big clap to the organizers of this conference today. And that is Software Mansion and Expo, who have come and put together amazing content, organized the speakers, organized the food and the beer. Very importantly, thank you to them. But also, they don't do that in isolation. They do it with a wonderful team of amazing sponsors. So another round of applause for all of our sponsors. They can hear you over in the back. All right. Now, thanks to our sponsors, thanks to our organizers, but a big thank you to our speakers. And someone doing double duty here as helping to organize the conference and also giving us a second keynote to kick off the day. I'd like everyone to give a massive round of applause to Charlie from Expo.
Hey everybody, what a year. Look at this. React is blowing up. React Native is blowing up. And Expo is blowing up. All these things are growing like weeds or wildfires or whatever analogy you want to use. Revenue Cat also published this report discussing all the different frameworks for making subscription apps. And React Native was the clear winner in basically every category across the board. This is one on just D60 revenue per install, and you can see the sort of yellow highlighted React Native just crushing Native, Flutter, and any other framework. React Native and Expo are just everywhere now. Just like you look at any new app, and there's a really good chance that it's built with React Native or Expo. But part of why this is happening is something that we see all around us. I put up this slide a year ago at this conference, highlighting this woman, Audrey, who works at AI2, and she's a non-programmer who had built an app with AI that she had put into production. And at the time, it felt a little bit gimmicky and unusual, and it was kind of a cool story, but not very common. Fast forward to today, and all of us are doing this. If you're a programmer, you're accelerating your development with AI, and you're flexing your skills to do things you couldn't do before. And if you weren't a programmer at all, you're now maybe becoming part of our community. All those graphs that I just showed you shoot up in January. January is the time when we sort of all realized that AI went from being a toy to being, a really good software developer. And React Native and Expo are winning this AI era so far. Yeah. So, congrats, everyone. We finally got React Native and Expo to be the best way to make new apps. That's a pretty big deal. For a lot of years, people just said a cross-platform framework can never be good enough. People talked about HTML5 as just not being good enough, and they were kind of right. A long list of other frameworks tried to get here, and they couldn't do it. And all of you were part of the big effort to make this happen and make us win. And all of us made a big bet on this community and this approach that we could get there, and that bet is paying off now. What's really put the wind in the sails of this is that React Native and Expo are really the best way to build apps with AI for a bunch of different reasons. And almost every app that is an AI app builder that generates apps or generates mobile apps uses Expo to do it. And if you ask most AIs like Claude or Codex or Gemini like how to build a mobile app, it'll direct you to Expo most of the time. There's a bunch of reasons for that. The biggest one is just that we bet on JS and TypeScript and React. And that turns out to be a great bet when there's a gigantic amount of training data that's prepped all these AIs to use our stack. Another big reason that this is happening is because There's great documentation across this community. In the Expo repo, the #1 source of commits was docs. There were over 1,160 commits just to the docs in the last year alone. So that is really helping make the AIs understand how to write Expo apps. And then universality has really come into play in the AI era. If you just go into a website that has a little prompt box like you see all over the place and you say, I want an app that plays the stream from my radio station that I have, it doesn't have to know what kind of phone you have. It doesn't have to know what kind of computer you have. It can just know, hey, if I make an Expo app, it'll work everywhere, and it'll work really, really quickly. So that's driving AIs to do everything. We also have an incredible ecosystem here, and all of you are part of it. From MMKV and Vision Camera from Margillo, from React Native Paper, CallStack, and Native Wind, and WebGPU, and Skia, and FlashList, all the way to React Native, Reanimated, and React Native Screens and Friends, and everything from Software Mansion. There's a huge effort across everyone in this room and also beyond that's making this a really vibrant ecosystem that takes care of all the problems that you run into. Every time you want to do something hard with React Native, there's probably someone else who has already done it, and you can benefit from their work and stand on their shoulders. And that's a big part of why we're getting further and further, because we're the sort of healthiest open source community in app development. The community is also just a big part of posting on Reddit about the experiences you have and sharing stories of success, which is leading people and also AIs to realize this and sort of spread the word. We can see everything's growing really quickly. You can see our stars on the Expo repository just keep growing faster and faster, and we'll cross 50,000 stars in a few days. And then it's on to 100,000 from there, I think. Two of the biggest, best flagship apps in the AI era are built with Expo. The Replit app is built with Expo, and even will let you build Expo apps with it, so it's sort of meta. And that's consistently in the top of the developers' tool charts in the App Store and is doing really, really well. V0 from Brussels, built by Fernando Rojo and friends with a great amount of care, and is one of the best apps out there, all built with Expo. So we're really winning the race to be the technology of choice for the new AI era. But the job's not really done. In some sense, we're not really quite there yet. Sort of the final boss of this journey is, I think, if you need to build an app that's critically important to your business, and you have unlimited resources and access to the best talent in the world, what technology do you choose? And we kind of went 0 for 3 on these frontier labs building their flagship AI apps. The ChatGPT app and the Gemini app and the Claude app are all built with Swift and Kotlin and these sort of traditional native technologies. So there's still a gap there. For websites, React has already won. Everybody making the best websites in the world is already using React. But we still have a little gap to close on the React Native side, and there's a few things we have left to do. So we're not 100% of the way done with this journey. And then at the same time as we have to finish that journey, the game's also changing underneath our feet. I've been talking about AI for the last 7 minutes, and I just talked about all these reasons why React Native and React and Expo are doing great and off to a great start in this AI era. But things are changing so much that there's no guarantee that we're going to keep winning this game if we don't do everything that we need to prepare for this new world. So there's a few more things we need to do as a community, and we need to do as an Expo team to make this happen. The most important thing, I think, here is completing feedback loops. When an AI agent can figure out what it's doing and evaluate whether it's complete or not, or whether it's done is working or not, then it can almost always figure things out. So Argent from Software Mansion and their related simulator work and Agent Device from CallStack, and these things that let agents programmatically inspect their work, understand what's going on, get screenshots, poke and probe at it, push buttons and see what happens, test apps and things like that. Those are really, really, really important and the foundation of making these things work. So we need to make this as good as it possibly can be. The sort of gold standard in the world right now for this is the web ecosystem. There's so many people building tooling there, and it's so open, and the tooling is so mature that that's a big reason why almost anybody doing stuff with AI, their first look is towards web. And that's another reason why continuing to make web support first class in the React Native ecosystem is more important than ever. I actually know a founder who's building an Expo app, but the way he does it is he uses Cursor Cloud Agent and just generates a website for development, and then maybe once every 2 or 3 days generates an iPhone app from that. But the website is good enough to test most things, and the iteration cycle is so fast that that's actually an incredible way to do it. So we really need to, there's more need than ever to make web support be a first-class citizen in this ecosystem. We all know that speed is important, but now that the time it takes to write code is going down and it's mostly being handled by AI for most people, the other parts of the process, builds, distribution, boot times, etc., become the bottlenecks in the process. Every second and millisecond we can shave off here really matters. So a lot of the effort the Expo team is going to put into the Expo project over the next year is about making build times be as fast as possible and every other part of everything that goes on and making an app be as fast as possible, so you're only limited by how fast you can write code. We also need to blow the lid off the ceiling. I think this is probably the #1 reason why the Google and Anthropic and OpenAI didn't choose React Native for their flagship, chat apps. I think it comes down to, they didn't think that they could do keyboard handling well enough. They didn't think they could do chat UIs well enough and things like that. So there's just a few gaps we need to close there to make it amazing. And things like Expo Router are really, really important for not just making it possible to do amazing things, but make it, be a pit of success that's easy to fall into. So that when you just do something by default, you go, wow, how did I get so good at making beautiful apps that feel really great? I must be really talented. But really, it's you plus using the great stack underneath you. And then another piece of the puzzle is that we need to add first-class support for agentic interfaces. As the world changes under our feet, AI is not only writing our software, but it's also starting to use it for us. And so what we need to do going forward is an Expo app we're going to not treat just iOS and Android and web as our 3 first-class surfaces. We're going to add agentic interfaces into it as one of our primary ways to explore stuff. The world is still figuring out exactly what that means, but it's going to be important. I talked about how we're going to do everything around the writing of code to make that easier. And I want to share a few things that we're working on in the Expo team over the last few months to help all that happen. Expo TV is making Expo even more universal. It lets you share about 85% of your code while targeting Apple TV and Android TV. And as of Expo SDK 56, the Jetpack Compose and Swift UI APIs in Expo UI are stable and shipped with the default template. With Expo UI, you're driving real Swift UI and Jetpack Compose widgets from a single JS API. And you don't need to bridge and implement all those yourself. You don't need to write a native module just to include one little widget from the operating system primitives. Expo Launch is an incredibly easy and fast way to get your app deployed to TestFlight, the App Store, and the web. No complicated configuration files, just a straightforward web-based flow, and the magic happens. The official Expo MCP server connects your agent to your project's SDK version, configuration, running dev server, and Expo's cloud services. Originally, it was only available to people on paid plans, but we've now made it free and open to anyone with an Expo account. One of my favorite things about this is the local simulator integration. A multimodal agent can screenshot and tap through your running app and pull React Native DevTools data and investigate maybe why a build failed or a workflow failed and pull in TestFlight and crash data. The Expo Skills repo is a collection of official skills for building, deploying, and debugging Expo apps. It covers UI building, deployment, SDK upgrades, DOM components, and dev clients. It can do cool stuff like deep integration with Expo Router and Liquid Glass, so you can have your AI agents one-shot, really polished UIs that look and feel completely native. I also want to talk about Expo Observe. It's a new performance observability tool and service. It captures all the common sense basics you need to make sure your app is working well in the wild. Real user startup metrics, cold and warm launch, time to first render, time to interactive, and bundle load times. It'll be available for everyone soon, but you can sign up for the private preview right now on the website and come to Caddy's talk tomorrow where you can learn more about this. Expo Widgets gives you an incredibly easy way to integrate with widgets and live activities on iOS, which is something you historically would have needed to drop into the weeds of native code to do. And Expo Router v7 doubles down and gives you the most native experiences possible, adding native toolbars, link transitions, and more native navigation primitives than ever before. SDK 56 is also here. Speed improvements across the board, from precompiled binaries, meaning faster builds, to improving Android's cold start times by 40%. Hermes v1 is also now the default, plus a ton of other goodies. We built a beautiful new starter app. It's actually shocking how big of a difference this makes. Every time I start a new Expo app now, I just feel like I'm a really good developer because the first screen I see just looks so slick and so nice, and like I know I'm off to a great start building something that's going to feel awesome. So even though the world is changing under our feet and software development is changing rapidly, our mission is still pretty much the same thing at Expo. When you have a vision for an app in your head, we want to make it come to life as quickly, as easily, and as great and high quality as possible. So we're going to keep working on this stuff, and it's going to happen. Thank you so much for coming out to Krakow and being a part of this community. Thank you so much to our hosts at Software Mansion and all the conference sponsors. And I can't wait to see what all of you build next.
Amazing talk. We've had 2 back-to-back awesome talks with lots of new announcements, and so you're going to need some time to digest this all. But don't worry, it is a coffee break time. We would like to say a big thank you to our sponsors, Revenue Cat, and you can go over and have some awesome coffee on them. While you're there, check out the sponsors. There's lots of amazing sponsors like the Expo and Software Mansion folks there that you can go and have a chat with, and we will see you after the break. And if you do want some more content, we'll be having some live studio interviews, which will be on this stage. And first, we have Britta from Shopify, who's going to be chatting with us. So we'll see you right after the break. Thank you.
One of the things that I want to tell people is that social connection is important. We all live now in a world where a lot of us work remotely, but there are a lot of things that are baking right now. And coming to a conference is a good way of really getting ahead of the curve. So I definitely recommend properly interacting with people and getting to know the React Native community.
I had a conversation with one developer that was working on something, and I learned a ton about how we could optimize things in my React Native project. I think that's incredible. That access and that community that App.js provides is unparalleled.
Good morning, everyone. It is so good to be back here, App.js 2025.
You can just feel it. I mean, it's so crazy when we're here because there's so many of these just apps that I use every day. And the author is here. He's talking about like how using React Native has drastically improved their workflow. Exciting time to be an app developer.
All of the engineers that I really admire are here, so it's like a pleasure to learn with them. So yeah, I'm enjoying. It's pretty cool.
Drink.
Wait. One more thing. There's one more group of people we need to thank.
Yes.
It's the audience.
The audience, yes. Can you give yourselves a round of applause?
I know,
you're at home.
Hard for your Islamic.
Yeah, a standing ovation for yourselves.
Round of applause.
That is awesome.
All right.
Thank you so much.
Thank you. It's a day of learning, and let's have fun.
It's not enough. Hey.
2 hours later.
Hello, everyone. This is the RTC on 2025.
So it's quite retro, it's quite fun. Let's see whether or not we can kind of make it real time. I don't have any backup here.
I felt kind of compelled like to break more stuff and, you know, in the process of trying to make them working. So, yeah.
I build stupid things for people.
I'm doing Elixir for life.
We met the only Elixir developer who's actually paying his bills with Elixir, so it's very impressive.
How do you like the conference?
Very, very interesting stuff. We love Vulkan Video, we love Rust.
Really, really good. It's my first time here.
As a nerd, I have to admit I'm really keen to this mock thing.
We have a strong team of speakers this year. Everyone's very cool.
A lot of topics during the conference that I really enjoyed.
Here it's very cozy. Everyone's very friendly. It's so cool. Anyone who's working in this field should definitely come.
Forget that. I'll start again. I forgot what I said at the beginning. So, productivity.
Elixir is great technology.
Maintainability.
And we just need to...
And readability.
Do a better job of marketing it.
Okay. Well, definitely what I appreciate the most about Elixir is the Elixir community. Boom, cut. Yeah.
Modern people don't really want to go deal with all those curly brackets, and Jose, I think, has done everybody a great favor by enhancing the language and making it much more useful in the modern day. So it's going to be an interesting afternoon to figure out how we apply our resources to things.
So we learned all these hard lessons, building software and failing. And you take those lessons and you learn to value a new set of priorities, right? And Elixir sort of embodies those things that people don't know are important when they're first starting out. You know, when you're first learning to program, the properties that Elixir actually provides, it's difficult to explain why those matter. And so that's one of the things that we've seen, is that it's filled with people who have deep experience, deep nuance and understanding of like what goes into good engineering and how we make software that will stand the test of time.
Folks from Software Mansion reached out. They said, look, we do this kind of summit with React Native. It could be interesting to have that for the Elixir community as well. So it was the perfect moment, the perfect place.
This might be the most unusual React Native workshop you'll ever attend. Why? I work in a villa on a Croatian island. Small groups up to 10 devs.
Led by the people building the tools you already use.
You learn how to build Expo modules and master the entire EAS ecosystem.
Then we'll dive into Reanimated, Gesture Handler, and Worklets.
We cover the new architecture, performance profiling, and JSI, and we'll finish with a consulting day to solve your app real problems.
Sounds good? Book your spot and see you by the pool.
Hello guys, today we are at Software Mansion with Meet.js, and this is meetup focused mainly on JavaScript and front-end development, although we have a variety of topics.
We're kind of trying to push the boundary of what's possible on the web. It's always been possible, but we're trying to make it easier than ever.
This meetup is perfect for people to see how their web knowledge can be applied in mobile world.
I love the energy they conveyed in the presentations.
So this is the kind of place where you can do Jolly Slider as a part of your job.
We are at the meetup in Software Mansion office, which is called Build with AI DeepMind Mansion, and this is edition 5. My name is Meistrich. I'm the lead software engineer in in-house Software Mansion AI team, and we are mostly focused in convincing people that Edge AI is a good idea and that they should consider it in their next product.
I'm Philip. I work here at Software Mansion, and my talk was about the performance on local models. Developers after my talk should consider using tools that reduce context use. They should consider either using a sub-agent for gathering this required information or using the dedicated tool. I don't think it was very controversial. Mateusz's talk was very similar and we agreed. So at least in Software Mansion, we have the same mind.
Hi, welcome everyone to the Studio Live, a live interview panel during App.js. I'm Kacper.
And I'm Zuza.
And here with us is Britta Evans-Fenton, a senior developer at Shopify. Hi, Britta.
Hello, thank you so much for having me. Nice to see you.
Hi, so this is not your first App.js, but you really liked to be here, right? So what made you come back to App.js this year?
I mean, what's not to love about App.js? Like, this is such an amazing, like, the production value is wonderful. The people are amazing. The food was surprisingly, like, the best food I've ever had at a conference. Yeah, it's just everywhere. It's just, like, everything's good. I literally cannot say anything bad about this conference at all. So thank you so much for having me back.
It's a pleasure. So maybe talking a bit about your talk that you have tomorrow. So what made you focus on the accessibility part of application? Because I would risk a statement that it's a bit neglected part of development.
It's a very good call out. So you'll hear this a little bit in my talk as well, but I, about 5 years ago, found out that I have the gene connected to macular degeneration. Which is a disease that my grandmother also had to go through, and I watched her go through, where she just basically slowly lost her vision. And I, unfortunately, will likely have that as well. So I introduced last time the concept of pre-disabled and talked about how I very much consider myself pre-disabled, but pre-disabled being anyone who doesn't have a disability now, but will very likely, due to age or maybe an accident later in the future, will have one. So, yeah, I started to kind of really dive into that. I watched my grandmother use a lot of technology to help her get through day-to-day stuff. And I realized I'm in a very unique position at being a developer and having this knowledge.
This is personal now.
It is very personal, yeah. And it just kind of fell into that. It kind of was around the time that I had moved from iOS to React Native as well. And I noticed no one was really talking about it. There wasn't really a lot of discussion. So, yeah, kind of jumped right in.
Yeah, so it's cool because it's very important, as you said.
Yeah. So your talk tomorrow is about accessibility. I don't want to spoil your talk like fully before the tomorrow, but I want to talk more about animations. This is like my part of the job. You're using Reanimated, right, at Shopify?
Absolutely.
And do you use the newest APIs like CSS animations? Maybe what's the pro tips for using animations in apps and different APIs that you would recommend or not?
Yeah, so we are using Animated 4.3, I believe, and haven't actually used CSS animations yet. It's been kind of something that I got confirmation that we've been playing with it, but we haven't actually moved anything onto production yet. Now, our app is a little bit interesting because we do love to add delight to our app, and that's kind of the main reason for a lot of our animations. But it's also an app that people need to be, it's point of sale. So it's when you're at a retail store, people are needing to like check out quickly. So they don't want a lot of time to be spent on animations as well. So our animations are usually quick. They're usually fast. They usually need to be something that provides enough information or enough knowledge to kind of get through and not get stuck. So a lot of our apps or a lot of our animations are very critically added to our animation or to our app itself. So yeah.
So you're saying like less animations is better than too many animations in an app like Shopify?
I will say like there's a certain level of like you want something to be smooth and you want something to be reliable, and there's a perceived speed as well. And so just being aware of that. So we do have a lot of animations in there, but just making sure that they're intentionally there and not just there for the sake of being there. They're very intentional. Now, something like our shop app, which is much more of a consumer-based app, definitely has lots of animations. They have really good fun with it. I wish we could have as much fun with that. But we do have to have, because people are not paying attention to their screen when they're tapping in and they're with a customer, right? So it does change things a little bit.
Any examples, like layout animations, maybe something gesture-driven or...
Yeah, so we definitely have like a swipe to delete animation in our cart, like when you add a product to the cart that you want to get rid of. We even have a new like kind of panel that slides in from the bottom. We have an animation when you pin in. So we have you have a pinned in user. So when you're like tapping those pins, and then there's an animation to see whether or not it's gone through or not gone through. So yeah, we do have like quite a number of animations, gesture, I mean, some of the functions are like sequence with timing, like spring animations with the usually entering, exiting animations. Yeah.
I'm just going to pull that thread just a little bit more.
Please do.
So at Shopify, either designers create the animations, like think about animations, or this is the part of the developers to think where to add an animation or not.
They're definitely designer driven. But our developers will often understand where the limitations are and what we can do at a certain speed and how we can play with things. What's really neat is that we do try to do back and forth quite a bit with our designers. So we'll map something out and they can tweak it, or they can ask for certain tweaks. We'll do like polish reviews on those animations. But yeah, so it's definitely, I would say, designer driven, developer like finalized.
Makes perfect sense.
Yeah.
Cool. Maybe so let's talk about very popular topic right now, AI. So as we're talking about accessibility in not so obvious parts, like accessible labels, okay, but animation is not so popular right now. So what would you say how AI is doing right now in this part?
Yeah, this is a really good question. Now, I will say accessibility on web, it's got pretty well. Unfortunately, I mean, AI is like trained on web, so it knows that quite a lot more, and it tries to pull in a lot of those patterns and ideologies from web and translate them into React Native, and that doesn't always work as well. Mobile accessibility is just not quite talked about, and React Native even less so. So you kind of got multiple layers of that. Also, like, AI is just something that is still, or not AI, sorry, accessibility is just something that's still considered optional for AI. If you think about a lot of the tutorials and examples that you see on the web, all of them don't include accessibility. So for AI reading that, they're going, oh yeah, accessibility is an add-on. So you really have to ask for accessibility to be added in.
That's actually weird, because I think for agents it would be simpler for them, rather than make screenshots all over the place, just use the accessibility tags, but that's not always the case.
No, and I mean, I wish it was. I wish it was something. I think EDE testing that's driven based off of accessibility means you're going to have very strong accessibility, and I prefer it. But I think now with like a lot of the like different agent drivers and whatnot, you're not necessarily getting that maybe as much. But there is a lot of improvement, and I'm happy to be talking to anybody who wants to do something along those lines. So give me a shout out. Yeah, come talk to me.
So I have a curveball for you. What's the most obscure bug you ever had in Shopify accessibility?
I think I kind of have two that come to mind really quickly. One of them is a bug, and one of them is one that we just maybe didn't quite think of in the right way. And the first one would be like when you have a banner, sometimes a common practice is to put a banner in where you have like an is visible tag and whether that's visible. Now, unfortunately, that is still accessible to the accessibility tree. So it will still say that banner regardless if that banner is visible or not. And that was something that caught us off guard. And so it depends on how the programmer, how the developer actually builds that banner out. And so there was an interesting couple of patterns that people had introduced that were causing that, where we were getting these no internet banners when in fact they were, they weren't visible to the human eye. They were just visible to the accessibility tree.
So something transparent for people are not very transparent to computers.
Yes.
So the visual UI doesn't always represent the accessibility UI, right? So you do want to try to make sure those are the same. And that's actually why I don't love accessibility label as much. I know it's been pushed quite a bit where people are trying to add accessibility labels everywhere, but it actually decouples that visual UI and the accessibility UI because it overwrites what's visually there. So unless you really need it, I usually don't recommend adding it. Sometimes it's good as a quick way to hide something else. So I actually find a great example actually is that the slide to delete animation. You can use a label to actually hide the delete that would happen. When you slide and you see often the word delete that appears, that's visually there. It's just hidden. And so it's a good way to kind of hide those things. But yeah. Do you want the other weird, obscure? Do we have time for the other weird, obscure?
Yeah, sure. Go
on. So this one's more of something that it didn't occur to us at the time when we were building it. It's almost like a UX style bug more than an accessibility bug. But at the beginning of when you're new to a screen, usually a screen user will just have the screen read to them from top to bottom. But when you're comfortable with the screen, you don't do that. And we had actually changed our pin pad to include a submit button because you could have anywhere from, instead of the 4 pin values, we would do up to 6. And so we added this new submit button. And so one of our users was blind and was adding in their 4-digit, and it didn't change screens, and they couldn't figure out why. And it's because, it's because we added that new submit button, which was visual, but it was something that we hadn't actually announced. So we realized that afterwards. We made the conscious decision to make sure it was there visually the whole time. So if anyone was new looking at it, but because they were so used to the app, they didn't even think to read that screen because they were so used to that experience. So that was something that was a little bit of a hard, fast, we had to...
So TalkBack just completely ignores that part of the app. Completely. The TalkBack.
The TalkBack? Well, so it doesn't, the thing is you have to tell if something is appearing or changing or is new UI, you kind of have to let your users know because they aren't going to know.
Yeah.
And it was something that we were very aware that we didn't want it to be an appearing button because that's a problem with appearing buttons. I'll be talking about that tomorrow. So we had it already in there, and it was just the submit button was disabled until the moment that you actually finished your pin or had at least 4 numbers in there. But if they were just never aware that new button existed because we hadn't ever said oh, now there's a submit button. So yeah, that was something that took a bit of time.
Difficult.
Yeah, it's more of a UX problem, but it's part of accessibility too, right? Some things are just about the accessibility, is more about the UX than the actual bug itself. So.
Yeah, but also it sounds really tricky because these are bugs that you can't actually see.
Correct. Yeah. And it's just having to get your mindset into that. And we couldn't have caught this one because anyone who is looking at it fresh, so there's a bunch of different services you can get where someone will go through with a screen reader, but they would, of course, not have caught it because they would have scanned the whole screen before interacting with the screen and known the submit button is there. It was our power users who were used to this, who have used that screen over and over and over again, that we caught them off guard, and they ended up needing someone who had some more visual experience that could say, oh, actually, there's a new button here you have to click. So it was not ideal.
So before we wrap up, I will give you a couple of seconds to pitch to the audience why they should or shouldn't come to your talk.
I mean, what can you say? I feel accessibility, I think everyone kind of figured out accessibility with the EAA or the European Accessibility Act last year. And But I think a lot of people took shortcuts to make sure that they hit those deadlines. And I recognize that. It's definitely something that if accessibility was new to you, you probably learned a lot in a very short period of time. But people didn't always get a chance to do some of the more fun parts of that. And that's animations, right? Like, I love animations. There's a reason you put animations in an app. So why is the default turning them off? And so I'm kind of giving you some ways to kind of interact with that and make sure that those animations are still accessible so that you can also continue to delight people with even when they have certain settings turned on. So yeah, hopefully that's enough of a pitch, but come see me.
Awesome.
I feel encouraged. Thank you, Rita, very much for being here with us. And we'll be back again during lunch break, so see you there.
Bye.
Thank you.
Thanks so much, Rita, for coming.
React Native Reanimated is an open source library that lets you create fluid and beautiful animations in React Native apps. With more than 6 million monthly downloads, it is one of the most trusted libraries in the ecosystem. And today, we have a huge announcement for you. We wanted to empower developers to create even more delightful, smooth, and easy to maintain animations that are way closer to what you already know from web development. And so, that's how Reanimated 4 was born. We took the best parts of CSS animations and CSS transitions and brought them to React Native, making Reanimated 4 completely different, but at the same time, instantly familiar. So let's see how it works.
The CSS animations and transitions make it easier to create complex animations with just a few lines of code. With CSS transitions, you can effortlessly create animations based on the React state. CSS animations, on the other hand, let you describe the behavior of animation step by step with familiar keyframes. But don't worry, you don't have to rewrite any of your existing animations. Worklets, shared values, and layout animations aren't going anywhere. They still remain a go-to choice for gesture-driven animations and animations that rely on the platform-native integration. We are fully committed to both evolve and maintain all these APIs with the focus on the new architecture.
In 2020, Reanimated 2 introduced worklets, a way to run JavaScript functions on a separate JavaScript runtime, executed synchronously on the UI thread. It was a game changer for animations and interactions. It made it possible to respond immediately to touch events and update the UI on the same frame of the user interaction, providing a truly native feeling. Simply put, offloading high-priority tasks to the UI thread leads to better performance and user experience. Since their inception, the community has discovered all kinds of new use cases for worklets, like camera frame processing, high-performance canvas rendering, and synchronous text formatting. Worklets became the powerhouse behind Reanimated 3 and 4. But now, they are becoming a fully fledged separate library. Meet React Native Worklets, which brings multithreading to React Native beyond just animations. Right now, we're overhauling the core internals while maintaining existing stable APIs, like Run on JS, Run on UI, Create Worklet Runtime, in a backwards compatible fashion. However, expect even richer API for multithreading really soon. You'll be able to offload the JavaScript thread by moving your heavy computation, data fetching, and processing to a background thread. Also, you will finally be able to run third-party libraries on a worklet runtime. We can't wait to see what you're going to build with React Native Worklets.
Extracting worklets to a separate package is just the first step towards modularizing Reanimated. Not all applications use all of Reanimated's features.
Take, for example, use animated sensor. Even if your app doesn't actively use sensors, the code related to them still contributes to the overall bundle size. This is especially important on the web, where every kilobyte counts. So to give you more control of what is shipped to your users, we've decided to break Reanimated into dedicated packages so that you could import the features individually. To support existing projects, the main React Native Reanimated package will continue to provide the full set of APIs to remain compatible with Reanimated 3. And you can expect more optimizations in the future.
With React Native 0.76, the new architecture became default, and we believe it opens door for easier maintenance, faster development, and support for more advanced features in the future. That's why Reanimated 4 works only with the new architecture. And one more thing. Many of you have been asking us about shared element transitions. We haven't dropped the idea. Quite the opposite. We want to make sure we make it right. We are actively working on this feature, and it's going to land in one of upcoming releases of Reanimated 4. So that wraps Reanimated 4. CSS transitions and animations, allowing to create animations easier than ever. Multi-threading capabilities with React Native worklets. Smaller bundle size through modular packages. The new architecture as the way forward. And shared element transition are on the way. We believe that Reanimated is in great hands. Yours. Thanks for sticking with us, pushing the limits, and creating incredible experience with our library. The future looks truly bright, and we can't wait to see what you are going to build next with Reanimated 4.
Running third-party libraries in worklets? It's already there. Say we have a GPU animation using React Native WebGPU. It's great, but it's vulnerable to the JS thread being busy. As you can see, we only have a few frames per second. So let's offload the animation to the UI thread using Run an UI from React Native worklets. We have to wrap our pipeline and also make sure to delegate the cleanup to the UI thread as well. Now we just save, and the animation is smooth back again, even though the JS thread is still on 4 FPS. And it also works with hot reload.
TypeGPU lets you write efficient and visually complex effects entirely in TypeScript. Faster iteration, less boilerplate, same level of control.
The composability that JS callbacks enable is fully at your fingertips.
You can use it standalone or plug it into existing libraries like Free.js or Pixie.js.
You will love the type safety, and your AI will love it too.
Hi, we recently released the Membrane Yellow plugin on HexPM for AI-powered object detection on video streams. Today I will show you a short demo illustrating how easy it is to use. For this demo, I'm using the Membrane Yellow plugin, a few other membrane packages, Boombox and Extra. I will also configure Ortex and Enix to speed up the processing. First, I download a YOLO model exported in Onyx format, along with a JSON file containing the model's class labels. Next, I implement a membrane pipeline with just one callback, handleInit. Here, I will define the components linked within the pipeline. The first component is the membrane camera capture, which grabs the video stream from my computer. Then, I plug an SW scale converter to set the pixel format to RGB. The next element is the YOLO detector from Membrane Yellow plugin. It performs object detection using YOLO Elixir library and adds prediction results to the stream's metadata. To use it, I have to specify the mode and pass the loaded YOLO model. After that, I will plug the YOLO drawer. It draws bounding boxes on the stream based on the results generated by the YOLO detector. The last child in the pipeline is Boombox bin, which I will use to display the stream in the player. Now the pipeline is implemented, so let's run it and see how it works. Let's start the example script. And now you can see me with bounding boxes drawn in real time by Membrane. If you want to know more, visit our Hex docs and check out the examples from the GitHub repo. Give it a try and don't forget to leave a star.
Live Debugger 0.6 is out. Here are the 4 ways it makes debugging easier. Testing your event handlers can often feel pretty cumbersome. You're either stuck clicking through the UI, waiting for a PubSub broadcast, or a background job to fire. Live Debugger lets you skip the setup. You can now craft and inject custom events or messages directly into your live view process. This gives you a way to test your handle info and handle event logic instantly, in total isolation. When a callback crashes, the page usually just disconnects or reloads. To find out why, you have to switch contexts, digging through your terminal logs and scrolling up just to find the stack trace. Live Debugger 0.6 changes that. We now capture the exact exception and its stack trace the moment a callback exits. You can see exactly what went wrong and where right inside the tool. If your app uses temporary assigns, we've got good news for you. Live Debugger now adds full support for them. Now you can verify exactly what data was passed to the render without guessing if it was even there. Finally, we've completely revisited highlighting. It now extends beyond just the nodes tree to cover active live views and streams. Just hover over any item in the tool and we'll instantly spotlight it in the browser. You will never lose track of what you're debugging. Just make sure that you have highlighting option enabled in your settings. From custom messages to cleaner errors, 0.6 is built to keep you in the zone. Try Live Debugger now and stay tuned for more.
Object detection in your app? Easier than you think. We'll be using React Native Executor, a library that lets you run AI models on device with React Native. Let's say you're building a color tracker app. First, initialize the use object detection hook and pick a model. When the user picks a photo, call forward with the image you wrapped. You get back an array of detections with labels and bounding boxes. Just pass those to your app logic. In our case, a color estimator. Let's see it work. Pick a photo and the app will detect what's on the plate. Everything runs on device, no cloud, and fully private. That was easy, wasn't it? Psst. Soon, you'll be able to run detection on live camera feed. Start our GitHub and follow Software Mention for more content like this.
3 months ago, we released the first version of the Elixir language tool, an interactive guide to Elixir that you can use to learn common Elixir concepts and experiment with them using the snippets that are provided here. You can also edit the snippets and run them, and thanks to Popcorn, they all run in your browser. Since then, we've been experimenting with the language tool and Popcorn and did some improvements. In particular, we saw there is quite a lot of happening here, quite a lot of I/O specs, and all the results are aggregated below, which can be confusing. We decided to change the layout of the language tool so it now resembles Livebook. There are small cells that you can run. Everything is a bit more clearer, so we encourage you to play with that, because we also added a new chapter about modules that was possible thanks to improvements to Popcorn and Atom VM. So now you can learn how to define modules, how to define type specs, behaviors, and a lot more. Please try it out and let us know what you think.
Research shows that people prefer apps with well-matched haptics. Good haptics make your app feel premium. Why? Because haptics is like music. Sounds weird, right? But it makes sense if you think about it. Haptics is a vibration, just as sound is a vibration of air. And we all know music can transfer emotion. So haptics can too. Haptics has another thing in common with music. It's hard to compose, and creating custom patterns can be so time-consuming. That's why we created Pulsar, rich and ready-to-use haptic preset library for Swift, Kotlin, and React Native. Presets that you can both feel and hear. Just open Preset Playground, download the Pulsar app from the App Store, connect it to Playground, and now you can feel the haptics in your hand. So you can also hear them even if you don't have your phone with you. With Pulsar, you will find the right preset for every occasion. Do you want to find something gentle that will softly notify a user about new message? Sure. Or maybe you want to warn a user in a bold and rigid way that the security camera has detected a potential threat? With Pulsar, this is easier than ever before. If you are a developer, you know how difficult it is to test haptics when you are on a simulator. Pulsar lets you hear haptics like they are real, even without the hardware. Want more customization? Sure, you can still create custom presets with Pulsar API, or create real-time gesture-based haptics even on Android. Just try Pulsar and feel the difference.
Hi, I'm Krzysztof, creator of SimCam by Software Mention. SimCam is a tool built to solve a real pain point in iOS app development. The simulator simply doesn't support camera testing. With SimCam, you can stream video from your Mac's built-in or external camera, inject an image or video, or generate a QR code without taking the phone out of your pocket. Let's see how it works. SimCam app sits conveniently in the menu bar. To use it, you don't need to change anything in your app. Once SimCam is started, you can open your app on the simulator and navigate to the place where you use the camera. SimCam streams any camera connected to your Mac directly into your simulator, whether that's the built-in camera or any external device. You can also inject any image or video into the camera feed, including auto-generated QR codes, which is great for testing scanning flows. All camera-driven app features work out of the box, like image recognition, face recognition, OCR, QR and barcode scanning, or video conferencing. Finally, SimCam comes with a CLI built for AI agents, so an agent can programmatically switch camera sources or generate QR codes. If you'd like to bring SimCam into your workflow, it's available with a lifetime license. Head over to simcam.swmention.com to get started.
Those of you tuning in online, I hope you managed to get some fresh air. Those of you in the room, I hope you had a wonderful break and had loads of wonderful conversations with one another, and also our sponsors just behind the curtain. How was everyone's break? surprising amount of energy compared to earlier. I will take it. Thank you so much. I'll be looking after you for the next few talks. I'm really, really excited for our first talk straight after the break. William is the creator of Can It Be Done in React Native, the popular YouTube series, and also the maintainer of both React Native WebGPU and Skia. I'm really, really excited for this talk. And so, take it away, William. Yeah. Let's do that. Yeah. Bigger. Yeah. See you in a bit.
When you are here, my heart is raised. When you are here, my heart is raised.
Developers. I hope you are well. William here, presenting from beautiful Krakow, Software Mansion, Expo. Thank you so much for having me today. These are some of the content creators, open source contributors, and indie makers who are pushing the boundaries of what it means to build a great React Native user experience. People like Enzo Mangano, who's here in the audience today. Enzo is known as a React Native Skia expert, and he's recently been experimenting with React Native WebGPU to build new, innovative kinds of renderings. People like the one and only Daeyeon Moon. Daeyeon has built some of the most incredible user experiences using React Native, and he is, in fact, an award-winning React Native developer. People like Iwo Plaza and Konrad Rechko from the TypeGPU team at Software Mansion, who are also here in the audience today. Recently, Ivo and Konrad have been experimenting with Redraw to build this beautiful TypeGPU logo animation. Project Redraw is also using TypeGPU itself. And so here they are using geometry-aware shaders written in TypeScript to build that animation. So, WebGPU, the beloved web standard, and React Native WebGPU was introduced here on stage at App.js. Skia, arguably the world's most advanced 2D library, and we created the library with Christian Falk, who will also be giving a talk tomorrow here on stage. And Redraw, a new grade of 2D primitives. It's a new leap we are making as to say, can we make a contribution to what it means to have state-of-the-art 2D graphic? As you can probably tell already, the opportunities to build user experiences that will create a sense of wonder and delight to your users are rich. This morning, I have an update for every of these projects, and we start with React Native WebGPU. When we got started with React Native WebGPU, one of the goals was to be able to copy-paste a WebGPU example from the web directly onto React Native. It should just work out of the box. And so, for instance, here we are configuring a WebGPU Canva. We copy-paste the example from the web. When you copy-paste the example from the web, there is one big invisible difference. Is that on the web, by default, you run on the presentation thread, And here we run by default on the JavaScript thread. And the way we needed to fix this difference is by adding a new API call, context.present, that lets us notify the UI thread that a frame is ready to be presented. So this line of code here is in React Native only. It's not part of the JavaScript WebGPU standard. We thought, okay, it's not so bad. It's just a tiny line of code to add, but it actually gets much trickier if you use third-party libraries. So for instance, here we use FreeFiber, and you see this crazy onCreating callback here. It's just so we are able to plug in the context.present call within the API. So this is where you see things start to look a bit awkward. And we are refining our understanding on how to do the presentation rendering in WebGPU. And so finally, we are able to remove the context.present. It just works like on the web. We follow the symmetry with the web. And here to React FreeFiber, this is the same. As far as FreeFiber is aware, this is the same as rendering on the web. Now, in React Native, if you want to go from the JavaScript thread to the UI thread, you're going to use an API. You're going to use reanimated worklets. And WebGPU is a bit of a special case because the library is so low level. If you don't bring any of your NPM packages with you, you're not going to go very far. You need to do matrix operations, uniform padding, TypeGPU, FreeJS. If you cannot bring your NPM packages with you on the worklet thread, you're not going to be able to go very far. And the reanimated team at Software Mansion has been working on a new feature, which I'm pretty excited about. It's called bundle mode. And that feature allows you to do just that, to bring your React Native bundle with you in a worklet thread. So let's have a look. Here I have a FreeJS scene running, and you see the little blue square running. The square is running on the JavaScript thread. So if I toggle the make JavaScript thread busy, you see the little square stopped turning around because the thread is not available anymore, but my 3D scene runs nicely. So that's bundle mode. It's an experimental feature. Oops. The way we also integrate it with WebGPU is also somewhat experimental, but these kinds of user experiences are going to become mainstream very soon. So we follow the symmetry with the web, and we see where it leads us. And on the web, people use WebGPU to do video processing. This is what people are doing on the web. And they do it using an API named import external texture. It's an API that allows you to import a camera feed or a video feed, and they do it extremely efficiently. The YUV to RGB conversion is handled on GPU, works everywhere. It's extremely easy on the battery life. This is what people are doing on the web. So that's what we're going to do. Let's have a look. So here I have my React Native WebGPU example app. And I'm going to play a video feed, which I'm going to import into WebGPU. I'm going to do three things. I'm going to apply some shaders to do color effects and color filters. I'm going to do resize the video using a shader. And I'm going to sample the video texture to apply effects like blur or liquid glass material. Let's have a look.
Okay, time for our pregame run-in. Happy fans, happy
So I'm applying color effects here.
Wait, there's no water in these. Excuse me, miss? Yes, Miss Hunter? We asked for hot water, like... Right away. You're welcome. Arrivederci. Goodbye. Okay. Hi, Bobby. Yeah, hi.
So here I'm sampling the texture. The buttons are not an overlay. I'm sampling the texture to build the liquid glass effect.
Just got this!
Sick. I can resize the video.
Late?
50,000
And now I can blur the texture behind to build this beautiful ambient mode effect. That's an effect we'll find on YouTube, for instance.
We'll be there in 3. Oh, I didn't even get to finish my damian! Why do they always interrupt our snacking?
So that's import external texture. Works on iOS and Android. It's done extremely efficiently. The YUV to RGB conversion is done completely on GPU. It's extremely easy on the battery life. We use Dawn, the WebGPU implementation from Google, and they do all of the heavy lifting for us here, including having this supported on Android, which is to have this supported on Android is quite a technical feat. So we're very excited about this. Now, so this is a video feed. We can also import a camera feed. We need a camera feed. What are we going to use? We're going to use, I think, the gold standard React Native Vision camera. And we're going to import the Vision camera feed into React Native WebGPU, and I'm going to do 3 things with it. First, like you saw with the video, I'm going to apply some effects, do some blurring, typical color filters, and so on. Then, I'm going to use to apply machine learning models like TensorFlow.js to do things like face detection. And finally, I'm going to, let's see what the third one is. So here, same story. I have a camera feed with Vision camera, and I can apply typical shader effects, chromatic aberration, blur, you name it. This example is running TensorFlow.js. So I'm loading the model here, and it does face detection automatically. This is a pure JavaScript user experiences. So just like on the web, I'm importing the model, I'm importing TensorFlow.js, and I just integrate it with React Native Vision camera. And for the third demo, I'm going to try to go live. So let's have a look. So I have my phone here. And so this is the React Native WebGPU example app. And I'm going to load the 3GS model. So you see here, the back camera is the background of the image, but the reflection on the helmet is actually the Vision camera. I don't know if you can see my face on the, or you guys can see yourself on the. Isn't that cool? Is Flutter doing this? So that's the integration with React Native Vision camera. And Vision camera implements an API named Native Buffer. It's an API we designed with Mark Rosavi, and the goal was to be able to integrate without statically linking against each other, plug and play between different modules, Vision camera, video, Skia, WebGPU, and so on. And so we can import it directly into React Native WebGPU. When we came up with this design, we encourage people who have an NPM module which does video or camera feeds or native view snapshots to implement this API so it can be integrated at zero cost with WebGPU. And in fact, when we implemented the import external feature, we didn't even have to make any modification to Vision camera. It's plug and play, just works. Now there is another API. So all you've seen so far is read only, and there is another API where you can write into the texture in case you want to do things like video encoding, for instance. Now, when we announced React Native WebGPU here on stage, I was very excited. Oops. The clicker is OK. And I was so excited that I forgot to register the package name on NPM. So I had to name the module React Native WGPU. And I didn't help with the confusion, but so the project name on GitHub was WebGPU. There is a WebGPU implementation which is named WGPU. And there are packages that depend on React Native WGPU which use the WebGPU suffix. So this was a very confusing situation. And so today, React Native WGPU becomes React Native WebGPU. Now, that's a game changer. One of the goals also when we introduced React Native WebGPU was to modernize the Skia, React Native Skia architecture using a new backend of Skia named Skia Graphite, which runs on top of WebGPU. So on Android, instead of using OpenGL, we use Vulkan. We do it through the WebGPU API. And because we have a unified runtime across libraries, we can run libraries like Three.js and Skia together. And we do it, this can be done through two APIs. So you have an API where you can, at zero cost, use a WebGPU texture directly into Skia, and as well bring a Skia image into a WebGPU scene. So here I have a 3D scene built with React Native WebGPU. But now at zero cost, this scene can be part of a 2D Skia scene. So the text layout, the path clipping, the backdrop filter are all done with Skia. So the 2D world and the 3D worlds are composed together at zero cost. So here a similar demo, the text layout, font rendering is done in Skia, but at zero cost because it's a unified runtime, I can use it into a 3D scene. Here another example, so that's our little helmet here, which is done with Three.js. So Three.js is based off class 3D library, but to build the futuristic UI, we use best of class 2D library, which is Skia. So again, here you have Skia and Three.js working together on the same unified runtime. So that's Skia Graphite. And here you can see the little cube. We put it all together. So you have video feed, path rendering. It's all under the same runtime. So Skia Graphite is available under the @next distribution channel. It's still very much experimental. It's a steep migration process. So currently it's completely experimental. We think that in the fall, this will be the recommended user experience for people who start with a new project. And by the end of the year, we hope that Skia Graphite will be a candidate release. That would be React Native Skia version 3.0. Now, we still work, of course, on improving the main React Native Skia trunk. We are working on a couple of improvements. I've picked one for you this morning. So in this demo, we use a feature which is called native view snapshot. So the view that you're seeing are React native views. And we take a snapshot of each view to do this nice transition. And so this is on iOS, works perfectly. But on Android, if you use complex views, so here, for instance, I have a web view, I'm using card elevations, and there are like potentially some complex React Native layouts that you would do, we wouldn't be able to get the exact pixel perfect snapshot on Android. So here, if I run the demo, you see that it actually looks very buggy. So this would only work if you have a really simple user interface between React Native. And so we look at each platform, iOS, Android, web, and we see what are the best practices there, what does the platform gives us, and of course, if there are novelty, we try to leverage them. So on iOS, no problem. On Android, it's extremely buggy to almost, I would say, a point of no repair. And on the web, there is nothing really you can do. So we look at the platform's APIs, and we see if there are novelties we can use to solve our problems. On the web, there is a new API named HTML in Canva. It's an experimental feature. Works only on Google Chrome behind the flag. And this is an incredible API. It solves tons of problems, including the snapshot view API. So this is potentially a solution that can be used. On Android, there is a new API named Hardware Renderer, API level 29 or above, which we can use to get a precise rendering of the native view to ship it to Skia. So here we have the exact same demo, but running on API level 29. And you see now we get the pixel perfect rendering. I have to give a shout out to Kim Brandvik, who pointed me to this new API. Kim is also the maintainer of React Native WebGPU camera, where you can use Kia Graphite and native camera as well as machine learning models to build incredible user experiences. So I recommend you check it out. And I am also coordinating with Gaëtan Renaudot, the maintainer of React Native ViewShot, so we can share the best practices here on how to get the best native views, because this is useful outside Skia. We use it in WebGPU. There are many use cases for it. So we're coordinating together to see how we can share knowledge and integrate together nicely. Skia, c'est un peu le joyau de la couronne. It's the crown jewel of 2D graphics. And when we introduced React Native Skia, we showed an example that looks like this. We draw a path. We have a stroke width and a color. And the stroke width is a number. That's it. And I always, instead of passing a number as a value, I always wanted to pass a function instead. So instead of passing a number, I'm passing a function. That function receives geometric information as parameter. So here you have the context variable, and we can describe a curve. Here we do a sine curve, and you see context.t, it's the arc length of the path. It's a value that goes from 0 to 1. At 0, you are at the beginning of the path. At 1, you are at the end of the path. And you can do a sine wave, and that gives you this beautiful variable stroke along the path. This was my fantasy. Same for colors. Instead of passing a single color or a simple gradient, I always wanted to pass a function. That function receives geometric information as parameter. And so, for instance, here we interpolate a palette of color depending on the arc length of the path. And that gives us this nice gradient along path variable. This was always my fantasy. And this is exactly what Project Redraw is. That's a new project I'm starting, which runs on top of WebGPU, so it integrates at zero cost with libraries like Skia and WebGPU. And you see these use GPU directives on the source code means that these functions are compiled and executed on the GPU using TypeGPU, which is a project from Software Mansion. So the same way Software Mansion came up with a way to execute code on any arbitrary threads with reanimated and worklets, Software Mansion came up with a way to execute and compile TypeScript code to the GPU. And you can use that geometric information, so arc length of the path, distance to the path, tangent to the path, to build any sorts of crazy renderings. So here we build a liquid glass effect, because all the information is available to you. So you can build any sorts of effects. The sky is the limit. So this is still very much experimental, but I set up a playground. You can try the feature, and you can paste any SVG path you would like, and you can, instead of having simple colors and fixed stroke width, you can experiment and build all sorts of interesting effects. There is, so I mentioned stroke width, color along path. There is a third property which are called vector favoring. So you see the blur that you see here is not done using an average of the pixel. It's not done using rasterization. It's computed directly using the vector information. And this has a couple of, okay, so you can build some beautiful glow effects and so on, but it has a couple of interesting implications. First, so if you build a soft shadow user interface such as this one, it's using so many inner shadows and outer shadows that you actually drop frames pretty quickly, because you have to do so much rasterization. But if you build the same user experience where you use a vector blur, so zero rasterization is involved, you will run at full frame rate. So the performance is very, very good. It also enables a couple of use cases I'm pretty excited about. So this is called analytical motion blur. I'm moving the sticker around, and you see it's blurring as I move around, and you have like some chromatic aberration as you go along. Before, you wouldn't be able to do this because you would have to do the rasterization step, and you would have to blur depending on the velocity and the direction of your finger. But here, because everything is computed in a single pass, it's very fast and it works very precisely. So I'd like to go back to the soft shadow example. So this is how the design looks like in Figma. And it's actually pretty crazy. So here for this little button, I have 3 inner shadows. And for each inner shadows, you have tons of parameters. And you have to do this for every element of your design. I don't think these are realistic expectations. I watch tutorials where you see people painstakingly building these designs. Manually, it takes forever. I don't think this sets a realistic expectation for developers and designers. What I believe is that instead, people are going to build flat user interfaces, such as this one, and they're going to set the temperature on how realistic they want the rendering to be. So here the rendering is completely done procedurally. I didn't have to set any shadows myself manually. You just set the temperature on how you want the design to look like. A bit like you would do in a 3D system, but here using the SVG paths you know and love. So that's how it looks like. And that's what I wanted to show you this morning. React Native WebGPU. We're implementing support for camera feeds and videos. It's extremely easy on the battery life. It's done extremely efficiently. Skia Graphite, a unified runtime between Skia and libraries like Three.js. It's a steep migration path, but we're working on it. And Project Redraw, a new grade of 2D primitives, a new leap we are making to build new kinds of 2D primitives. This is our vision for computer graphics in React Native. Thank you, Shopify, and use the community for supporting it. Now, so, hello? Okay. Now I'm not done. There's one more thing. Now, every April 1st, I like to make an April Fool's video. It's always a joke, but I always put a technical nugget within the video. 2 years ago, I made a Binging with Babish parody, where I wanted to build a 3D cake slice using React Native Skia. This was very hard to do because Skia is a 2D library, so it's not really made to do 3D things. And I was incredibly frustrated because I knew that behind the scene, Skia runs on top of 3D APIs. So I knew these 3D APIs existed, I simply couldn't access them. So I was quite frustrated, and this is when it became clear that WebGPU was the way forward. So from a place of fun and silliness, something very serious came out of it, React Native WebGPU. Last year, for April Fools, I wanted to give an homage to the Queen's Gambit series by exploring non-destructive geometries and things like SDF. This was extremely fun to do, but I remember after finishing the video telling myself this was completely useless. This didn't help anyone to build a better app. And then I told myself, well, what would happen if we apply all of that we've learned making the video, all the recipes that we've learned, what happens if we apply it to 2D user interfaces? And the answer to that question is Project Redraw. What you saw with Project Redraw is applying all of these recipes to 2D user interfaces. I like these examples to remind myself that unproductive times never fail to end up being the most productive ones. All of this work is a cycle between making a new leap and massaging the octopus. With React Native WebGPU, this was a new leap we were making, and then after it was time to massage the octopus. Obviously, with Project Redraw, I am making a very big leap. It's a big swing. So I'm going to need to massage the octopus extra long on this one. As I do, I'm going to keep you posted every step of the way. And so indeed, I am looking forward to talk to you soon. And until next time, happy hacking.
William, that talk was so cool. You know what? That talk had everything. The demos were really cool. You know what? Can we just do another round of applause for how ballsy it was to do so many live demos? And they went so good. No, more than that. More than that. Yeah. So good. Yeah, I learned loads. I was watching it backstage. Just really fantastic. And thank you for being such a wonderful audience so far. So, we're going to move on to our next talk now. I'm really excited for this. Jay is the founder of Legend App and CTO at Bravely, but amongst us, amongst friends, amongst the React Native community, he's probably best known for being the maintainer of Legend State and Legend List. Now, the kind of core of this talk, I think, is really interesting. And it's about how many of the best practices, I suppose, that we are taught when building React apps may actually be, I suppose, working against you in some ways and making your applications less performant. Jay's going to be talking about what they are and provide some suggestions on how to overcome those. So I think we're just about there. We just need a couple more moments here. I'm very excited for this talk. You know, I do think as developers, when we first learn something, we often learn the kind of lowest lift way to get into building an application. And then as we become more tenured, more experienced, more senior, we start to look into things like performance and how some of those initial things that we learn aren't always the best at scale. How are we doing over there? Yeah, I need to keep going for a moment. So I didn't actually prepare any stand-up today, but I'm sure you will absolutely love the jokes that I have. Okay, well, you didn't really fill me with a lot of confidence there. That was an effort being made. So, do I have any jokes? Does anyone have any good programming jokes here? Come on. People are thinking. I smell the burning from the cogs turning. Really? Really? Okay, well, I probably should have prepared a few jokes here. Yeah. I am the joke, it seems. But completely fine. I am really excited for this talk and learn how I can build more performant applications. I think we are just about there. Just a moment more, I'm being told in my earpiece here. So my job is to stand here and keep you highly engaged while the next speakers are going. The problem is, I'm not very funny. I'm not very prepared. And we're here. And you do have your eyes on me. We are keeping this going. You're thinking, oh, that was a bit of a bomb there. I am actually thinking about starting stand-up comedy, as it happens. Do you do stand-up comedy? Do you do stand-up comedy over there? What do you do? Oh, you're speaking in a... Do you want to come up here and help fix the technical challenges? Are we ready to go? Have we nailed it? Yeah. Boom. You know what? I'm gonna prepare some wonderful jokes for later. I need you to just give Jay a huge round of applause, and also me for keeping you engaged this long. Somehow. Dude, you're going to absolutely rock this. I'm really excited for it.
Hello, React Native developers. Imagine having to follow William. That was really cool. So here we go. Last year's App.js was my first conference talk ever, and it was so much fun. It's great to be back here. That talk was about Legend List, which was version 1.0.14 at the time. Since then, there's been almost 1,400 commits, and it has over 1 million downloads per month now, which is crazy. Since then, it now supports both React Native and React DOM, so it's now the fastest list library on both mobile and web. It's been super optimized for chat apps and even has this cool anchoring feature that can scroll user messages to the top built in. And now it's on version 3 beta 56. It's even faster than V2. It's more stable. Initial scroll is finally perfect. That was the hardest thing. It supports animated item transition, tons of bugs or fixes. I'm really excited about it, but it's just too many betas. So today I'm changing that. It's 3.0 stable. But that's actually not what I'm here to talk about today. I'm here to talk about performance. My plan for this talk was to cover a bunch of different performance topics, but as I benchmarked them and helped a few companies optimize their apps, I realized that one of these is so much more impactful than everything else, and most apps are doing it the slow way without even knowing it. So we're not doing that at all. Today we're talking about completely rethinking app architecture. I want to talk about making apps that are really fast, not just fast for React Native app, better than native. I worked with Fernando Rojo on animations and list performance for Vercel's V0 iOS app. It's a beautiful AI chat app that just feels incredible to use. When it was announced, people couldn't believe it was React Native because it felt so good. And here's a React Native Mac app I'm working on. This video is me double-clicking the app, and it's fully open and ready instantly. It opens a 10 megabyte markdown file in 20 milliseconds. Let's look at that in slow motion at 5% speed to see how crazy this is. It's actually already fully open, parsed, and rendering rich content before the window is finished opening. For comparison, here's Zed, which is a text editor built in Rust, known for being very fast. It opens the file quickly, but it takes over 4 seconds to parse and syntax highlight. Most other apps I tried either refused to open it, froze, or crashed. So 20 milliseconds is crazy. Here's another app I'm making. It's a React Native Mac MP3 player. It uses less CPU and memory than almost every other music app I tried, even the native Apple Music. These are React Native apps, and they're faster than almost every other app on my computer. They're not just fast relative to Electron WebView apps, they're faster than most native apps. Because React Native macOS is awesome. But mainly, React Native in 2026 is just so good. The game has totally changed. The new architecture unlocks big possibilities. Hermes keeps getting better. Nitro modules are crazy fast. Lists are no longer a bottleneck. As we just saw, redraw makes incredible graphics, easy and fast. Keyboard controller makes keyboard management super smooth. Agent Device and Argent have cut my debugging time down just so much. It's incredible. But still, React Native is seen as a compromise. And that's just not actually true. I've seen and worked on React Native apps that are fully best in class, sometimes better than native apps. I know it's possible. But this year, I've also looked at a lot of code bases for consulting work and helping companies with legend list issues. And I saw the same problems spread all over the place. So I want us to stop fixing these same symptoms over and over, and let's try to fix that root cause. Because React Native is not slow. The way we use it is. If you've seen one of my talks, you may know my catchphrase, render less, less often. But today I want to make it spicier. Render once. But first, why is rendering too much a problem? Everyone talks about reducing renders, but what's the actual impact here? So I did a little benchmark in my music app to compare what if I re-render from the top app all the way down versus in a medium-sized component in the middle down to the bottom, or I just re-render a tiny text element leaf node at the bottom. When that render passes all the way down from the top, it has to do a lot more work along the way, rather than just updating one text element. But it's got to be a small difference, right? No, it's huge. Even I was surprised by this one. Moving the update target from the top-level app down to the tiniest leaf node made a huge difference. It reduced the CPU usage by 10 times. So rendering less has a really deep impact. But React's state model is designed around re-rendering. Render coordinates everything. Render passes local state down the tree. It updates context consumers. It triggers effects. It updates query properties. It updates external properties. It updates subscriptions. And it also updates UI. That's a lot of responsibility for what we call render. And that's where so many normal React patterns become a big performance problem. So let's say we're making a chat app. We have a reply feature that changes the color of a message. That's cool. Re-render the message to update the color. And then you want to also show in the composer that you're replying. So now we need to access the same state in sibling components. So what do? Say it with me. You lift state up. All right, nobody did it. Well, you do what the React docs tell you to do. You lift state up. As the docs say, it's one of the most common things you'll do writing React code. So you move the state up to the top of the tree, and you pass it all the way down. And it re-renders every component all the way down. It re-renders the chat screen. It re-renders the composer with all of its dialogues and buttons and hooks. It re-renders everything down to the message list. And then it re-renders every single chat message. All that one message can change a background color. And this is just killing performance. Now, React Compiler helps a lot, and you should absolutely use it, but it can't save you from actual changes. When prop is changed, it has to pass the state all the way down. Compiler can't help this. So to update a style in one message, we have to cascade state changes through the whole screen. And let's talk about effects. Here's an example from the React docs, controlling a modal dialog. To open a modal on button press, we could just open the modal imperatively, but the React pattern is to set state, which triggers a render, then use an effect to open the modal. It doesn't actually change what renders, but it re-renders anyway. Or maybe I want to pause query polling temporarily. I have to set a state so that I can call the useQuery hook again with different parameters. Setting is paused doesn't actually change what renders, but we have to re-render anyway to update the query. Or I want to mark a chat as read, but only when the window is focused. The useDisFocused hook re-renders when focus state changes, so we have to run it in an effect. That doesn't change what renders, but now this screen re-renders every time focus changes. This is all because render is needed for coordinating things that aren't even rendering. We're wasting all of this computing to just run side effects and move state around. Now let's talk about callbacks. Shout out if you see the problem here. All right, nobody did it. Well, the depths array needs to have a value in it, or this callback will become stale when value changes, and then we'll log a value. We'll log the old value. So you add value to the depths array, and it's fixed. But now onPress changes whenever value changes, and that means this big component also re-renders whenever value changes. You can't easily see this by looking at it. It's a hidden performance problem. I've seen tons of mistakes like this, causing noticeable freezes when some spaghetti path of a state change accidentally re-renders the whole app. This kind of silly mistake can actually have a really deep impact. And finally, let's talk about state. React State is extremely blunt and oversubscribed. UseState doesn't just create state. It also subscribes the current component to that state. That sounds normal, because we're all used to it by now, but it's actually a huge limitation. The owner of the state has to re-render when it changes, and then it's responsible for passing it down to whatever uses it. Ownership and subscription are tied together. Context can be even worse. UseContext doesn't only subscribe to the field you need, it subscribes to the whole context value. Whenever anything in the context value changes, all subscribers re-render. Say you want to get font scale in your custom text element. This will re-render every text element whenever font scale changes. That's not great, but it doesn't happen too often. But that's a trick. You actually subscribe to the window size too. So when a tablet or desktop user resizes the window, every single text element across your whole app re-renders and your app freezes. It doesn't actually need the width here, but use context subscribe to it anyway. So now you have a huge performance problem for no reason. So we know that rendering too much, too often, is a major cause of performance problems. But render is the orchestrator of everything, and React encourages re-rendering often and spreading those renders deep and wide. So that's the model that I want to break. Instead of re-rendering everything everywhere all at once, we render just once. We don't even need to change the framework to do this. We just have to think about state differently and coordinate state separately from render. Currently, render coordinates everything, and state owners push the state down. Instead, let's let consumers update themselves as needed. And all we need for that is stable state objects that you can subscribe to. Some people call these signals, some call them observables. Reanimated calls them shared values. The key thing here is that useObservable does not subscribe to the state. It just creates it. Any other component can useValue it to subscribe to it. This separates the ownership from the subscription. We lift the state ownership up when we need to, but we push state subscription all the way down. So in this example, the chat screen passes these stable state objects that never change, so it never has to re-render. Then this tiny little reply row subscribes to the state that it needs, and it re-renders itself whenever it needs to. It does almost nothing, so the cost of re-rendering that is tiny compared to re-rendering the whole chat screen. So whereas normally the whole app would re-render because the state is owned and subscribed at the top, with this setup, only the affected components re-render. Nothing else is visually changing, so they don't need to re-render, so we can just skip all of it. If a callback needs a state value, it can just get the value. It doesn't need to pass through a render. It doesn't need to be constantly recreated. It can just be a stable function that never changes. An observing effect can just rerun itself when the state it cares about changes. It doesn't need a render to update it. It automatically subscribes to any state it accesses. So we can open a modal without any render coordination and still have the state to track it. Use context is still very useful, but to provide stable state objects. That way the provider never re-renders, and the consumers can select which specific thing to listen to re-render as little as possible. We could also subscribe to derived values. So rather than subscribing to reply ID, which would re-render every single message, it can subscribe to a derived value so that only one reply message actually re-renders. So when I say render once, I don't mean never update. I mean render the app and large coordinating screens once. Let leaf nodes re-render themselves. Let effects rerun themselves. Don't orchestrate through render. This way your apps just do a lot less work. And this is not just a wild theory I have. I've actually been building all of my apps and libraries like this for 10 years. If you use my state library, Legend State, you probably realized a while ago I've just been describing how it works. And this is basically how other frameworks like Solid, Svelte, and Preact work. But it's actually already in React Native. This is how Reanimated works. A shared value is a stable state object. When you get a shared value within an observing hook, it subscribes and updates itself automatically. You can set it anywhere in your code, and it'll update the UI without a render. So we're actually already doing this to get the best performance with animations. And if you use Legend List, you also have this pattern in your app already. This is the main reason Legend List is the fastest list library on mobile and web. It just does less work. It uses less CPU. Legend List mounts a pool of absolutely positioned containers up front, and then it never re-renders that array ever again. It signals individual containers to re-render themselves when needed. So when you scroll down, it signals one container to re-render at a new position with a new item. This keeps the size of renders as small as possible for best scrolling performance. When an item's size changes, which happens quite often, a tiny wrapper component re-renders itself with just a style change and nothing else. When the list size changes, it skips rendering entirely and it updates an animated style. It's not actually animating, but it's more performant than doing a render. These size changes happen very often while you're scrolling as new items come in and you have an estimated size and an actual size. They lay out, you measure. So this happens a lot. It would kill performance if it had to update and render the outer list component with a new size every single time. Legend list is fast because it's extremely careful to do less work. Rendering has a real and significant cost. So for the fastest possible apps, render less often. Or push further, render once. Use React to create the structure, then update the smallest leaf nodes directly. But this isn't just a list hack. This is the model I want you to take back to your apps. So try this today. Well, maybe not today, since we're at a conference. So try this on Monday. The first step is to find what's actually slow. Look at your slowest screens and interactions. Just throw logs everywhere and just see what's rendering so much. Or use the highlight updates feature in the dev tools to just watch renders as they happen, figure out what's going on. Then just try optimizing that screen to see what you can do. This problem can actually be fully solved with a state library. It doesn't need any framework changes. Obviously, I recommend Legend State. I'm not aware of any other state libraries that do all of this, but there are some other signal-style libraries that you can use if you prefer, or just make your own. The key thing is you want to decouple the state creation and subscription, and push the renders down as far as you can to the leaf nodes. I know this is controversial. Everyone has very strong opinions about state. I've gotten a ton of pushback that teams don't want to change their state libraries, or they prefer to just use the built-in state and use context, because that's what React recommends, right? But you already use reanimated instead of the built-in animated because it's better. You dropped style sheet for unistyles or native wind or uniwind. If you still have flat lists in your app somehow, talk to me after this. I hope you're still not using touchable opacity. So why are we still clinging on to the built-in state? Some teams just refuse to use the state library, or you're a library developer and you don't want another dependency. I understand that. So there's also some lower level things you can do to cut out the renders. So instead of this very familiar pattern, try to use the imperative APIs rather than hooks to avoid the re-renders. So instead of re-rendering every time window size changes, you can just get the window size when you need it. And then you can subscribe to it. Missed one. So you can subscribe to it changing and then do whatever you want with it. If you want to pass that through state, cool. If you want to send it to post-hog or whatever, it's fine. And if you're a library author, please add an imperative API as well as a hook like Dimensions has. So then you can get the value when you need it. You can use an event listener to hook into it if you want to. You don't need to do a re-render for it. Another pattern I've used is to make hooks take a callback function and return a ref. So then the users can use the ref when they need to get the value. They can pass the ref around. It's a stable object. Or they can just listen to changes with the callback and do whatever they want with it. You can change your callbacks to something like use latest callback or use event callback, which updates them without dependency arrays. And that makes the callbacks stable so they don't cause render cascades down the tree. If you really want to stick with context for some reason, but just not have the terrible performance problems that come with it, you could use something like use context selector. It still re-renders on every change, but at least it lets you select only the small piece you care about. But these are mostly small fixes to the symptoms. The deepest impact we can get is from rethinking state at a higher level. High-level orchestrating components should never re-render. They should own the state but not subscribe to it. Re-renders should be pushed down to the leaf nodes. I know this is a departure from normal React patterns, but in my experience, it really does make apps a lot faster, and I think it's worth a try. I really believe state architecture is by far the biggest hidden bottleneck in most apps, so you should really care about it and optimize the bananas out of it. And I care so much about this, I built a whole state and sync library because it was the only way to get the best performance. This architecture, in my opinion, is how you get from fast for React Native to really fast. Render once. Thank you.
Thank you so much for that wonderful talk. Okay, so I do actually... is anyone else in here called Kevin, by the way? Wonderful. I don't need to ruin anyone's day. If anyone tuning in online is also called Kevin, I'm going to ruin your day. So I live in Germany. I'm British, but I live in Germany. And you know how some names have those, you know, fair or unfair connotations attached to them, right? I'm sure we can all think of a couple of those. So I'm walking down the street, lived in Germany a couple of years at this point, and there's a big billboard, forgot the name of the company, but their line is, "So easy, even Kevin could do it." I'm thinking that's a little bit odd. Walking with my friend, I say, "Hey, what's that about? What's that about? Is it?" I felt like it was some weird targeted regional advertising. He just turns to me and goes, "Oh, no one's told you." Turns out Kevin is a name in Germany, my country of residence, which basically means you're an absolute fool, an absolute idiot, a jester. And now I have to live with that every single day. Fortunately, my German isn't that amazing, so I can just fully lean into it, you know. We already are struggling a little bit to communicate. Let me just go one step further and be a fool as well. So, if you are any Kevins in the audience, just consider this before you move to Germany. Unlike me, who had been judged for a couple of years before realizing that had ever happened. So I asked my mum, I told my mum this, by the way, she was highly amused. I said, why did you name me Kevin? Like, you know, what is the origin of my name? You are going to absolutely love this. This is a absolutely true story. I am named after ex-WWE wrestler Kevin the Diesel Nash, obviously. Yeah, right? I embody the image. Are we good over there?
Sure. Yeah,
we're good.
I'm good to go.
There?
Yeah.
I do also have a story about a middle name of mine, but that'll have to wait. Perttu is Senior Developer Advocate at RevenueCat. Thank you. at RevenueCat. He's been shipping React Native applications to production for over 6 years with apps that have reached millions of users. I'm really interested in the topic of this talk, which I think is, you know, what a lot of companies are currently running the numbers on, which is when we have AI agents that can rewrite entire code bases. Is the React Native promise of build once, deploy everywhere even still relevant? Can we give a huge 10 out of 10 round of applause for Perttu? 10 out of 10. That isn't 10 out of 10. Better. Thank you.
Thank you. All right, let's get started. So earlier this year, I was slightly frustrated with React Native. I've been building my own app and porting it to Android. I had a working iOS version, and I just could not get the ripple animation to work at all. So I tweeted this thing, that AI is going to kill React Native just because it's so damn hard to get ripple animation to work, and it's actually easier to just port your Swift UI app to Kotlin. And I thought no one would notice it. It's just someone ranting a little bit. But it actually got quite a lot of reactions. So like 600 likes, 77 comments. And people were, of course, like on both sides. You can see that a lot of people really loved it. It was like, React Native's going to die. Fuck yeah. And a lot of people were like, you're wrong. You're absolutely wrong. You should resign. And I personally love this one, which was like, actually, you should die. Because, and I love it that it's like, not just by any means, but by actually AI killing you. And I don't know if in Rocco's Basilisk, if you've heard of that, developer advocates aren't really that high on the list of things that, or people that AI will kill. Maybe they should, at least according to this guy. So that, of course, was a joke, but there was a little bit of a truth in that I tweeted. So previously, before that, like a few weeks before, I was meeting a customer in San Francisco, and they had actually been acquired previous year. They were making like $12 million a month. They were all good. They only had an iOS app, and that was the Swift UI app that they had built, and they were considering moving to React Native in order to have Android and iOS and not having to support two different platforms with two different code bases. And I asked, like, how is that going? Like, probably pretty well. And the guy goes, actually, we scrapped that completely. We just took one of our Swift UI developers and asked him to convert it to Kotlin using Claude. And I was very surprised because that was like, how is that faster, easier, or even produces better results in any way? So also, I love that the AI keeps making me more handsome in every one of these pictures that I'm actually on stage. But that got me thinking that AI is kind of changing the architecture trade-offs that we've gotten used to in the past 10 years. So when we previously would choose React Native, because it gave us multi-platform very easily, it allowed us to iterate really fast and deliver quickly doing that. We could have smaller teams and ship faster. And now, AI kind of makes all of these completely useless. We can also do all of these with AI. So I did an experiment. I took a Swift UI app that I had built, and then I made a React Native version of that. And then I converted the Swift UI app into Kotlin, so that I would end up with 4 apps, 1 React Native app for 2 platforms, and a Kotlin, and a Swift UI app, and see which one of those routes is faster, better, produces better results. And before I get into the experiment, just to talk a little about who I am actually here. So my name is Perttu Lähteenlahti. I'm a developer advocate at RevenueCat, where I have the coolest job. I get to help developers make more money. Sometimes that means hanging by the booth, handing out swag like this morning, or giving talks. This one is from React Conf, I think. Or it means going to an ice fishing competition, because that's, for some reason, what Swift developers really like doing when they go to a conference in up north. But yeah, so that's what I do. I love my job, and I get to build apps on the side. So this was the app that I had originally built, called SEO Console. Allowed me to look into my Google Search Console traffic, built in Swift UI, had a pretty good native UI feel, and that meant that if I wanted to port it to Android, I would also want it to feel like an Android app. So it would have to make use of Material Design 3, and on iOS, it would have to use, of course, Liquid Class, and have native features like widgets, and then consistent and nice-looking charts, because charts are the main thing that I keep looking at. And my experiment was, or the hypothesis was, that AI will dramatically reduce the implementation cost across all stacks. So it doesn't really matter what stack you're using, be that Swift UI or React Native, the implementation will be cheaper. But at the same time, as you gain that, you will lose on coordination, consistency, and maintenance costs. So, as I said, I took the app, I replicated in React Native and Kotlin to see which one of these 2 routes worked the best. And what I measured was that I used Claude's session start and session end hooks to get how many tokens I'm using, how many prompts did it take to implement a feature or to convert the full app, and then just the raw time of doing all of this, which then gave me, for example, the time to functional app as a metric. And the parity, like I could compare like how close are the apps actually to the spec that I had. The iteration speed, so how many versions did I need to make in order to get the feature to a state that it actually required. And then last but not least, I looked at how much of the code got duplicated. So if you look at, here we have all 4 apps. And I'm just going to ask, like, who thinks this is the Swift UI app? Just like the one on the right here. Just raise your hand if you think that's the Swift UI app. Okay, 2 people, cool. And how many people think that this one is the Kotlin app? Like 3 people? All right. Well, if we zoom in on the inconsistency, we see multiple ones. So there's actually, the first one is actually Swift UI app, not a React Native app. So React Native handles, for example, wrapping the text way better for some reason. But you can see that there was a bunch of things, even when I ended up at the finalized app, that I still needed to tweak. And this ended up taking a surprising lot of time to go back and forth. And the Kotlin app, for example, it never really got to a stage where it was actually good. Like, for example, in React Native, the fonts and everything was good on the first try. On Kotlin, despite multiple times asking it, like, no, it needs to match the design that I have for that platform, and I gave it like actual designs, it just wouldn't get there. This could be part of me not understanding Kotlin as well, but also just the fact that AI doesn't have enough context, enough learning material to actually produce good Material UI 3 code. And in React Native's case, I know that it doesn't have that, but it still produced better results in most cases. So if we look at the results, it took like 3 times more tokens, 8 times more prompts, and almost a double the amount of time to get to a state by converting to a finalized app state by converting the Kotlin, the SwiftUI app to Kotlin than it took, for example, to just take the React Native app and do the same thing. And this is quite a like, of course, we can reduce the token count, the prompt count, by using better prompts, using MCPs, skills, and just like token reducing methods. And even in the age of like token maxing, the token count doesn't really matter. But what matters, it is the more time that it took to do these things. And no matter what I did when I added skills, it didn't really come down from this. And there's a few different reasons for that. So I poured these like results into 3 insights. So as I said, it took more prompts and time to convert to Kotlin than it just building in React Native to 2 platforms at the same time. You could get like 80% done in a weekend, but then like I spent almost a week just fixing stuff here and there on the Kotlin version that it would actually have those things that all the other things had. And it was just generally more faster. And there's a funny thing, like last week I was listening to React Native Radio podcast, and they had actually encountered the exact same problem. So they said that at Infinite Red, they had been trying to build the same app in React Native, and then did the same in Kotlin, or I'm not sure what native language they used. Maybe they used Java, but I'm guessing it was Kotlin. And they ended up the same result. It took like 20%, the remaining 20% ended up taking way more time. So that was an interesting learning, because I thought that it would be very simple to just convert, because it's just from one syntax to another. Who cares? AI shouldn't. The second one, like boilerplate, it's practically free. So, and that meant that like getting to states where the app actually like functioned and looked good, that was essentially free. And I got there very quickly. But then the polishing part, doing the bug fixes, coordinating that the bug is fixed on one platform and also on the other, that started accumulating, actually costing way more time. So even though, like in React Native, we have a single lane, and that usually produces like 2 apps. In SwiftUI and Kotlin, when they were separate apps, I ended up spending a lot of time in the polishing phase, because things just didn't feel right. They didn't feel good. And if there was a bug, I would usually have to fix it on both. Although, of course, in React Native's case, usually you have the opposite way around. So if you have a bug on iOS, it usually happens on Android as well. So it was a bit of a weird thing, but it was not as consistent as you would have guessed. A third insight, like since code is now very cheap and we don't really have to care about how quickly we're creating something, the fact that React Native allows us to write once was always kind of a side effect and doesn't really matter anymore. It was a nice perk while it lasted, but the true power of any framework is the fact that you have to only think once, like at least most of the time when you're implementing anything with it. In my app, there were multiple times where I had to go back and reference the SwiftUI code in order to understand if the Kotlin code was working better. And this happened a lot when working with time series data, which I have a lot because there's charts. And the charts ended up being all over the place. And this is one exact case where it really didn't work. But that's kind of the point where you end up losing a lot of time, despite having AI that easily produces you the code. And because my experiment was quite lightweight, I wanted to pull in also some industry data. So we at RevenueCAD, every year, we publish a report called the State of Subscription Apps. And we collect the data from last year's apps that use our SDK to monetize their apps. So for example, this year's report is from last year's data. So it already includes the so-called AI wave of apps. And that data set has 115,000 apps, SwiftUI, Kotlin, React Native, Flutter, everything. And we track all of those, how much money those are making, how are they performing in those cases. And they make $16 billion in revenue. So we're counting a lot of dollars. So I first wanted to know that what are actually people choosing when they want to build apps that monetize very well? Because if it's now easy to convert from one syntax to another, shouldn't that mean that we're starting to see like React Native lose? Because previously it was doing pretty well. And it actually turns out that React Native still wins in almost every possible way. So download to paid is 25% higher than, for example, download to paid on Swift UI, which is the top leader in that. So that means that React Native apps, when users download them, they are more likely to make money than same app built in native. The same thing happens when you revenue per install. Every install that you get brings in more money than any other platform, and 55% higher than the next contender is very high. And also, you could explain two of these away by saying that React Native apps use shady tactics to get users to subscribe in the beginning. But also, if you look at the long-term payer value, so after a year, when users been a subscriber, how much money are you making with that app? React Native still holds in that. And wins pretty significant degree. And you could, of course, say that, okay, React Native probably unlocks all of those things, and that's why people are using it. But I think it's the opposite way around. So people who actually want to build good apps that monetize well, that users love using, they end up choosing React Native because they get there way easier, way better. If you want to take a look at the report yourself, you can scan the QR code and you can find it from there, but it's also on our website. So why choose React Native now? When previously we would have multi-platform, faster iteration, smaller teams ship faster as the core things, we now have complexity, coordination, consistency, and still shipping faster. Complexity is that you still end up with, there's less complexity with React Native with the two apps. And since AI doesn't reduce complexity, actually, in my case, it ended up multiplying it multiple times, forcing me to go back and forth, look at the code. It doesn't really solve that. So you would still be better off choosing React Native if you want to reduce the complexity. Another thing is the coordination between platforms. It was way easier, and it still is way easier to just work on two platforms from a single code base. And then there's, of course, consistency. So key product features that are not user-facing are way easier to coordinate in React Native than anything else, and which is also one of the reasons why it probably tells you why those apps are monetizing so well. So when you can add analytics, AP testing, monetization in a single code base and control everything from there, you don't end up coming to problems where you're missing, for example, an important analytics event, and that's why you don't understand what the users on Android are doing. Another part is the fact that iOS and Android, those don't make up a multi-platform solution. So as apps are just interfaces to your service, you kind of need the web as well. And it usually ends up being the biggest one you have. And I was looking at the schedule, and there's actually going to be a talk that I'm personally going to see, but probably you have to. Edwin Warrior's talk on one code base to 3 platforms, which kind of sounds that it kind of touches on this pretty well. So if I want to conclude this thing, the real measure of a framework is not the lines of codes or lines of codes that you ship or the tokens in any way. It is the shipped features that count. And if we go back to the customer, it's now 4 months later, they still have not shipped the app. And I'm pretty sure they would have been able to do that with React Native in that time. I'm going to have an article version of this talk with all the data and whatnot, probably tomorrow. I don't know if I have time to post it today on my blog, so you can take a look at it there. Thank you.
Fascinating talk. Thank you so much for it, Perttu, and also thanks for challenging some of our assumptions. I think a lot of us are seeing the hype machine online and starting to draw our own conclusions around the role of AI in the projects that we build. Right, so does anyone here have any irrational fears? Love this interactive audience. I do have an irrational fear, and I can't explain why, because I understand it's irrational, and it's chickens. It's chickens. An ex of mine had 5 chickens in a coop at the bottom of the garden. They always paid their rent on time, delicious eggs. But then when they're broody and they're sitting on their eggs, you have to kind of move them off because they're good to eat and take them. Otherwise, they'll starve themselves to death. So you need to. It turns out I'm terrified of them. I opened the coop. My partner was away at the time. And I just all I had to do was move this chicken here and pick up a couple of eggs. And we stared each other down for over an hour. I was late to a work call, and I had to explain that, I feel like I'm done with this story now. Anyway, I'll get to the end of it, which is this chicken and I, we just stare at each other, and even though I'm told this chicken will not move until you move it, and you have to move it or she'll starve, in the end, she just looked at me and just moved out of the way, like pitied me enough to just go, you know what, I'm done. I'm done with this. That's a true story. Yeah. Still scared of them.
I believe you.
Still scared of them. Kraen is a developer experience engineer at ElevenLabs, where he spends time helping developers integrate voice AI into their applications. I am a user of the SDKs there, which you work on. Prior to that, he worked for 7 years on Realm, which is a mobile-first database that was later acquired by MongoDB, which I also use. So I've used a ton of your work in the past. Thank you so much for joining us. And yeah, this is a talk about how the ElevenLabs SDKs were re-architected. So I'm going to give you the floor. Huge round of applause, please.
Thank you so much. Great. So my name is Kraen Hansen, and I work as this developer experience engineer at ElevenLabs. And I basically help build SDKs and docs to help you build with agents. And this talk is about re-architecting the ElevenAgents SDK for React Native. So the premise of the talk, I'm going to center it around this concept of context rod. And you might think you know what I'm talking about in the agentic sense. That's not what I'm talking about. I'm talking about the OG context rod, the React context rod. Yeah. The clicker went out. No, it's good. 2 seconds. I just need to do one thing here. Good. So I want to teach you, I guess it's a fairly simple concept, but I want to teach you how to spot it and how we fixed it, and also how it's just one boring pattern, I guess, that you can use throughout. And I think it links back a bit to Jay's talk earlier. Maybe you can see mine as like a subset talk oriented around context and re-rendering performance there. I'm doing something wrong here. Okay, cool. So just a very quick refresher for people that, I mean, you know context, but just we have this context that we're creating, and we have the possibility of multiple, like we use a provider here. We can provide the count value into the context provider, and we can consume the context. And this subscribes to the changes for the context. So each of these label and display components, they re-render when the context changes. And if you want to contain the re-rendering, you might be tempted to use memorization, but the key takeaway here is that even if you memorize and you don't re-render based on the props changing from the outside of the component, so to speak, if you're subscribing to context within your component, you will still re-render. Okay, so my journey into the architecture here started as I was onboarding. I started at ElevenLabs this January, and in November this was created by a community member, which is super encouraged. I was really happy to see this, not to see that there was performance issues on React Native, but that this was surfaced. The analysis was that the provider had too much state, which would cause renders or re-renders of the children. And this is not entirely correct, or at least that's my takeaway, is that in fact the problem was we were using a single monolithic context for a lot of different things, a lot of different state, and subscribing to that throughout all the sub hooks and APIs that we provided. So the main thing was actually that we needed to, instead of using a single context for each of the APIs that we exposed, we should use something else. But let's see. I want to just try with a toy example here, a simplified version of the issue. I have a simulated mode here, simulated volume. These are states that change on an interval. The volume changes more frequently than the mode, and we have a status here, disconnected status, and we're passing that in just as a value for the consumers. and this is just the app wrapping that. And we show 3 panels here for showing it. So this is what you see when you render it. You can see that the volume panel is frequently updating. The state of the speaking, listening here is actually changing much less frequently, but you do see the rendering all the time, right? So that's the key takeaway here. And also the status here, which is actually not changing, is still re-rendering. It's a problem. So the solution one solution would be to use a state management library, like Jay said and talked about. Another solution here is to basically split up the context and separate context, one context per concern. And this is what the solution that we went for. So in this case, we have still the state at the provider level, so we are not changing that, but we are changing the fact that now we are memorizing these context values, and we are passing them into individual context providers for the underlying children to consume. This app code didn't change. And what we're seeing now is the volume panel is only re-rendering when it's supposed to, and the listening speaking here is also only changing when it's supposed to. So this is the toy example that I wanted to show. So going from that insight and having that instinct, I wanted to see, this is like a meta point, I guess, is like I wanted to see what is a good developer experience for the future of our SDK. So we have a client package, which is this procedural API that Jay also wanted to have exposed from an underlying library. So it's not React specific, it's just a JavaScript API with like procedural non-declarative APIs, not hooks and stuff like that. And I wanted to see how would the ideal developer experience be. So we have this agent test bench, which is a Vite project within our monorepo structure. And I just started implementing the hooks in this, not inside the library that I would eventually build, but inside the test bench itself. And the reason for that is it served as a prototype that I could also use. It was an incomplete prototype. It had bugs and it had a lot of other stuff, but it had like the API surface that I wanted to envision. And I used that for a coding agent to come up with a better plan that was rooted in both the existing implementation and then in the test bench prototype. So this is a way to build with agents that I really like. Prototyping something that's not really working and then using that as context for the real thing. Good. So this is more similar to what you saw before, but now in the actual, it's not taking directly from the code in the SDK, but now we are separating status mode. Controls is more, these are like never changing at all, but we still want to pass them down, so it has its own context. Yeah. And these are the hooks that the API provides. Status message like, is it connected or not? If there was an error, what is the error? Is the agent speaking? Is it listening? Yeah, conversation controls, as I said, starting, ending the session, muting, and looking if your microphone is muted. All these different. And then there's an escape hatch that you can use to get the raw conversation to access the procedural API if you really want to. By the way, this the callback pattern, like these client tools are functions in your app that you can expose to the agent. I'm also going to show that later. And this is using the same pattern that Jay also talked about, where this callback doesn't take dependency arrays, but it just always uses the latest version of the callback. Yeah. Another pattern that came out of that is basically, now we have a lot of providers and we want to be able to render each of them, and it grows into like provider tree hell. I don't know what the name of that is, but where you have like a long tree of providers. And this is one way of like reducing that burden. Maybe there's a better idiomatic. If you know a better way to do this, I would love to know. But it's basically just a list of providers that we are rendering in turn. Yeah. Cool. So what we ended up with is this idiomatic, the imperative call which is a JavaScript library. It's not React specific. It works on web. It works on React Native. It's architected in a way where the code that is common only uses the language features. And then we have the hooks library, or the React library on top, hooks and providers, which is more platform agnostic. And then we have the React Native SDK. It used to be a separate implementation from the React package, but now we could basically just re-export the React package and do some small platform-specific injection for audio handling, which was platform-specific for React Native. And the benefit of that was we also got React Native Web for free, because we were just not injecting that when we were on web, and it was the same API being exposed from the React package as from the React Native package. Okay, so now we're going to do something a little more, this can go horribly wrong, but I want to show how this looks in the actual SDK. So I'm trying to see here if
Mic check 1 2. All right, I'm live, I'm wired, and I am bored.
Can you hear me?
Oh, I can hear you crystal clear. You're coming through loud and proud. What's on your mind?
Okay, so we're doing the demo now. We're live. Can you show me just doing some background work?
Let me pull that up real quick.
Okay, cool. Can you do a joke?
All right, here's one for you. Why don't programmers like nature? Because it has too many bugs and not enough documentation. Boom! Thank you, I'll be here all conference.
Okay, fair enough. Let's try some more help. Anyways. Thank you. Live demo. Okay. So in the end, this was the before state of the how you would consume our SDKs on React Native on the left side and React on the other side. And this confused coding agents, right? It's kind of like, I want to use the ElevenAgents SDK, but it was like there was two different ways of doing that depending on if it was React or React Native. This is not good. On the React Native side, it had a provider, and on the React side, it did not. It was just a hook with no provider. So it basically this is what it turned into on the React Native side, and this is what it turned into on the React side. It's the exact same thing. Good. So to help with that upgrade, because these are breaking changes to the way that you consume the API, we also expose a skill that you can install and then just do /ElevenLabs SDK migration. I think that's a really neat way. Like, we've done code mods before. It's brittle. It's very hard to do in a way. You can spend so much time debugging those depending on the different tools that people are using or the different styles of code that they're doing. So I think it's really hard to maintain. I think a skill for upgrading is much more capable, and we have customers doing like one-shot upgrading their implementations of against the new major version. So I think that's a pretty cool pattern that you can also repeat. So finally, one context per concern. I'm pretty sure this is also in the React docs, but I don't know who reads docs nowadays. It's this boring pattern that you really should try to use if you can. And especially when you have performance issues around your context use. This was it for me. I encourage you to scan this one. This is going to give you a 1-month creator plan, if you want to, for the platform. I think it's really fun to just try out. So that was it for me.
Do it. I'll just do it. My beer.
Thank you so much for that talk, and both congratulations, but also low bar for your AI agent getting more laughs than me. So yeah, thanks for that. So we've just had 4 fantastic talks. Thank you to all of our speakers in this block, and that means we're. Hey, wasn't so, where's Nathaniel? Isn't he meant to be here? Okay, all right, whatever. Anyway, lunch is now. There are vegetarian and vegan options. You can get that outside and in the restaurant. Okay, all right. I suppose I'll have to do this next bit. It's fine. During the break, for people who are interested, they're going to stay here, or folks online, there's going to be a couple of those interview sessions happening, Perttu and Alex, so they should be really good. You should check in on that note. Where's Nathaniel? Has anyone seen Nathaniel? I swear he was right behind me. Whatever. Anyway, I think, yeah. Oh, hello. Yeah. So yeah, for lunch there's vegetarian and vegan options. You can find those. You can find those outside. And where's my boy at? Oh, dude, I swear you were right behind me.
I'm so sorry. Beer. There's beer for lunch. So I thought I'd sneak away, skip the lines, and just start early.
It's a good thing we're friends.
Yes, yeah. And look, there's a bunch of people who are already at home enjoying the conference from their sofas. So I thought, why not indulge? And it's pretty cool up here. There's beer, there's coffee. I will say, Expo and Software Mansion, they're smart. They sat right next to their sponsor booth, right next to the beer. Good choice. But maybe in the break you could come find me, and also folks at home, have a beer. Enjoy it.
See you after lunch.
Hello again, welcome in live studio. It's Susan Kacper again with our second guest, Perttu Lähteenlahti, a senior developer advocate at RevenueCAD. Hello.
Hello, that was very good.
Thank you very much. I was practicing. Yeah, so starting our conversation, I want to talk a little bit about your journey because it's quite unusual. So you started as a carpenter and then finished up as a software developer.
No, there was like few little stops. Like I started with carpentry, then I was like, this isn't really my thing, so I went into cognitive neuroscience. Then I was like, this isn't really my thing. I'm going to be a UI designer. I founded a few companies. I worked in finance, and I was like, no, engineering is the thing. I think I'm going to go back to that. And then I ended up as a developer advocate after doing engineering for like 10 years. Yeah.
Okay, but it's about creating.
It's always been about creating. Yeah. It's building something, getting out to people, and figuring out that the thing you built was wrong, and going back and doing it again.
Cool.
You just had a talk, which you nailed it, by the way. Congratulations.
Oh, yeah.
But let's just reiterate, and could you add what is RevenueCAD actually, what it does, and just in a couple of sentences, explain it.
Sure. A couple of sentences. Well, we're the monetization layer to iOS, Android, and web. So we make it very easy for you to collect in-app purchases, subscriptions, get users to pay for those. And then we make it so that you can actually boost those numbers up. So we provide paywalls, experimentation, A/B testing, all of those things, so that you don't have to like spend a lot of time building that infrastructure and logic yourself, but you can just get it directly from us, and you can actually focus on building the features.
So we also have, you just said paywalls. What makes the paywalls so good? Why shouldn't I just like build it myself? I think they are way better because I use RevenueCAD myself, but what's your idea on it?
I don't think there's a perfect paywall. There's only paywalls that have been experimented and figured out that this one works for the user. So it's all about the experimentation. And what we do with the paywalls, for example, is that you can build them in the dashboard that we have, either using AI or just using the drag and drop designer that we have. And then you can deploy them without having to make a new release of your app at all. So you can just like make multiple paywalls. You can put them to test which one of them actually works.
Like over the year, updated the paywall.
Yes, different customer groups. That's that. Okay, we have like the new users. They get a different paywall. Let's put half of them trying this paywall, which actually talks about benefits instead of features. You get the numbers that, okay, this one converts better, gets more users paying, and you can of course put different products. You can put like, okay, this paywall we're just showing the monthly subscription, and this one we're showing both the monthly and a yearly and a trial as well, and you can test out which one of those works. So we make that very easy so that you don't have to spend time figuring out how to wire all of that together to get the same features.
And by default they are compliant with all the Apple and
completely yes.
Yeah, makes sense.
Our job is to understand how the in-app purchase ecosystem works. So we follow closely what Apple and Google, when they say that, okay, don't do this, and we're like, we guide the customers, then we don't allow you to do that. Or if you're not allowed to do that, then we tell you that, hey, there's a caveat. You have to actually pay attention that this is not allowed. Good example is, for example, exit offers. So you show one paywall, and user decides that, okay, I don't want to subscribe here. And then you show another one right after that that says, hey, actually, if you now subscribe, you get also 50% off. That one might be allowed in some cases, but if you go like a completely different subscription price, Apple, for example, doesn't like that. And we tell you that, hey, don't try this, but try, for example, instead the trial offer, like a longer trial or something like that.
Makes sense.
Cool, yeah. Really helpful. So speaking about a setup, how would you describe setting RevenueCat in, for example, my React Native app? Is it super easy? I can do it just myself, or maybe you have some skills to do it?
Yeah.
You know,
AI?
Yeah. I'd say that it's very easy. If you go the traditional route, the artisanal route of writing it yourself, it's import purchases from React Native purchases, and then call initialize, and that's it. Then you can decide if you want to show your paywall or our paywall. Both of those require only a few lines of code. But the easiest setup is actually just go to our website, and it gives you like, do this in Claude, and that does all of it. We have a pretty good position that we've been on the market long enough, and we've produced a lot of content on how to set up RevenueCat, that if you just ask like, how do I monetize my app from any agent, they're just going to be like, well, I'm just going to throw in RevenueCat and set it up for you. They don't even consider any other options. So.
It's true.
I have that problem in the app that I'm privately working on. I'm using RevenueCat, by the way. That my customers are buying stuff, but they immediately cancel the subscription. Do you have any tips for making that not happen so I make more money?
So I'm guessing based on that, you probably have a very short trial length, like 3 days, 7 days, or something like that.
Yeah.
We actually have a report that we collect every year of the subscription app data, and that works as a pretty good source of like what works on the market, what converts, and what gets people to continue being subscribers. And one of the results from this year, for example, was that longer trial lengths convert way better. So, for example, if you used to have 3-day, go to 7-day trial, and if you have a 7-day, go all the way up to 14. Actually, the most performant trial length was like beyond 14 days. That usually meant that people would stay subscribed for longer. But with trials, there's of course the thing that like the reason why people subscribe very early is, or unsubscribe very early, is because they're used to like forgetting and then ending up paying for something that they didn't want to use. So if you want to like make this feature or make the, let's say, experience way better for the customer, what you should do is you should have like this something called the Blinky style paywall. So you have this timeline on your paywall that says that, okay, day 0, you unlock all the features. Day 5, we send you a notification that in 2 days your trial will convert. And then you tell that in 7 days your trial converts to a paid and you pay. That gets people to stay because they're like, okay, you've now given me the confidence that you'll notify me if my subscription is going to like turn into a paid one. And they're like, okay, then I don't have to unsubscribe immediately. I can just continue using, and you'll let me know when I like need to take an action if I need to.
The notification part, is this something that RevenueCut does for you, or this is something that I have to build myself?
You mean identification as like for who these are?
The notification, like your trial is ending in 3 days. This is something that you handle, or?
Yes, like we have our webhook infrastructure. We don't have notifications in the SDK, at least not yet. So you would still have to plug in your own notification system and have, for example, one signal running that accepts like payloads from our webhooks. And then, like, based on those notifies. I've also quite recently written an article how to do this, so you could also do it with, like, local first notifications. So as soon as the user subscribe, you just save the subscription period and the trial length, and you deduct 2 days, for example, and do that with completely local notifications if you want. But you can also do it with server notifications, because we have very powerful webhooks.
Cool. So I wanted to ask, what do you think personally these days when we have all this vibe coding stuff?
Yeah.
So is it easier to make a profitable app because you can do it faster with AI and stuff? Or maybe is it harder because it's an overload in stores?
I'd say that it's easier to make the app. But looking at, for example, the state of subscription apps data from last year, the market is definitely splitting between winners and losers. So we have like the winners. There's not really like a middle ground of apps that's making like somewhat money. There's actually like apps that barely make anything, and then apps that make a lot of money. And vibe coding brings you very easily to the side of like the apps that make very little money. And that's actually the thing, is like getting there to the stage where you actually start making money is not really about the technology itself. It's about the, like actually experimenting, like which pricing works, which monetization model works, and also which features work. So the faster you can deploy stuff to the users and test those things out, the more certain you are that you're going to win and get to the winners category. That's what we've seen in most cases, that as long as you keep shipping features as often as possible. And I think that's also like one of the places where like React Native and Expo really like outshines every other, is because like if you now make a Swift UI app and you submit a new version of that app, because there's such an influx of new apps, like I think beginning of the year it was massive amount. You could notice in the review times, and I think they still haven't really recovered. It takes like 1 to 2 days almost for Apple to review, sometimes even longer. If you want to get features and bug fixes out faster, you could use something like Expo Application Services, and that's no longer a problem. You're getting good stuff, high fidelity stuff in the hands of users way faster. They're going to be more willing to pay for your app because they feel like you're actually providing a service.
Mr. Apple can be sometimes a bit effy if you change the whole app over the air. Yes. So don't overdo it, but you can ship some features over the air. That's true,
what we say as well. Because with our paywalls, because they're fully customizable from the web, what you can do is this so-called soft paywall versus hard paywall. And there's an interesting metric that hard paywalls, so paywalls that you show the users right in the beginning as you start using the app, and they won't allow, like what it means is that you won't be allowed to use the app unless you pay. That's a hard paywall. And then you have a soft paywall, which you can use like a subset of the features of the app, but it keeps showing you paywall every now and then. Those two perform very interestingly and very differently. Soft paywalls actually lose to hard paywalls. So if you have a hard paywall, that converts to paying customers way better. So if you're building a new app, that's probably where you should start. And then at the same time, they actually, both of them, when you look at them after a year, they pretty much retain the same amount of customers. So it's more like, do you want like acquire users that are paying really fast, or you just want to keep the same amount? Doesn't really matter. The thing is, you can't change between these two paywall types. Like, even though we allow it, Apple doesn't like it. So if you start with a soft paywall and you switch it to hard paywall, what happens is that you told in your app description in App Store, for example, that, hey, you unlock all of these things, and they open the app and suddenly they can't pay. Apple will contact you. They will pull your app and say that.
It's not very nice of you to do that.
So be careful also what you do in those cases. Yeah.
So carry on the Apple subject, because my app doesn't have like any physical features, no cameras, no Bluetooth, not so on. I'm just using simulator for my development, but the payments on simulators aren't that great.
No.
Why? Why is that? It's not a revenue cat fault. I've read the documentation, but I have to use physical devices for development because of payments.
Yeah, trust me, if we could fix that, we would have. So you have either two ways. You could either add the StoreKit configuration file, which makes it a little bit easier to actually test your app on a simulator or test your purchases on a simulator, but that still doesn't work in most cases. And that's because the Apple sandbox testing on simulators is quite broken. And they don't really have a reason also to fix it, probably, because eventually you still have to test it on a real device. And you would always test it on a real device before you ship it to review, for example, because anything can go wrong. And if you have, for example, subscriptions, Apple will take a very thorough look at those. And if your subscription fails for any reason, they will just reject your app for that reason. And even if your app was completely functional and had freemium features that you could still use, they will just, because you couldn't purchase, they will block it. So.
Is this better on Android? Is Android as, not bad, but as strict as iPhones?
Yeah, I would say that Android emulators is more like a full store experience. So usually you can test it quite well. The problem is that setup to get like RevenueCat and App Store connected, that's very easy. It barely takes you any time. But then on Google Play, you have the opposite problem. Like, it's very easy to test the subscriptions on emulators and do test subscriptions and whatnot, but it's very difficult to connect these two places because Google has made the whole Google Cloud Console plus Google Play Console sort of very complicated. For example, when you submit to get the API keys, it might take you 48 hours before the API keys just start working. So there's like, you win and lose on both sides a little bit.
It can't be too easy.
Yeah.
Okay, so maybe to wrap up our conversation, do you have any advice you can give to maybe some young visionaries that want to create a very profitable app so they can become rich?
All right.
That question, very open question.
Yeah, I know, but I've actually thought about this a lot. So when you're using, like, because of AI, code is very cheap now, and it's cheap enough that you can actually start to target niches that weren't targeted before. So we, for example, seen revenue customers build very specialized apps for very small group of users, and are able to monetize there. Like previously that would have taken like days, weeks, whatever to build that app. And that's just like, if you spent that much time building it, it's not very cost efficient to then put like a $5 subscription per month. It's never going to pay back for you if your customer, like total addressable market of your customer segment is like 100 people. It's going to take a lot of work at least. But the thing is, like when you start with a small market and you can start very cheap, you can actually grow from there. You target those customers like, you know what? Actually, these people might benefit from it as well. And that's where the domain knowledge comes into play. So if you're building the app yourself, go really dive really deep into a topic where you're trying to like solve a problem and see like, has anyone else solved that? And then based on that, start building the app. Or get a co-founder who actually knows that. That's also a good combination, that you have a co-founder who really knows. Like if you're building software for teachers, start working with a teacher. Like, what do you actually need? Like, I've seen people build like a whiteboard copy app, for example, during COVID times, and sell it 4 months after to what is this company, Kahoot, for example, because no one else was just targeting teachers, and Kahoot was like, we need that. So
just make something people want, right?
Exactly. Yeah, the YC motto, works in this case as well.
Thanks so much, Perttu, for coming.
Thank you.
Senior developer advocate at RevenueCat. Thank you so much.
Thank you.
It was amazing.
Nice talking to you.
A good developer fixes bugs. A great one designs systems that don't fail. In-app purchases, those were critical, so you need eyes on every moving part. I built unique flows for every purchase state, not to mention a custom entitlement API for grace periods and family sharing. If a subscription expires, I have custom logic to grant temporary entitlements based on the user's unique cohort. That's weird. No. I rebuilt this entire system and my code never breaks.
Today's apps ship faster than ever. AA is writing most of the code, but the test didn't keep up because no QA team can move that fast. For that, you need a tester army. So we built one. AA agents that test your web and mobile apps in a real browser or a simulator using natural language. Try it at tester.army.
Mobile tests aren't handwritten anymore. Now agents write them. Maestro speaks YAML. With Maestro MCP, your coding agent inspects your apps, writes the test, and runs it on a device. And when something breaks, your agent fixes it. Tests heal themselves. Trusted by the world's top mobile teams, works with every coding agent. Start now at maestro.dev.
Hello everyone, welcome back again at Live Studio, long time no see. Now with our next guest, Alex Volochnev, a principal senior advocate at CodeRabbit. Welcome.
Thank you. Pleasure to be here. Wonderful.
Thank you for being with us. So I wanted to start with a question about your description, because I read that you describe yourself as IT exorcist. What does it mean?
That means really a lot to me. So, you see, I work in software development in IT for definitely over 20 years. I actually don't remember already. I wrote my first program in 1992. And in this time...
That's crazy, actually.
Yeah. So in this time, I did very different jobs in IT, including like technical support and software development and leading technical software development, all those things. After very many years, I realized that what the thing I really want to do and what is like the most important for me to do is to have us developers deliver better software for the users, but keeping it in the way what's convenient for us, for developers. So developer experience and user experience and reliability, all those things. Now I saw in my life, especially in my times in technical leadership, what biggest problem, usually all the biggest problem, they are coming not from technologies, not from software we are using, not from databases we are running, but from misunderstandings, miscommunications, the way how people talk and communicate with each other, the way how people use the tools, and so on and so forth. And we do it not because we are bad. Usually, like most of the developers I ever knew wanted to do their job well. They just didn't know something or misunderstood something and so on. So when it came up as a joke, of course, I told those misconcepts, mistakes as demons I want to expel. Not demons like in the Linux world, but demons like misunderstandings. And so I want to get rid of them. And that became this IT exorcist joke when I made my LinkedIn job title.
Cool, I get it now.
Yeah, so I want to steer the conversation into the company you work at currently, CodeRabbit. It's a platform, right? So it's more than just an LLM wrapper, but I want to ask you, what's the value added of CodeRabbit instead of using just, I don't know, prompting an AI agent to review my code? What does CodeRabbit do? That's my question, basically.
That's a very good question. So, biggest thing, biggest project, biggest feature what CodeRabbit is known for is code review, mostly pull request code review. And there is an incredible job happening behind, under the hood in the background, what is invisible to user. So to user it looks like I create a pull request. After some minutes there is a review with some warnings raised. Because we want developer experience to be very, very good. But there is an incredible amount of work happening behind. So there is a sandbox for each run, where is checkout for this branch, then merging, then running dozens, actually by now over 50 different tools to identify possible mistakes. Including there is a connection to your issue trackers, there is a connection to external tools using MCP tools. So the truth is, in 2026, there are plenty of great LLMs. Like absolutely epic. I enjoy working with Opus 4.7, for example. It's a great tool. So now the real difficulty in working with any AI is building right context. It shouldn't be too big, it shouldn't be too small, it should be just right. And then CodeRabbit begins to work. The first phase of work, maybe the most important one, is not the review. Review begins significantly later. First part of job is to get the right context. So, for example, maybe your pull request is wonderful and have no bugs. That happens rarely, but that happens sometime. But what's the purpose of it if it doesn't resolve a problem was described in the issue? There is no purpose in merging that. So one of the very important things is checking how it closes the requirements given in GitHub ticket or in Jira issue, linear issue, using all the external connections. Also, analyzing not only change set, because very many review tools or very many in-house tools people develop because problem exists for everyone, they focus on change set. That's wrong. Your change set might be wonderful. Your change set may be even perfect, but then outer tool using that will be broken because you have some backward incompatibility, which presents no problem here, but will present in other things. So we want to merge code and see all the changing stack on how it affects everything in this repository. And then we need to go deeper, because we're service-oriented and microservices and front-ends, back-ends, and so on and so forth. So also a lot of work happening if you have linked repositories for multi-repo analysis. So seeing not only what happens here, but also what will happen with a repository, what will be a consumer for this repository, what you are changing. So, yeah, biggest part of work is to build proper context based on the data we can access, and to everyone using CodeRabbit or developing their own in-house solution, I'm not jealous. Do the proper job gathering context. It's much harder than it looks in the beginning.
So it looks simple for the end user, but you actually hide a lot of complexity with this platform. That's very nice.
Yes, and I believe that's how it should be. So yes, it's highly configurable, but in general, experience should be as simple as possible, of course.
Cool. And what made you join CodeRabbit? Was it like the idea of the company, or maybe a feature that you liked?
So actually, I joined CodeRabbit, we can say, at first as a user. So I develop open source since, I don't remember, 2012, and contribute a lot to the open source, to different projects and to my own projects and some other projects. People were writing suboptimal code, all the history of human civilization, well, software development civilization, to say so. But with appearance of AI, it became worse. Much worse. So, and reviewing, I didn't want to review it all before it's really checked. Amount of contributed slop was tremendously high. I began to use CodeRabbit as a best code review tool I found back then as a user. And then my friends who knew me from my previous job in DataStax and Killer Code invited me to join for a conference in Berlin. It was DroidCon 2025. So I joined it, and then eventually they invited me to join. So I didn't find the company. Well, I find the company as a user, and then company found me as a contributor. Yeah.
Cool. And the next question is quite open. So what do you think will be the future of quality code? Will be developers still reviewing the code on some point, or maybe is it improving AI reviewers?
That's painful topic. So the truth is, there is always will be someone testing your product, and there always will be someone reviewing your product. Or you do it yourself, or you do it with AI, but you need to do it and set it up, or your users will do it for you. And then complain and write on Twitter angry posts. So, what very, very important, and I can sign this as my official petition, as my official statement. AI code review should not and will not, never, literally never, replace human review. And I say it as an employee of the AI code review company. And everyone in CodeRabbit will sign this, because we know, yes, CodeRabbit is to simplify things, is to make things faster, better, to catch most important things as quickly as possible in few minutes after pull request is created. So developer who made it immediately receives feedback, doesn't have to wait for hours or days or weeks. I saw pull requests and open source waiting for initial feedback for months. It hurts.
It happens, yeah.
Yeah, like I worked a lot with Apache Software Foundation, and for some projects it can be months, if not more. So CodeRabbit gives you a chance to see the first review within minutes, not hours, not days, not months. That is important, but there always will be need for human judgment, and no way any AI can replace it. And I know there are companies currently exist just write some code with LLM and throw it to production without basically any review, passing tests, okay, throw it where their users will test it for them, and their users will be very happy.
There's a very good joke that unit tests on Titanic were all passing, but the Titanic still sunk.
Yeah. So, no, testing is a separate question, but yeah, that's a very important point. What reputation is such a thing, what in the beginning you lose it drop by drop and you don't notice that. And then later you eventually just wake up one day and no one wants to use your product anymore. So you need to use AI review, and very strictly, but also you need to use human review. And if you don't, well, you will regret it eventually.
So I guess we can organize it to have a place for both of these reviews.
We definitely need to have both in the pipeline, yes, absolutely.
So this is also a question of responsibility. Who is responsible when the code breaks in production? If you delegate too much to the agent, who's taking the blame for breaking AI? I don't think so. What do you think so?
Yeah. So I keep telling about that. Guns don't kill people. Guns don't kill people, people kill people. And don't blame the gun on that. Blame there is always someone who made a decision. For example, someone who made a decision just merge everything without human review. Usually someone from management. But, well, it's easier to blame some engineers who should have coded up somehow, although they've been told not to review and just throw everything on production after AI review. And that's a system problem. What our SDLC, software development lifecycle, was not designed for AI. It was designed for people, only human teams, and it's not a thing anymore, but we're still trying to... So we got a jetpack, or I don't know, rocket, but we are trying to to manage it like a horse with reins. And it gives strange results because, well, reins are not for rockets, right? You need some better tools. And we want these. We want to keep looking for ways to improve those processes. Essential part of this improvement of SDLC, is what you are talking about, is ownership. Before each so how was it? Some product manager creates a Jira ticket, then some developer gets assigned it, developer implements solution, throws a pull request, then someone's getting assigned it as a reviews, manages. We always can track those things from bottom to the top using git blame, using all our things. So we always know who implemented, who asked for the change, who reviewed. We always know whom to blame. every disaster has first name, last name, and job title. Now it's not a thing anymore, because if you open like CodeRabbit repositories, you will see what 80–90% of pull requests are done by CodeRabbit agent. And why did this thing? Why this pull request was created? You can track it. What someone in Slack asked for such change. But that's basically what we have. When is this person on Slack who requested the change, he should take responsibility for implementation? No, it can be a product person, marketing person, whatever, product design person who has nothing to do with the code, and the idea could have been just perfect. Agent is never responsible for the change. Human is always responsible for the change. My approach for that currently is what each and every person, each and every part of a project needs to have ownership. So some designated owner who has responsibility and need to review all the changes going there, yes, but also, and that management loves to forget about, they need to have power to say no. So, no, that's not how we do it. We will not merge with bullshit.
On the topic of management, well, because all over the place, all over the world, now the employees are getting told that they are now an AI native company. And I don't know what that means, but I would like to ask, how can we accelerate the adoption of AI in our companies? This is something that we should help, or just, I don't know, buying an AI subscription, it's enough to give Claude or, I don't know, anything else to an employee, and it will figure it out. What's your take on it?
I'm thinking maybe we should not accelerate the speed.
Okay.
If you should not accelerate if you don't have brakes.
Okay, that's a take.
So yes, there is a time. Like you see, the problem is, I believe that there is a huge problem in basically all the businesses. What people are rushing so much for numbers, for salaries, for income, for profits, because it's all very like looking into the capitalization and the income. So we forget what we are creating tools for people. And I'm not a CEO or anything. I'm an engineer and I'm a human and I'm using products. And I see what basically all the products are using now break much more often than they were breaking before. GitHub got outage, how many this year? Like we are tightly connected with GitHub, so I see like all of them.
I think twice this week.
Yeah, precisely. How much was it last year?
Less, because it didn't break the news?
Yeah, last year we had less than in last 2 weeks. You see the problem. So,
do you think it's AI? Or
so, obviously, I don't have confidential information.
Sure,
even if I would have, I wouldn't share. So we at CodeRabbit, we watch very, 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 very attentively all the major public outages, and we very much investigating on our side as much as it's possible based on the public information and some internal knowledge on what we can, on why could it happen. So companies public their reports on how it happens, some don't. Some information we have. Very, very, very many cases definitely connected to AI. But look above, guns don't kill people. It's not the problem what AI writes with bugs, because AI is not responsible for anything. It's our problem and our mistake what we are shipping the bugs. We are shipping those bugs. We are to blame. So as I talked at the recent meetup in Krakow, the drunken on AI speed. People got drunk and people rush to deploy and adopt and just do everything with AI, accelerating, and then on a high speed on Autobahn they realize they don't have brakes and their customers just running to someone who is more stable.
Rockets don't have brakes.
Rockets don't have brakes. That means what we need to use some aero braking or something, like we need to develop something, and we need to make it controllable. Speaking of controllable, now I finally can get to your question. So
AI subscription,
AI subscription is a solution. No, it's not. Sorry. So in very many companies, AI adoption looked like that. So management read what some tool, I don't know to give names, but like any AI assisting development tool is better than all the others. Tomorrow they buy subscription and throw it on the engineers and so that's it. Just use it, guys.
Personally, I was told to use as much and burn as much token as possible, so I did. They ship more? I bet, yeah.
It's absolutely wonderful to burn tokens. Otherwise, how do you learn to use it? So no, overall, it's a very good idea. But that's very important to understand what each project absolutely must have proper SLA. And in 2026, SLA now means not what you think. SLA now means slope level agreement. So slope level agreement is very important, and it's okay to have low, it's okay to have high. You just need to do it consciously and not let some random people or just incident decide for you. You need to make a decision. How long this project is going to exist, and how important is this project? Will someone die? Are you running like a nuclear station reactor, or are you doing it's a student project? And then you want to understand how to execute and how to review and how to test it properly and how much you want to change each and every step of SDLC. But that needs to be a conscious decision. Adoption. People adopted AI in the way like they would be adopting just a new tool. Like they have a new security check tool, I don't know, let's say, random name, git leaks, better leaks appeared. We just downloading it, adding it to our CI/CD pipeline, and it's done. So people did it like they use it to do. That's a huge mistake because AI-assisted coding and now agentic coding, full auto coding, semi-auto coding is not a new tool. It's a principally new way to deliver software. And unfortunately, I don't have a ready answer, one size fits all, just do this, and that. I have to say what we really need to think is that's very new. Like from the first car on the street and the first traffic light on the street, there has been a few decades. I do hope this time we will pass this path a little bit faster. So we need to have traffic lights, and each company needs to decide how we want to do it, but again consciously. And for that, you need to run experiments, and you need to do proper incident investigation. Before you have a bug on production, you know how it happened. Now we need to reinvent the way how we work with the incidents and see, okay, there is a bug on production. How did it went through? Let's open up the whole path and see where we could have coded. Because the problem is now we are running very, very, very fast, much faster than before. People were writing shitty code all the time since existence, but now they can do it 10 times faster. So what you safety level you could afford before, you cannot afford anymore because your previous safety level will just, what was $10 a year will become $100 a year, $1,000 a year, and then all your users will leave you, and they will be very right. Yeah, so we need to stay very, very aware on what we are doing and think. So ownership, we discussed it. And definitely makes sense to revamp and disassemble, reassemble the way how we review everything. So CodeRabbit's answer to that is AI-assisted review, which is important, which is essential, but single-handedly not enough.
Yes. So last question from me. I believe something has changed, like in December last year, on how we write code, build stuff. I would like to ask you, like, a bit open-ended question. Do you think what's the hardest part of software engineering now? Instead of building, it happens. It's easier now. So what's the hardest now?
The hardest part didn't change per se. Hardest part just became a bigger part of developers' reality. The story, as I said already twice today, I believe, people were writing not great code all the time, but now they do it fast. So, and meanwhile, code review is harder. So, reviewing someone else's code, reading someone else's code is harder than writing this code. And that's at first sounds a little bit strange, a little bit like controversial. Why, like, when I write a solution, I need to design this solution. It takes a lot of work. Yes, it takes a lot of work. Pleasant software designing work, which I personally enjoy very much. And this part of a job was taken from me by AI. So best part, most favorite part of the job now is gone. But look, now when we get to review, I need to decompose, reverse engineer, and understand someone else's thinking. And the guy who submit this pull request has actually no idea what's happening in. So now I need to go through all the hallucinations and slope of some changes. Time to first bullshit significantly decrease it.
I love the term.
Yeah, and reviews always were hard, as was it Richie Kernighan who said what debugging is twice harder than writing. So if you write the code at the top of your performance, at the top of your skill, you will be never able to debug it. Part of this problem is what reading code, unknown code, is harder than writing it. So now we need to review much bigger pairs, much more often, and even one who auto-read them has no idea what's happening inside. So this part of job became much bigger, much harder, and that's the irony. What AI promised, make our life better, and instead of that, the best part was taken from us, and worst part got bigger. So, yeah, now ask any senior engineer in a company what heavily uses AI, so basically most of the companies, how many % of your time were review before and how many % of your time is review now. And in most of the cases, this time will be significantly bigger, but there are companies where this time actually will be decreased. Do you think if it's good or bad?
That depends, doesn't it?
As I said in the very beginning, someone is going to review your product. But it can be or you or customer. So if there are companies where seniors, whatever engineers don't review, then the customers will do that for them. No worries.
So thank you very much for joining us. It was a pleasure. And we're seeing each other on the next break later. So
thanks so much, Alex. It was amazing. Thank you.
My pleasure. Thank you for inviting.
React Native Reanimated is an open source library that lets you create fluid and beautiful animations in React Native apps. With more than 6 million monthly downloads, it is one of the most trusted libraries in the ecosystem. And today, we have a huge announcement for you. We wanted to empower developers to create even more delightful, smooth, and easy to maintain animations that are way closer to what you already know from web development. And so, that's how Reanimated 4 was born. We took the best parts of CSS animations and CSS transitions and brought them to React Native, making Reanimated 4 completely different, but at the same time, instantly familiar. So let's see how it works.
The CSS animations and transitions make it easier to create complex animations with just a few lines of code. With CSS transitions, you can effortlessly create animations based on the React state CSS animations, on the other hand, let you describe the behavior of animation step by step with familiar keyframes. But don't worry, you don't have to rewrite any of your existing animations. Worklets, shared values, and layout animations aren't going anywhere. They still remain a go-to choice for gesture-driven animations and animations that rely on the platform-native integration. We are fully committed to both evolve and maintain all these APIs with the focus on the new architecture.
In 2020, Reanimated 2 introduced worklets, a way to run JavaScript functions on a separate JavaScript runtime, executed synchronously on the UI thread. It was a game changer for animations and interactions. It made it possible to respond immediately to touch events and update the UI on the same frame of the user interaction, providing a truly native feeling. Simply put, offloading high-priority tasks to the UI thread leads to better performance and user experience. Since their inception, the community has discovered all kinds of new use cases for worklets, like camera frame processing, high-performant canvas rendering, and synchronous text formatting. Worklets became the powerhouse behind Reanimated 3 and 4. But now, they are becoming a fully fledged separate library. Meet React Native Worklets, which brings multi-threading to React Native beyond just animations. Right now, we're overhauling the core internals while maintaining existing stable APIs, like run on JS, run on UI, create worklet runtime, in a backwards compatible fashion. However, expect even richer API for multi-threading really soon. You'll be able to offload the JavaScript thread by moving your heavy computation, data fetching and processing to a background thread. Also, you will finally be able to run third-party libraries on a worklet runtime. We can't wait to see what you're going to build with React Native Worklets.
Extracting worklets to a separate package is just the first step towards modularizing Reanimated. Not all applications use all of Reanimated's features. Take, for example, Use Animated Sensor. Even if your app doesn't actively use sensors, the code related to them still contributes to the overall bundle size. This is especially important on the web, where every kilobyte counts. So to give you more control of what is shipped to your users, we've decided to break Reanimated into dedicated packages so that you could import the features individually. To support existing projects, the main React Native Reanimated package will continue to provide the full set of APIs to remain compatible with Reanimated 3. And you can expect more optimizations in the future.
With React Native 0.76, the new architecture became default, and we believe it opens door for easier maintenance, faster development, and support for more advanced features in the future. That's why Reanimated 4 works only with the new architecture. And one more thing. Many of you have been asking us about shared element transitions. We haven't dropped the idea. Quite the opposite. We want to make sure we make it right. We are actively working on this feature, and it's going to land in one of upcoming releases of Reanimated 4. So that wraps Reanimated 4. CSS transitions and animations, allowing to create animations easier than ever. Multi-threading capabilities with React Native Worklets. Smaller bundle size through modular packages. The new architecture as the way forward. And shared element transition are on the way. We believe that Reanimated is in great hands. Yours. Thanks for sticking with us, pushing the limits, and creating incredible experience with our library. The future looks truly bright, and we can't wait to see what you are going to build next with Reanimated 4.
Running third-party libraries in worklets? It's already there. Say we have a GPU animation using React Native WebGPU. It's great, but it's vulnerable to the JS thread being busy. As you can see, we only have a few frames per second. So let's offload the animation to the UI thread using run an UI from React Native worklets. We have to wrap our pipeline and also make sure to delegate the cleanup to the UI thread as well. Now we just save, and the animation is smoothed back again, even though the JS thread is still on 4 FPS. And it also works with hot reload.
TypeGPU lets you write efficient and visually complex effects entirely in TypeScript. Faster duration, less boilerplate, same level of control. The composability that JS callbacks enable is fully at your fingertips. You can use it standalone or plug it into existing libraries like Free.js or Pixie.js. You will love the type safety and your AI will love it too.
Hi, we recently released the Membrane Yellow plugin on HexPM for AI-powered object detection on video streams. Today, I will show you a short demo illustrating how easy it is to use. For this demo, I'm using the Membrane Yellow plugin, a few other membrane packages, Boombox and Extra. I will also configure Ortex and Enix to speed up the processing. First, I download a YOLO model exported in Onyx format, along with a JSON file containing the model's class labels. Next, I implement a membrane pipeline with just one callback, handLimit. Here, I will define the components linked within the pipeline. The first component is the membrane camera capture, which grabs the video stream from my computer. Then, I plug an SW scale converter to set the pixel format to RGB. The next element is the YOLO detector from Membrane Yellow plugin. It performs object detection using YOLO Elixir library and adds prediction results to the stream's metadata. To use it, I have to specify the mode and pass the loaded YOLO model. After that, I will plug the YOLO drawer. It draws bounding boxes on the stream based on the results generated by the YOLO detector. The last child in the pipeline is Boombox bin, which I will use to display the stream in the player. Now the pipeline is implemented, so let's run it and see how it works. Let's start the example script. And now you can see me with bounding boxes drawn in real time by Membrane. If you want to know more, visit our Hex docs and check out the examples from the GitHub repo. Give it a try and don't forget to leave a star.
Live Debugger 0.6 is out. Here are the 4 ways it makes debugging easier. Testing your event handlers can often feel pretty cumbersome. You're either stuck clicking through the UI, waiting for a pub-sub broadcast, or a background job to fire. Live Debugger lets you skip the setup. You can now craft and inject custom events or messages directly into your live view process. This gives you a way to test your handle info and handle event logic instantly, in total isolation. When a callback crashes, the page usually just disconnects or reloads. To find out why, you have to switch contexts, digging through your terminal logs and scrolling up just to find the stack trace. Live Debugger 0.6 changes that. We now capture the exact exception and its stack trace the moment a callback exits. You can see exactly what went wrong and where right inside the tool. If your app uses temporary assigns, we've got good news for you. Live Debugger now adds full support for them. Now you can verify exactly what data was passed to the render without guessing if it was even there. Finally, we've completely revisited highlighting. It now extends beyond just the nodes tree to cover active live views and streams. Just hover over any item in the tool and we'll instantly spotlight it in the browser. You will never lose track of what you're debugging. Just make sure that you have highlighting option enabled in your settings. From custom messages to cleaner errors, 0.6 is built to keep you in the zone. Try Live Debugger now and stay tuned for more.
Object detection in your app? Easier than you think. We'll be using React Native Executors, a library that lets you run AI models on device with React Native. Let's say you're building a calorie tracker app. First, initialize the useObjectDetection hook and pick a model. When the user picks a photo, call forward with the image you were at. You get back an array of detections with labels and bounding boxes. Just pass those to your app logic. In our case, a calorie estimator. Let's see it work. Pick a photo, and the app will detect what's on the plate. Everything runs on device, no cloud, and fully private. That was easy, wasn't it? Psst. Soon, you'll be able to run detection on live camera feed. Start our GitHub and follow Software Mention for more content like this.
3 months ago, we released the first version of the Elixir language tool, an interactive guide to Elixir that you can use to learn common Elixir concepts and experiment with them using the snippets that are provided here. You can also edit the snippets and run them, and thanks to Popcorn, they all run in your browser. Since then, we've been experimenting with the language tool and Popcorn and did some improvements. In particular, we saw there is quite a lot of happening here, quite a lot of I/O inspects, and all the results are aggregated below, which can be confusing. We decided to change the layout of the language tool so it now resembles Livebook. There are small cells that you can run. Everything is a bit more clearer, so we encourage you to play with that, because we also added a new chapter about modules that was possible thanks to improvements to Popcorn and Atom VM. So now you can learn how to define modules, how to define time specs, behaviors, and a lot more. Please try it out and let us know what you think.
Research shows that people prefer apps with well-matched haptics. Good haptics make your app feel premium. Why? Because haptics is like music. Sounds weird, right? But it makes sense if you think about it. Haptics is a vibration, just as sound is a vibration of air. And we all know music can transfer emotion. So haptics can too. Haptics has another thing in common with music. It's hard to compose, and creating custom patterns can be so time-consuming. That's why we created Pulsar, rich and ready-to-use haptic preset library for Swift, Kotlin, and React Native. Presets that you can both feel and hear. Just open Preset Playground, download the Pulsar app from the App Store, connect it to Playground, and now you can feel the haptics in your hand. So you can also hear them, even if you don't have your phone with you. With Pulsar, you will find the right preset for every occasion. Do you want to find something gentle that will softly notify a user about new message? Sure. Or maybe you want to warn a user in a bold and rigid way that the security camera has detected a potential threat? With Pulsar, this is easier than ever before. If you are a developer, you know how difficult it is to test haptics when you are on a simulator. Pulsar lets you hear haptics like they are real, even without the hardware. Want more customization? Sure, you can still create custom presets with Pulsar API, or create real-time gesture-based haptics even on Android. Just try Pulsar and feel the difference.
Hi, I'm Krzysztof, creator of SimCam by Software Mention. SimCam is a tool built to solve a real pain point in iOS app development. The simulator simply doesn't support camera testing. With SimCam, you can stream video from your Mac's built-in or external camera, inject an image or video, or generate a QR code without taking the phone out of your pocket. Let's see how it works. SimCam app sits conveniently in the menu bar. To use it, you don't need to change anything in your app. Once SimCam is started, you can open your app on the simulator and navigate to the place where you use the camera. SimCam streams any camera connected to your Mac directly into your simulator, whether that's the built-in camera or any external device. You can also inject any image or video into the camera feed, including auto-generated QR codes, which is great for testing scanning flows. All camera-driven app features work out of the box, like image recognition, face recognition, OCR, QR and barcode scanning, or video conferencing. Finally, SimCam comes with a CLI built for AI agents, so an agent can programmatically switch camera sources or generate QR codes. If you'd like to bring SimCam into your workflow, it's available with a lifetime license. Head over to simcam.swmention.com to get started.
One of the things that I want to tell people is that social connection is important. We all live now in a world where a lot of us work remotely, but there are a lot of things that are baking right now. And coming to a conference is a good way of really getting ahead of the curve. So I definitely recommend properly interacting with people and getting to know the React Native community.
I had a conversation with one developer that was working on something, and I learned a ton about how we could optimize things in my React Native project. I think that's incredible. That access and that community that App.js provides is unparalleled.
Good morning, everyone. It is so good to be back here at App.js 2025.
And you can just feel it. I mean, it's so crazy when we're here because there's so many of these just apps that I use every day. And the author is here. He's talking about like how using React Native has drastically improved their workflow. Exciting time to be an app developer.
All of the engineers that I really admire are here, so it's like a pleasure to learn with them. So yeah, I'm enjoying. It's pretty cool.
Drink. Wait. One more thing. There's one more group of people we need to thank.
Yes.
It's the audience.
The audience, yes. Can you give yourselves a round of applause?
I know.
You're at home.
Hard for your Slavic.
Yeah, a standing ovation for yourselves.
Round of applause.
That is awesome.
All right.
Thank you so much.
Thank you. It's a day of learning, and let's have fun.
There's not enough.
2 hours later.
Hello, everyone. This is the RTC on 2025.
So it's quite retro, it's quite fun. Let's see whether or not we can kind of make it real time. I don't have any backup here.
I felt kind of compelled like to break more stuff and, in the process of trying to make them working. So, yeah.
I build stupid things for people.
I'm doing Elixir for life.
We met the only Elixir developer who's actually paying his bills with Elixir, so it's very impressive.
How do you like the conference?
Very, very interesting stuff. We love Vulkan Video, we love Rust.
Really, really good. It's my first time here.
As a nerd, I have to admit I'm really keen to this mock thing.
We have a strong team of speakers this year. Everyone's very cool.
A lot of topics during the conference that I really enjoyed.
Here it's very cozy. Everyone's very friendly. It's so cool. Anyone who's working in this field should definitely come.
Forget that. I'll start again. I forgot what I said at the beginning. So, productivity.
Elixir is great technology.
Maintainability.
And we just need to...
And readability.
Do a better job of marketing it.
Okay. Well, definitely what I appreciate the most about Elixir is the Elixir community. Boom. Yeah.
Modern people don't really want to go deal with all those curly brackets, and Jose, I think, has done everybody a great favor by enhancing the language and making it much more useful in the modern day. So it's going to be an interesting afternoon to figure out how we apply our resources to things.
So we learned all these hard lessons, building software and failing. And you take those lessons and you learn to value a new set of priorities, right? And Elixir sort of embodies those things that people don't know are important when they're first starting out. When you're first learning to program, the properties that Elixir actually provides, it's difficult to explain why those matter. And so that's one of the things that we've seen, is that it's filled with people who have deep experience, deep nuance and understanding of like what goes into good engineering and how we make software that will stand the test of time.
Folks from Software Mansion reached out. They said, look, we do this kind of summit with React Native. It could be interesting to have that for the Elixir community as well. So it was the perfect moment, the perfect place.
This might be the most unusual React Native workshop you'll ever attend. Why? I work in a villa on a Croatian island. Small groups up to 10 devs.
Led by the people building the tools you already use.
You learn how to build Expo modules and master the entire EAS ecosystem.
Then we'll dive into Reanimated, Gesture Handler, and Worklets.
We cover the new architecture, performance profiling, and JSI, and we'll finish with a consulting day to solve your app real problems.
Sounds good? Book your spot and see you by the pool.
Hello guys, today we are at Software Mansion with Meet.js, and this is meetup focused mainly on JavaScript and front-end development, although we have variety of topics.
We're kind of trying to push the boundary of what's possible on the web. It's always been possible, but we're trying to make it easier than ever.
This meetup is perfect for people to see how their web knowledge can be applied in mobile world.
I love the energy they conveyed in the presentations.
So this is the kind of place where you can do Jolly Slider as a part of your job.
We are at the meetup in Software Mansion office, which is called Build with AI DeepMind Mansion, and this is edition 5. My name is Mateusz Kopciński. I'm the lead software engineer in-house Software Mansion AI team, and we are mostly focused in convincing people that Edge AI is a good idea and that they should consider it in their next product.
I'm Philip. I work here at Software Mansion, and my talk was about the performance on local models. Developers, after my talk, should consider using tools that reduce context use. They should consider either using a sub-agent for gathering this required information or using the dedicated tool. I don't think it was very controversial. Mateusz's talk was very similar and we agreed. So at least in Software Mansion, we have the same mind.
A good developer fixes bugs. A great one designs systems that don't fail. In-app purchases, those were critical, so you need eyes on every moving part. I built unique flows for every purchase state, not to mention a custom entitlement API for grace periods and family sharing. If a subscription expires, I have custom logic to grant temporary entitlements based on the user's unique cohort. That's weird. No. I rebuilt this entire system and my code never breaks.
Today's apps ship faster than ever. AA is writing most of the code, but the test didn't keep up because no QA team can move that fast. For that, you need a tester army. So we built one. AA agents that test your web and mobile apps in a real browser or a simulator using natural language. Try it at tester.army.
Mobile tests aren't handwritten anymore. Now agents write them. Maestro speaks YAML. With Maestro MCP, your coding agent inspects your app, writes the test, and runs it on a device. And when something breaks, your agent fixes it. Tests heal themselves. Trusted by the world's top mobile teams, works with every coding agent. Start now at maestro.dev.
everyone, all in here and those joining us from home. Welcome back to the second half of the first day of App.js Conference. And I'm really excited to continue and be with you on the stage for our next couple of speakers. I've been refueled, I've had my beer, I'm feeling pretty good. Couple of announcements that I do want to just let everyone know. You are very lucky today because you do not just get one after party, you get two. There is going to be an after party hosted tonight by our friends at Code Rabbit. Couple of pieces of information for you to go and make sure you have a great time. The link, which will give you the information on where and how to get there, is on the website. So go onto the website or in the app and find the link, and so you can join in there. And also, it's usually really helpful if you remember to take your badge as well with you when you go. All right, the party will start. But the party here is about to start with more content on the stage. We have another amazing speaker lined up for you today. I love it when I get to meet engineers who don't just do engineering, but they take engineering and they combine it with something that they're passionate about. And our next speaker is an amazing artist and an amazing engineer and has put those things together to really work on helping other engineers build some amazing art and all kinds of stuff. So, here to talk about TypeGPU, I am going to invite Ivo. Can we give him a round of applause?
Hello, everyone. Had a nice lunch break? Very nice. Okay, we're going to wake up a bit as the time goes on. Hey, everyone. I'm so excited to be here. App.js, Software Mansion, and Expo, thank you so much for having me. Before I tell you more about myself and why I'm here, I would like to tell you a story. A story about a React Native developer from an alternate universe. And in that alternate universe, React Native reanimated and worklets, they don't exist. They have never been invented. So that React Native developer goes on about their day, they're building their app, when suddenly their beautiful animations and interactions stutter, giving into tasks with higher priority. It's all running on a single thread, but as we know, devices nowadays have more than one thread, thankfully. But how do we make use of that? Well, a friend comes up to them and says, hey, I found this cool new library. It's called React Native RS Animated. It allows you to write Rust programs called worklets and dispatch them from JavaScript to run on the UI thread. Now, Rust is a great language. It's very type safe. It's very memory safe. So that sounds great. What could go wrong? Well, let's take a closer look at the API. It turns out that the API requires you to write Rust in a string. Okay, nice start. And you might not be familiar with Rust, but we can see there's some variables there. There's like a main function there that's external to JavaScript. Okay, it adds two numbers, writes them into C, and we can just run on UI, pass the worklet, and it runs on UI, apparently, right? But if we want to do more, we can use something called shared values, right? Use shared value. We have ABC, but now to hook the Rust together with the JavaScript, we have to give each value an indice, a number that identifies it. We cannot really refer to them by their name. It's not that high level. So we assign 0 to A, 1 to B, 2 to C. Very cool. We do the same in our JavaScript down below. And that's fine, but when the Rust code changes or the JavaScript code changes, we have to keep those in sync, so it's not perfect. And yeah, I forgot to talk about, we actually have to serialize our values into binary. When we create a shared value, we have to create a float32 array, or depending on what we actually want to share, an equivalent value. And that's fine for primitives, but for structs and arrays, that becomes much, much more complicated. So great, that doesn't sound tedious at all, right? And again, Rust is an amazing language. And it's very capable. It's just the fact that we need to shoehorn it into a TypeScript code base that makes it miserable. We give up all of the type safety whenever values move from TypeScript to Rust or the other way around. And thankfully, there are alternate reality libraries that build on top of React Native Verse Animated, but sometimes all you really want to do is to just run your own code on a different thread. Now, thankfully, we're in our own reality. React Native Reanimated exists, worklets exist, but I really want to make the point that this situation is actually happening. This is happening in our own universe, just not with worklets. It's happening with WebGPU. WebGPU is the new cross-platform GPU API for the web, now also available in React Native, thanks to the amazing William Candillon. Ooh, yeah, round of applause. Yeah, it's so awesome. Like, it really unlocks so much capabilities. Like, it allows for more performant graphics computing, just general compute workloads for, say, you can imagine massively parallel computations like AI inference or simulation. And most importantly, it's not built on OpenGL, which has been deprecated on Apple devices for a while now. So what's the problem, right? It unlocks so many possibilities. Well, this is the kind of like API you can expect, right? You have to learn a whole new language, which is kind of Rust-like, which is why I kind of drew that parallel. You don't have to learn it here. I won't like require you to know or understand what it works. I just wanted you to see that, you know, the syntax is kind of foreign or can be foreign to TypeScript developers, and it's not ideal to kind of pull that into our existing code bases. And yeah, WebGPU sheeting language. It's the language that we use to write programs for the GPU in WebGPU, commonly abbreviated as WGZL. I'll probably use the WGZL word from now on. And yeah, this is usually what you see in your actual code base. If you're integrating WebGPU into a TypeScript code base, usually just write it in a string, as I've shown in my alternate reality parallel. So in my own analogy, React Native Verse Animated is meant to reflect the friction that a TypeScript developer might feel when using WebGPU directly. As an example, I want to show this shader. It's like an AI undulating orb thing that can react to your voice. You can think of it that way as a use case. And this is the code for it in WebGPU shading language. It's quite a lot, but I won't delve too deep into it. I don't want to teach you how WebGPU shading language works and how the shader works. So I'll just show you some TypeScript pseudocode. We have like a React component, and we say orb, and we just have a black sphere. And we can add some like props to it, let's say, like an ambient color, right? And it's pink. Very nice. We can also add some Fresnel, which just adds like a rim lighting around the sphere. Very nice. We can add like a light direction and diffuse, which gives it some more light from the top, some warm light. We can also change the background to a different color. Very nice. What would also be nice to do would be to pass like a JS callback instead of a value so that we can react to stuff that's happening on the screen. In this case, the background callback receives a UV coordinate, which is just a 0 to 1, 0 to 1 coordinate on the screen. So in this case, we use the Y coordinate to blend between two colors, which in the end turns into a gradient that changes from the top to the bottom. Very cool. We're not there yet, but let's say that we took more time to develop this, or asked somebody else to develop these functions to plug it in. We could think that we could just import it from somebody else, plug it in as props, and it works, right? I mean, of course, I'm kind of lying here. I hid a lot of stuff, but just the ability to kind of take apart the orb, which is kind of the hard thing to actually draw the sphere and fake the sphere, from the visual look. You can separate those two apart. And I kind of lied to you. I'm a liar. This is not pseudocode, right? This is an actual React component that's written in plain JavaScript. You have callbacks. You pass them into the component, and then they get compiled into WebGPU shading language using the library that we're working on called TypeGPU. Thank you so much. My name is Iwo Plaza. I'm the lead developer of TypeGPU. TypeGPU is one of the libraries created by Software Mansion, and basically what it is, it's a TypeScript toolkit for WebGPU, allowing you to write complex graphical and compute shaders without ever giving up on the TypeScript developer experience. It has no native dependencies, so it works the same way on web and on React Native, thanks to React Native WebGPU by William Candillon. And it's actually framework agnostic. I know this is a React Native conference, so this might be a little bit controversial, but it works with React, it works with Svelte, Vue, even just vanilla JS if you want to do that. And actually the slides that you're seeing right now are just Vue components and TypeGPU using SlideDev if you're curious. So let's back up a bit, right? Why should you care about TypeGPU? Let's try to answer that. Like, why build a new shader system at all? Like, we have so many cool libraries out there, right? Most in use by React Native developers are React Native Skia and Free.js through React Free Fiber. So where does TypeGPU fit into all of this? Well, if you think about it, all of the existing libraries like Skia and Free.js provide a high-level API, right, that you can like describe your scene in. But they also always provide an API that lets you drill deeper, an abstraction below, and lets you actually write shaders that work on a lower level and customize it a lot more. In the case of Skia, it's SKSL. In terms of Free.js, it's TSL. So for Skia, it looks a bit like this. This might seem familiar to what I've been showing before. You basically, because the Skia from Chrome has their own shading language, you have to write in that, pass it using as a string to their APIs, and it works. You have a great effect. It's cool. But it has the same problems as we saw before. If you want to build a bigger program and split it up into chunks, you have to concatenate it. It's not ideal. It's not something that we felt would be something we wanted to build upon. And in terms of Free.js, they have something called Free.js Shading Language, TSL. It looks a little bit like this. This is JavaScript. But instead of like saying a for loop, you have to say loop, like call a loop function, pass in the start index, the end index, the type of the variable, I think that's iterating, the condition as like a string, and then the function that gets called on each iteration. And like accessing arrays and stuff isn't, like, it's not syntax that we're familiar with as TypeScript developers. And most importantly, this is not type safe. Like, when you actually put this into a code base, you're not going to be able to hover over any element and see what its type actually is. You kind of have to guess based on the context yourself. So what we thought was, what if we just focused on those parts of those libraries? What if we build a solution that solves the problem of writing low-level shaders in an ergonomic way, sit down and research development for like 2 years, I think. And the result is a shader system that truly first class in your TypeScript codebase. Like, feels like it belongs in your TypeScript codebase, and one that isn't bound to a specific framework. And I mean, that means you can write your shader functions once and use them across shaders, across frameworks, across your projects, across technology stacks. That's, I feel, really powerful. And most importantly, like, we've built TypeGPU in a very modular way. So it allows you to build your own purpose-built framework, as we do in our examples page on typegpu.com, or integrate it into those libraries like Free.js or Skia, replacing their dedicated shader system. So why TypeScript? I feel like that's a question that gets asked to us a lot as React Native developers. Like, why TypeScript? Why can't you just choose a normal language, right? And we're a little bit more tolerant to this kind of question, or to, like, seeing TypeScript in places where it's a little bit unusual. But for us, it was more than just syntax. What it basically came down to was that it was easier to enhance TypeScript with the things that we thought were missing and that were in WebGPU shading language than it was to go the other way around. For example, Wixel, WebGPU shading language, has operator overloading, which means you can add vectors, multiply vectors by matrices and stuff like that. You can't really do that in TypeScript, right? Right? We'll see about that a few slides from now. But TypeScript has importing from other files, right? That seems pretty important. It has generics. It has so many features we've come to be accustomed with. We also get the benefit from unified tooling, right? Our TypeScript language server is able to know about both the CPU code and the GPU code, and most importantly, keep it type safe on the bridge between that link. I wrote console log there. I don't know if you guys have seen the tweet, but we do support running console log on the GPU, which allows you to be a lot more safer when you're debugging. You can just like console log on each pixel on the screen. Oh. And it works pretty well, I have to say. And it's very useful. Like, otherwise you would have to like draw a pixel and interpret the color of the pixel and see what's wrong with that. It's very hard to do otherwise. And also what I wanted to talk about is pre-computation. I'll touch on it a little bit later. But because of the fact that the code is the same, it's written in the same language and runs on both the CPU and the GPU, we're able to do something similar that web frameworks do nowadays with partial pre-rendering. You can think like you have the part of your shader / in this case web page that's static. So you can just pre-compute that, serve it from a CDN, and fill in the dynamic parts on the client, right? That's very fast. You don't have to do all the work on the server or on the client. And we can kind of apply the same logic here. If we can do stuff before the shader even reaches the GPU, because it's in the same language, we can just run it, right, on the CPU, then we just generate smaller WebGPU shader code than you would write by hand. Tsover. What is Tsover? Well, Tsover is basically our fork of TypeScript. I know fork sounds pretty scary, but it's a sustainable fork. It's not like a usual fork, like you would think, like we fork a GitHub repo. What it actually is, it's a script that applies the changes, like minimal changes that it needs on any TypeScript version you want, and we just publish that as an alternate version of TypeScript that you can install. And what it allows you to do is it allows us, as TypeGPU, to define operator overloads for the things that we want. So you can have two vectors, add them together, and it works. You have type safety. And it not only works at runtime, so you actually get a real value. If you hover over C, it's a vector too. It's not any or throwing an error and shouting at you. And we built it as a separate solution so that you, as library authors, or if you want to just have operator overloading for your own objects in your app, you can just integrate Tsover without integrating with TypeGPU. Of course, I want you to integrate with TypeGPU, but So to summarize, it's not just about syntax. I hope you can see why we thought it would be sane to compile TypeScript into WebGPU shading language to begin with. It's not just about syntax, it's about the developer experience and functionality we have grown accustomed to and we know the value of. And I have this half-serious claim that programs written in TypeGPU end up actually being faster than those written in WebGPU. Now, that might seem crazy because first of all, I mean, the shaders are in JavaScript, so that can't be fast, right? But second of all, like, we are built on top of WebGPU, so it's hard to think about how can we be faster than the thing we're building on top of. We're essentially limited by the efficiency of the WebGPU API. We even have an API, you don't have to read the code, but we have an API that's called tgpu.resolve, which just takes your TypeScript program, turns it into a WebGPU program. So theoretically, just the end user could write whatever we output and be just as fast, right? Well, that's the catch. It's human nature to cut corners. Like, it's sometimes fun and satisfying to optimize things for the sake of it. But in the end, we're bound either by having to deliver something that works and is fast enough, or sacrifice readability and reusability in the process. And I've heard a lot of people approach general-purpose GPU programming as a last resort, meaning it's just simpler and more maintainable in the end to pull data from the GPU, which takes a long time, do computations in JavaScript, and push it back onto the GPU so that we can do some more calculations or draw it to the screen. And this is actually a huge bottleneck with libraries like ONNX Runtime, which do AI inference. If a functionality cannot be hardware accelerated, the data is pulled back into RAM, processed on the CPU, and pushed back, which often ends up being as slow or even slower than just doing everything on the CPU. And yeah, going back to my note about pre-computation, which I kind of talked to you briefly about, I want to showcase you kind of the mental process of what that looks like. So here we have use GPU function as just a shader, accepts a parameter t. And we have a from color and a to color. We use the hex to RGB function, passing in a string to it with a hex code for a color. We have red and green. And then we multiply both values by half, so they get a little darker. And then we mix those two colors using the t that we got as an argument. Now, I mean, first of all, you can be kind of weirded out that there's a string in my shader. Why is there a string in my shader? This is actually a comp time function. You can mark any function you want as comp time. And what actually happens when we look at your code is this gets pre-computed before it even reaches the GPU. It's pre-computed in JS, so it turns into this, which is just read using 0 to 1 vector syntax. We then multiply it by 0.5 because both of those values are known, and this is it. We can't do any more about that. We do the same with the next line, and we end up with this. And then, we just mix the two together because t is only known when the code actually reaches the GPU. So we can't really do anything about that at that point. So we end our process, and then we just turn it into WebGPU shading language. And you can see how the code is just very similar. Like, the only thing really different is the syntax, but the actual semantics and what you wanted to achieve with your shader is kept as it is. And it was very important to us to maintain your intention as a developer. So essentially, I feel like we've reached a point with TypeGPU where, because your shader is just a TypeScript function, you're essentially writing the same code as you would if you were cutting corners. Yet the performance is often better than what you would write by hand in TypeGPU, or with WebGPU, sorry. TypeGPU is the fast one. Now, I'm very proud that I've gone this far into the presentation without talking about the agentic elephants in the room. From the beginning, TypeGPU has put the developer first. And we believe that when we give developers powerful and expressive tools that reduce friction, amazing things can be built. Now, the side effect of this is that actually agents are very good at writing TypeGPU. We've recently released agent skills, which just fill in that gap of API, because TypeGPU is fresh enough that it's not really represented in the training data. But as we saw, like, TypeScript is very well represented in training data, and agents are very good at writing TypeScript. So if we just tell them what the API is, they can do very well. And also using the fact that it's just type safe, and there's no like numeric indices here, numeric indices here that you have to synchronize. AI is very prone to like editing part of one file, but forgetting to edit the same thing in another file, and that can lead to very hard to reproduce and just track bugs. So that helps a lot. If you have one source of truth, AIs make less mistakes. And we have a few examples that were just purely made with AI. One of them is a real-time ray tracer. You can just like move objects around, and the ray traces in real time. And the other is just like a signal. It's called Signal Grove. It's like you have a field of grass and trees. That's what it's called. Yeah, and like water in something. It looks pretty cool. And yeah, it was interesting for us to do these experiments because we were thinking, like, wouldn't it be harder for AIs to build these, like, their own frameworks, basically? But it turns out they can build very good purpose-built solutions. And when they aren't limited by the expressivity of a high-level API, they can just tweak whatever they want. And thanks to the type safety, it just works. So finally, our AI slop can live on a type-safe foundation. Is it AI slop by that point? I don't know. And yeah, we love React, right? Software Mention loves React. And during the 2 years that we were developing TypeGPU, we were testing TypeGPU out in all sorts of React code bases. And we've gathered that up, finally, into a project that I'm very happy to announce, which is TypeGPU React. There we go. Now, this is still low level for the TypeGPU mythos, let's say. We're definitely planning to add more high-level APIs on top, but we also believe that with good primitives, people can build their own purpose-built higher-level APIs that suit their specific needs. So for now, we have a useRoot hook, which just allows you to asynchronously fetch a GPU device, which usually involves like a lot of use effects and not very maintainable code or code that can crash very easily. We also have resource allocation, which we found was very helpful, and just a use frame hook that doesn't require any re-rendering, which is very useful for performance. And it works out of the box with React and React Native, of course. My second to last point that I wanted to touch on. How's everybody doing? Okay, very good. So, I mean, yeah, maybe you're excited. Maybe you what TypeGPU is and why we did it, why we made the decisions that we made. But you might not be sure when you should actually reach for TypeGPU as opposed to the other solutions. And TypeGPU isn't really geared towards a specific type of app or effect. And because of that, I believe it's really a tool that allows you to get an intuition on how the GPU actually works, its strengths and its weaknesses. And it allows you to learn the platform and not the syntax or specifics of a particular abstraction. Now, not that I don't like abstractions. If you saw William's talk, redraw is a very powerful set of primitives that's actually built to work with TypeGPU and built with TypeGPU in mind. And I really feel that now we are in a time where abstractions don't need to own their own domain. They really can focus on what problems they want to solve. And redraw, it exposes a lot of primitives for high-performance UI elements with vector effects. And they can defer to TypeGPU for all the other stuff that makes the low-level access ergonomic. And because of this, I feel like now it's the best time for you to build your own primitives and share them with other people. I'm really looking forward to see what you're going to build. So when should I use TypeGPU? I feel like the question should actually be when to use the GPU at all. And to give you a very broad answer, if you're drawing anything, you should probably use the GPU, unless you want to experiment with a software renderer for some reason. That's also pretty fun. If you have a parallel algorithm, just some operation that you want to run on a lot of data, like a simulation, and you have thousands of objects, use the GPU. It's pretty good. It's pretty good at that. If you feel like you're moving a lot of data around, from the CPU to the GPU back, and you have to do processing on the CPU and push it back to draw it again, you should probably use the GPU. Now, if you don't have an idea for what you could do, you can look at our examples page. We have lots of examples, both graphical and compute, and including simulation, including the jelly slider that you may have seen on Twitter. And talking about the jelly slider, I feel like it's a prime example of what knowing the platform allows us to do. If Konrad Reczko, the author of Jelly Slider, was writing it in anything other than TypeGPU, I truly believe that he would quit halfway, because he would either have to debug mismatch issues that are irrelevant, really, to the problem when using raw WebGPU, or fight with a high-level abstraction to get the actual performance and result that he wanted. And I feel like TypeGPU is the perfect golden middle between abstraction and expressivity. If you have the App.js map and you're on iOS, that's very important, you can open up your map and you have a 2D to 3D toggle. The 3D map is written from the ground up in TypeGPU, so you can check that out and play with it, like zoom and rotate. It's pretty fun. And yeah, if you're already on, if you're already on Free.js or you happen to like that abstraction, you can actually just use TypeGPU in Free.js already. You can look at our docs. We have a specific TypeGPU/3 integration guide. You can look at that. You can still use the high-level APIs that you want, but just use TypeScript to write your shaders. And on the topic of redraw, I know it's in technical preview right now, but if you want to get into it, like you're probably going to end up using TypeGPU as the shader system anyway. You can already prepare for the publishing of redraw by trying out TypeGPU first, getting that intuition, and when it comes public, you'll just be able to transfer that knowledge over without any adjustment. So the last point. Okay, you know where to use it, you know why to use it, but how do you actually use it? And for a while, that hasn't been super clear, because we've been adding just more and more cool tools that help you with that just the amount of steps grow and grow. So to help with that, I'm happy to announce another thing that we released like not that long ago that helps with just that, and it's called the TypeGPU CLI. You can actually just run npx TypeGPU at latest, and what it's going to do, it's going to work like the create Vite CLI. You're going to provide your project name, select the template. We have the Vite and Expo templates. You can choose from our ecosystem libraries that implement some of the stuff already. You can even download the agent skills right then and there. So really, you don't have to think about anything. You can just run the command, set up your project, and start using TypeGPU. I love that word. And yeah, like if you don't want to start from a better template, but you want to use some of our examples, like the jelly slider, and just play with it and see how it works. Every example that you see on this page, if you click on like there's a show code button, you can find it, and then when it shows up the code, there's like an edit on StackBlitz button. If you click that, it's going to open up a new fork of StackBlitz with that project, so you can either play with it on StackBlitz or download it locally and just start from there. And also, I feel like for a while to use TypeGPU, you had to know WebGPU and shader programming to begin with. And we really wanted to lower that barrier of entry. So we've started writing just bare fundamental guides where you learn TypeGPU and graphics programming / compute programming at the same time as you learn the API. And yeah, we also have guides on how to integrate TypeGPU into other frameworks. And if your favorite frameworks is missing, just let us know and we'll add it in. And if you hop on our Discord server, we're actually pretty active on there. If you don't get to scan the QR code, you just go on our typegpu.com, and there's this Discord logo in the top right. You can just click it, and you'll join our channel. There's a lot of people from outside Software Mansion just posting their projects that they built using TypeGPU, and it's very inspiring. And yeah, we would love to help you out with your GPU journey. And both me and Konrad will be walking around the venue, and we'll be happy to chat. Yeah, those are us, if you want to burn that into your brain. And my last point is math is cool. That's it. Thank you so much.
Thank you so much. Really, really great talk. So much amazing content that we can take away from. It's really interesting, I find, having so many different people talk about the different tools that they're making, the different libraries that are making our lives as developers easier so that we can build the apps that we want. But what's also great is getting to hear from other developers who are building, who are deploying at crazy scale the apps that maybe you and I use today. I'm actually really excited for our next talk, because our next talk works at Partiful, which is an app that I've used a lot, especially going to organize parties and so on and so forth. So I'm really excited to learn about their pipeline and how they deploy. It's been really, really interesting to see not just the tools, but also the outcomes as well, so that I can figure out what I'm going to take home and try out tomorrow. Good thing for you, though, I know there's been a lot of content that we've given to you, so make sure you check out the recordings. Yes, it's being live streamed. Maybe there is something you want to send to a colleague, or maybe there's something you want to go back over. You can always go and check up on the recordings and then find the content that you've missed. I know it's a lot, but we've got it going. All right, let us get ready for our next speaker. I would like to introduce to the stage, well, he's already here, one of the tallest speakers on our lineup today, Yefim the Dream. Give him a round of applause.
Thank you for having me. I'm Yefim Vedernikoff, and I'm here from New York City to talk about how we ship Partiful on Autopilot. A lot of the talks today and a lot of the existing documentation focus on getting you from nothing to something, from an idea to a functioning app, from 0 to 1. What happens next? My talk will be about what happens after 1.0. You built and released your app. Users are downloading it and using it every day from the Apple App Store and the Google Play Store. You're hiring a stellar team of designers and engineers who push product and ship features. How do you release your app every week? We're going to walk through how Partiful does it and the lessons and scars we've earned along the way. Partiful who, you may be asking? This is our second App.js, so allow me to reintroduce ourselves. Partiful is the easiest way to plan social events. You can see us at the top of the App Store, closing in on Pinterest, and crowding out Zillow and Ring Camera. Oh, and what's that behind the App Store screenshot? Oh, it's a blog post from Software Mansion titled "Refining an Event Planning App That Won Google Play's Best App Award." And yeah, it's about us. We won Google Play's Best App Award of 2024. Thank you. It's great to be back. Partiful is fun, interactive event pages. Partiful is platform agnostic, powered by SMS, WhatsApp, and now iMessage. It gets everyone on the same page and keeps track of who you met IRL. We take product very seriously at Partiful. In fact, in the week that I've been traveling Europe, first Vienna and now here in beautiful Krakow, our team has shipped Partiful Ticketing, a full ticketing solution for your events, including QR code check-in, Partiful Communities, a new home for your interest-based group chats and gallivants, and React Native new architecture, perhaps the biggest behemoth of the three. We ship these features and more every week, every single week, for nearly 3 years. This year, we will ship our 150th release. I'm going to walk you through exactly how our app gets from a merged pull request on GitHub to the App Store every week and the tips and tricks that make it work. We shipped the app in August of 2023 with one app target, iOS. Now, nearly 3 years later, we have 5 targets: the iOS app, the Android app, the iOS app clip, our live activity, and our app clips live activity. Thank you, Expo, for Expo widgets. I'm sure you know the drill. We had one lucky sucker who was responsible for releasing the app every week, our release conductor, who happens to be my manager, Alex. Hi, Alex. It was a week-long affair. Around Tuesday breakfast, he would start bullying folks to get their fixes in. They would QA the app themselves and ask engineers to QA their own changes. Our solo release conductor could not take vacation, could not call in sick, could not do anything else really without slowing down the entire app release process. This was just one app, the iOS app. We didn't have an Android app yet. This was the era of the babysitter. And it worked up until Alex took vacation in March of 2024, and we had to skip a release that week. So our first attempt was to scale the release conductor from a singular release conductor to the plural release conductors. With the Android app on the horizon, we scaled from one engineer to a rotating team of release conductors, the babysitter's club, so to speak, for those who have read millennials in the crowd. The release was still triggered manually by one of my teammates, but the bully changed every week, freeing up the solo engineer to continue working on product. We systematized the release. We moved the cutoff for changes to Thursday night, built a dedicated QA team to QA the app every Friday morning. We drafted a runbook. The process was now owned by the engineering team as a whole. We automated a little bit of it. We had a Slack bot that posted every Thursday morning to let people know that the release was coming, get their changes in. All that was left to do was to conquer the final frontier, humans. So what is our release conductor role? Our release conductor owns the release every week for that week. They chase down PRs that are needed to make the cut that week. They loop in our QA team. They monitor Sentry for errors. They submit to the Google Play Store and the Apple App Store. Any hot fixes or any things we catch in QA or end-to-end tests warn us about, they have to hotfix. Or they own getting the hotfix into the release. And in order to perpetuate the cycle and to keep everyone knowledgeable on the team, they're also in charge of onboarding the next release conductor. You can see how the problem started, how the release conductor role started crumbling. It was very manual. In my time as release conductor, I would manually commit over and over and over. You can see in the Git log, bump build number to 1.24.1, build 10, bump build number to 1.24.1, build 10, take 2, once more, again. A lot of manual committing, a lot of trying to get changes in the last minute. QA was constantly being pushed later and later and later, sometimes even to Monday, and things were just bleeding, and the cracks were starting to form. And other people could take any release number, since there was no rhyme or reason to the release numbers. Anyone could take any release number and push out a test flight just to test their features, and we were stepping on one another's toes. And one time we even released something that someone thought was the production release, because we were all managing build numbers manually. We pushed it to the iOS App Store, and thankfully we caught it maybe an hour or two after the release went out to real users. And then we rushed an emergency release and were able to salvage it. But who hasn't released, test code in production? So we've always known that Autopilot was coming. Automation is the future, and we wanted to automate more and more. I'm not going to go into the too grisly of the details, but this is a Slack thread from 4 weeks before Autopilot. You can see the reminder bot posts, anyone trying to make the app release cut today. A bunch of my coworkers, including my manager and the current release conductor, Amadou, chiming in about wanting to get their changes in. And then Ramya at 5:30 p.m. on a Thursday saying, every time you all say you can do Friday, my sleep schedule gets worse. And then the same thread continued into the morning. Irene, prophetically replies, we'll eventually have automated app cuts anyway. And then I hit back with the banger, enjoy the mercy while you still can. Mine is merged. So can I make the cut, or people still need some time? The release conductor asks. I think you can make the cut, but I'll have Alex confirm. And then Alex, 10 in the morning the next day, after all this has been sifted through, finally says, my stuff is ready, and we make the cut. Very painful. So here we are, the dawn of a new era. I automated our release. I built our Autopilot. And now, the bot, every time it reminds engineers, whether they're trying to make an app cut today, they know that the app cut is happening. It's not, you can't beg and plead and message in Slack. It's gonna happen. It's only a matter of time before the cut is happening. We're coming up to a year of Autopilot next month, and the best part about it is that no one has noticed. It's been working for so long that we can hardly remember the times of yore. The release conductor team is now 3 fixed engineers who devote a few hours per week to shepherd the release along, but we've automated more and more of the bones. So, quick recap of the macro timeline. From launch to about 7 months in, we had the solo ownership, 1 engineer, 1 babysitter. That started breaking. Team ownership. We had a whole team owning the pipeline, owning the build process. That started breaking. Now we're having the pipeline own more and more of itself. So, how does Autopilot work? What is our secret recipe? Before, it was very manual to decide the version number. We were constantly getting into debates. Should version 2.0 be twice as good as 1.0? We can't release 2.0 until we have this feature or that feature. We must, whenever we launch 3.0, we must reskin the entire app. Everything was was just debated endlessly, ceaselessly. We didn't have any automations besides really the Slack bot and some of these EAS build jobs. And so a lot of people ask, when I gave this talk before, is Autopilot just CI/CD? Is it just hooking up your GitHub actions just right and making sure they all sing the same tune? Autopilot is more than that. It's a way to get there. We're moving from high touch and high Slack and lots of messages back and forth to light touch and being able to own very little and still ship at a cadence as our app is growing and our engineering team is growing. So Autopilot looks like a GitHub Actions scheduled job, a cron job that runs every morning, every Friday morning, that enqueues GitHub Actions build job, that then enqueues an EAS build, that then enqueues an EAS submit, and we call this our daisy chain. Builds auto-submit to test flight in Google Play, and the date is the version number. So quick code slide, quick GitHub Action screenshot of our daisy chain. This is automatically triggered by GitHub, 6 a.m. every morning, or every Friday morning, and uploads it to EAS build. And we also upload binaries to our AI-enabled end-to-end test provider, GPT driver. And so you can see that at the bottom there. We also tag our releases in Git so we know exactly what code was committed. Right now, it's a bit of a mess. It's daisy chaining GitHub Actions together with EAS workflows. We want to get more coherent. Who hasn't suffered a devastating GitHub Actions outage in the past few months? We want to, move off GitHub Actions, maybe onto EAS workflows. But this has been working for us so far. And then the biggest takeaway, if there's any takeaway, is that the date as the version number freed us. Before, all these debates. Now, there's no debates. We know the version number. It's 3.4.10, April 10th, month, day. The 3 is kind of irrelevant. 3.4.17, a week later. 3.5.01, 3.5.08. A week later, we launched ticketing. 3.5.15. Monotomically increasing. No more deciding what version we're shipping. No manual bumps. No conflicts. Everyone is on the same page. If you see a bug introduced in a specific version, you know exactly the date that that bug was introduced. You can go and look for it, look for any PRs that happened around that time. Very easy to see. And as our CEO put so succinctly, thank God we're using dates for versions now. So, as I said, Autopilot, not just CI/CD. We still have the human touch. Human touch, so the build lands in test flight and Google Play internal track automatically Friday morning. The release conductor loops in our QA team, just one person right now. The QA team checks the output of the AI-enabled end-to-end tests and runs any manual tests that the AI tripped up on or couldn't figure out. And then QA gives the check mark, and we're off to the races. The release conductor rolls out the release to our external testers, and then we roll it out over the weekend, where Partiful is mostly used. So over the weekend, we go to a lot of Partifuls. Monday morning, the release conductor checks Sentry, submits to Apple and Google for review. Apple and Google take their sweet time to review. There can be a whole talk about that. The release conductor releases first thing Wednesday morning, and our users rejoice. So what happens when things go sideways? Just a real quick tangent. The nice thing about this pipeline is it works the same way. If QA catches something or a user encounters a crash over the weekend, we cherry pick commit into the release branch, and we QA the cherry pick, and then we go ahead with the release with the cherry pick on top of that release. So the daisy chain is the same infra. There's no scrambling, no figuring out how to rebuild, no manual triggering of builds, no managing version numbers, no managing build numbers. Everything just automatically happens. Hot fixes are solved. Again, just real quick, what does our release look like? Week in the life. 6 a.m., cron cuts the release. Builds land in test flight, Google Play, internal track. QA gives the check. Release conductors submit to Apple and Google. We bake it over the weekend. Then release conductors submit it to Apple and Google on Monday, and then Apple and Google approve, and a release goes live. So we now have an automated deadline for when a PR needs to be merged in order to make it into the next release. Thursday evening. There's no more guessing, no more crying, no more bribing your way into the next release. If you don't make this release, there's always next week. That's what I tell them. We struggled so much with versioning. We wanted version 2.0 to feel twice as good as 1.0. But as soon as we let go of that and switched to automatic date versioning, we freed ourselves and started to think about real problems, like how does Partiful make money? The daisy chain works. We're able to kick off a cron job and trace it all the way through to EAS submit. Thank you, Expo, for that. Hot fixes aren't special. They follow the same pipeline. The cron job reduces manual work. We don't have to manually commit anymore. We don't have to figure out what build or version number you're on, what build or version number you're submitting. Automated cron job doesn't have feelings. It just does its thing every Friday morning. Date versioning is easy, and it's free. So I want to leave you guys with just some things we're cooking up next. I'm rethinking some of the things we built, seeing what we can do in the future to speed the release up, automate it more and more. ES workflow migration, I already mentioned. End-to-end testing, we need to deflake our end-to-end tests so that manual QA is cut down more and more, and we give more time back to our QA team. Automate App Store Connect more and more. Right now we still draft release notes, and we have to use the App Store Connect platform. Some of the Slack messages that we manually send now, we can automate more and more. And I'm really excited for the talk by Katie next tomorrow, which is talking about monitoring your release and Expo observability, Expo Observe. And because right now we're using Android Vitals that I check maybe once every couple days to see the last week of data. But it would be nice to automate that as well. So this is how Partiful ships on Autopilot. Thank you so much.
Thank you so much. All right. We have more amazing talks. They've been really, really, really good today. We are going to have another talk coming up in just a moment, so make sure you get your clapping hands ready, because the next talk is all about illusions. I'm really excited to hear about this one as well as we get set up. All right, now I know that I've made a couple of announcements, and I just want to quickly go over them as well. Wanted to remind people about the after party that is later on tonight, so make sure you go onto the website and find the link. Also want to remind you that we'll be here tomorrow as well with lots more content, and there will be an after party as well. Now, in a couple of minutes, we've got another talk, and then we'll have a break. And during that break, I want to remind everyone to go and check out all of the sponsors' booths, because some of the sponsors are going to be having raffles and prizes that they'll be giving away tomorrow afternoon. So make sure you go check out those sponsors. Make sure you get your names in, because there's always the lucky few that have to, or maybe lucky or unlucky, who have to take a little bit of extra baggage as they go home. So that could be you. So make sure you go and check out all of the sponsor booths as well, both downstairs and upstairs, and maybe you could win a prize to take home. All right. Our next speaker is a senior React Native developer at Margello, and they are going to be talking to us all about the illusion of portals in React Native. It's really interesting. I love the kind of total diversity of topics that we get to learn about today. And it's going to be really interesting for you, because some people will learn about things that maybe they're already using, and they're going to learn how to use them better. And for someone like me, I did not know about portals. So I'm really excited to learn all of this from scratch today and take that away. So our next speaker, Kiryl, he's a long-time speaker. He was here last year as well. Always kills it with amazing talks. So I'm really excited to learn from him, and I hope you are too. So we'll get going in just a moment. Make sure you get yourself comfortable if you're at home. Make sure you lean back on your chair, be ready to listen. And also, I see a bunch of people with your laptops out. Make sure you get ready, because there's lots of really cool examples that you can take away and use yourself. So hopefully you get to take some of this home, take it back to your engineering teams, and share it with them as well. Don't forget, make sure you check the app, because we're constantly updating things, and you can keep track of the schedule and what's coming up next as well after that. And without further ado, we'll get on with our content. So can we give a 10 out of 10 applause and welcome to the wonderful Kiryl?
Thank you. Thank you. Hello, App.js Conference. It's great to be back here in Krakow on stage again. My name is Kiryl. I'm a software engineer from Margello, and last year I gave a talk about keyboard management evolution. This year, we are switching gears a bit. The topic is called Illusion of Portals. I'm pretty sure most of you already know what a portal is and when to use it. But just out of curiosity, could you raise your hand if you ever needed to use it in your app? Okay, many of us. Great. Before we dive into deeper internals, I would like to take a moment and quickly recap what a portal is and when would you use it. We also have people watching us online, so it's important to be on the same page. Let's start our journey with a simple question. What is a portal? At a high level, portal is a mechanism that helps you to render part of your component tree somewhere else. Why is that useful? Let's imagine you have a logout button. When user press it, you want to show a confirmation dialog. Now, obviously, you cannot just render it in the same component because you expect it to cover the entire screen. So it needs to be rendered above everything at a higher level where it can actually overlay it. And that's exactly where portals comes into play. For rendering a portal, we need to explicitly use the create portal function. And the frustrating part is that it doesn't come from React core package. You need to import it from React DOM. So in practice, this concept is really tied to the web. On mobile, though, we often need the same idea. Render something outside of the current component tree at a global level. Interestingly, but many React Native developers don't really think in terms of portals at all. Why is that? First, as mentioned, the portal concept originates from web development, so it's not part of the mental model in React Native. But there is a more important reason. In React Native, we already have a component for this problem. This is the model component. You can render it anywhere from your component tree, and it still will appear on top of everything else. So, in a way, React Native already gives you a portal-like behavior. But it's important to understand that model only partially implements the idea of portal. On the web, portal gives us full flexibility in deciding where exactly the content should be placed. You can attach it directly to body, or you can target any other element in the tree. And this is the key difference. It doesn't just mean render on top of everything. It means you can choose the scope of that rendering. For example, imagine building a context menu. You might want it to be visually rendered above a specific screen, but still behave as part of the screen, so that when you swipe it away, the context menu moves along with it. And in model, it's kind of not achievable. Your component will stay on the screen where it is, and it will not follow your screen. So it's not just about layering. It's about a control over where things live in the tree. And in that sense, model is just one specific use case of what portals can do. It solves a very basic scenario, but it doesn't cover the full spectrum. And this actually proves an important point. We do need portals in mobile as well. So the question becomes, what do we actually have? In fact, React Native ecosystem has already several solutions, and all of them solve a problem in a fairly similar way. So let's take a look at their API and the difference between web and React Native. On web, create portal function accepts two arguments: the content that we want to render and the target DOM element, where that content should appear. In React Native, historically, we didn't have an API like getElementById or any other way to directly query arbitrary nodes. So the API evolved a little bit differently. Instead of imperative approach, the API converged on a declarative model. First of all, we need to define a portal host. You can think of it as an anchor point or the destination where the content should be rendered. Then, somewhere else in the tree, we need to render a portal component and target a specific host through something like a host name prop. All children inside that portal will then appear under the corresponding portal host. So, at a high level, everything feels very React-like. We declaratively described what should be rendered and where it should end up, but still within the constraints of the React framework, not the render implementation. But let's quickly look under the hood of these implementations to see how they actually made and how they differ from the web. As I mentioned earlier, most portal solutions implemented in JavaScript are purely in JavaScript. The common pattern is to use some kind of shared state, typically React context, Zustand, or any similar store, to keep a global registry. This registry is a simple key value map where the key is the host name and the value is data associated with that host. When portal host mounts, it registered itself in this map. Later, when a portal is rendered, it pushes its children into the same shared state under the corresponding host name. The matching portal host receives that content and renders it in its own place. And to be clear, this idea is not bad at all. It actually pushed ecosystem forward in a meaningful way. It powers many popular libraries like React Native bottom sheet. But at the same time, it's important to understand that this approach is fundamentally different from how portals work on web. Let's take a look at a simple example. We have a component that renders two children, A and B, but B is rendered through a portal. Now, if we inspect it in a React DevTools, we will see a logical React tree, the one on the right side. The app is a parent and it has two children, A and B. Even though B is rendered somewhere else in the actual UI through a portal, it still appears as a direct child of app component. Now, if you switch it into React DevTools, we will see a slightly different picture. There will be a div block with ID root. That's where React's entire app is mounted. App will be attached to this root element. And because we are using a portal, component B will also be attached there, effectively rendered into a different DOM node. So everything works exactly as expected. But if we try to run the same code in React Native, we will immediately see a difference. The native hierarchy output will look correct. So from a rendering perspective, it looks like a portal. It behaves like a portal. It takes content defined in one place in JSX and renders it somewhere else. So visually, everything works as expected. But what about React tree? In reality, it will look identical to native tree. Why does it happen? Because we are effectively modifying the React tree by rendering children in a different part of it. In other words, our JavaScript implementation is physically changing where in the tree certain elements are mounted. And this approach comes with its own cost. Once you start modifying tree like this, some core React features begin to break or behave unexpectedly. The common scenario is context propagation. Imagine this layout. B is rendered through a portal while C stays inside the context provider. Because JavaScript portals physically change the place where elements are rendered, B is rendered now outside of that context, which means it simply cannot access it anymore. A common workaround is to move provider higher up, and sometimes it works, but not always, especially when you need multiple providers stacked on top of each other, each with its own value. And that's where things starts to break. We are trying to preserve React's model while reshaping the structure of tree and runtime. So, on the surface, it looks very similar to Portal, but it isn't really portals. It's more like a simulation, an approximation, an illusion. And this is exactly where the title of this talk comes from, the illusion of portals. All these solutions give us something that looks like a portal, feels like a portal, but behaves differently where it actually matters. And that difference is not just theoretical. It affects how your state flows, how your app scales, how predictable your UI really is. So, at some point of time, you start to realize this is not about missing an API. This is about missing a primitive. And once you see it like this, the question changes. It's no longer which portal library should I use. It becomes why don't we have real portals in React Native at all? And exactly that question led to the creation of React Native Teleport. Not as another variation of the same idea, but as an attempt to fix a root problem, to combine a declarative API, something that feels natural in React, without breaking React rules and avoiding tree reshaping at runtime. And to achieve that, we took familiar mental model from React Native, where portal and portal host are declarative components, but moved the actual rendering responsibility down to the native layer. So, in one sentence, in this model, React keeps the ownership and native use handles the placement. And Portal and Portal host are no longer just pure JavaScript components. They render native use, and this native use becomes responsible for managing and attaching children, which is much closer to how create Portal function works on web. But with this approach, we still have a clean, isomorphic React abstraction that works on all platforms while using native primitives under the hood. But there is a reason it's called React Native Teleport, not a React Native Portal. So let's draw a line here. We've talked what portals are and what we have in React Native. Now let's go one level deeper, because once you start thinking and working with portals, a natural question comes up. If we can keep content in one place in the tree but render it somewhere else, can we actually move an existing element between different containers? And the short answer is no, not in a React world. React Reconciler has strict rules, and it doesn't really support moving an existing element between different parents. From its perspective, the move operation doesn't exist. Even if you try to preserve an element identity with a stable key, once you attach it to a new parent, React will treat it as something new. Internally, it's effectively delete and create operation, unmount from one place and mount again in another. So in React world, nothing is ever truly moved. It's always recreated. And this is not just an internal implementation detail. When you remount heavy views, like high-resolution image, videos, maps, or other complex elements, you often notice a flicker. Because every time the element is recreated, it needs time and resources to initialize everything again. But here's where things get interesting. In Teleport, we've pushed this responsibility down to the native layer. And once views are no longer managed by React, everything changes. We are no longer limited by the idea that moving is impossible. We can actually take an existing native view and attach it somewhere else in the hierarchy, without destroying it, without recreating, without losing its state. We just move it. And this technique is called reparenting. This is the moment where the mental model of React quietly breaks, because what React says is impossible suddenly becomes possible at the native level. And I know that at this point you might ask, okay, so now effectively we have a force operations in React. Instead of just create, update, and delete, we also have move operation. So what is the point of it? At first glance, it might feel unnecessary. After all, we always can unmount a view from one place and mount it again in another. But when you start thinking about it more carefully, you realize something important. This missing primitive, moving instead of recreating, actually opens a whole set of new capabilities that are very hard to achieve otherwise. So let's explore them. We can take the Instagram app as an example. When you press on a video, it feels very natural. The video smoothly scales up and transitions to a next screen. The transition is fluid, continuous, and you never lose a context. On Android, it works differently. When you tap a video, you might see a preview frame or even a black screen. And only when transition completes, the video playback will resume. So effectively, continuity is broken. But now let's see how we can implement this kind of transitions using Teleport. And with Teleport, we get the same seamless transitions on iOS, Android, and even on web. This works because we are effectively moving the video between different containers, not recreating it. So our playback is never interrupted. And now, just think about it for a second. With help of React Native, we can build applications faster, thanks to a shared code base which can be run on multiple platforms without any changes. But now, we can deliver an experience that feels sometimes even more polished than native. Isn't it cool? I think it is. Another area where this kind of capability really shines is context menus. We can take the Telegram application as a reference. On iOS, there is a really beautiful interaction pattern. When you long press an item, it gets lifted above everything else, the background gets blurred, and your focus is entirely on the element and its available actions. There is no distraction. You immediately understand what you are interacting with. Now, if you look at the same pattern on on Android and web, you will immediately notice the difference. The selected element just gets covered by a context menu. And as a result, it's not always obvious which item was actually selected. So the connection between the action and the element becomes weaker. And from a UX perspective, iOS handles this much better. With help of teleport, we can literally take the selected element, lift it above everything else, preserve its state, and create consistent high-quality experience everywhere. iOS, Android, and web. And for us, that means that users don't have to relearn interactions depending on the platform. They know what to expect. And we can deliver, as developers, the same level of polished, exceptional UI across the board. And at this point of time, you might be thinking, wait, didn't we see something like this in the documentation already? And you'd be right. The React team on web introduced support for view transitions, which makes it much easier to build such kind of interactions. But there is few important things to keep in mind. First, view transitions are only browser API. There is no direct equivalent in React Native yet. Second, view transitions are mostly about animations and transitions, whereas teleport is about moving an element between different containers without animation. If you want to make it animated, you need to use additional library. And last, but probably the most important, is that view transitions rely on a snapshot-based approach. So when an element appears in a different place in the tree, browser doesn't actually move a live element. It takes a snapshot and animate it instead. And it has consequences. If you try to recreate some of the demos we just talked about, you will notice that as soon as transition starts, the content freezes. And when transition ends, the video effectively resets in a way that breaks continuity. So while both approaches are trying to solve a similar problem, they are fundamentally different. View transitions rely on browser API and snapshot-based approach, whereas teleport works with the actual live content, preserving state, preserving continue, and enables truly seamless transitions. And teleport and this library can be used for many other advanced UI interactions. Things like app tours, where you highlight a specific element, dim everything else, and bring that element up front of the screen. An image gallery, where selected photo seamlessly scales into a full screen view. Pick and pop interactions, where long pressing an item reveals a preview of the next screen before navigating it. There is also many use cases in chat applications. For example, sending a message where a text from the input smoothly transforms into a message bubble. PDF attachments, previews, maps, where the card smoothly expands into a full screen view without flickering. Animated stickers previews, where the sticker can be moved into preview area without restarting its animation or flickering in any way. And many, many more other use cases. And the really exciting part is that the same code works everywhere. We are no longer stuck thinking, well, this is iOS-only API, so Android and web will not get the same experience. With help of teleport, we can deliver the same transitions and result to all platforms. And as I said before, teleport is not only about animations and transitions. Another area where it can be really useful is component preloading. We can render heavy components off screen ahead of time, keep them mounted and ready, and then simply teleport them into a screen when it opens. And instead of creating everything at the moment of the navigation, we can prepare the UI in advance and make transitions feel almost instant. I know you might be confused because of the word off-screen. After all, the off-screen was the former name of the new React activity component, and both approaches are trying to improve perceived performance. But the difference is pretty fundamental. React activity keeps an existing part of UI alive, while making it hidden and lower priority. The component stays exactly where it is in the React tree. React preserves its state, but can deprioritize its update while it's not visible. So the component still exists. It's just hidden and inactive. Teleport works differently. Instead of keeping a component hidden in the same place, we can render it somewhere else in the UI hierarchy, keep it mounted and ready, and then simply move it on screen when we need it. So, one approach is about preserving UI while it's inactive. The other is about relocating live UI between different elements. And I think that's everything that I wanted to share for today. Let's quickly summarize the main ideas before we wrap up. So, what did we learn today? We started with simple portals. Something that sounds familiar, something many of us already used. But when we look deeper, we realized that in React Native, most portal solutions give us only the appearance of portals. They look visually right, but they change the React tree, they affect the context, they reshape the mental model we rely on. And that's the illusion. Teleport tries to break that illusion by moving responsibility rendering to the native layer. In this model, React keeps the original tree untouched, and native views handles the placement. And from there, we can do something that React normally cannot express. Move existing UI. Not recreate it, not remount, not reset it, just move it. This gives us smoother transitions, better continuity, and most important, a new way to think about advanced cross-platform UI. Because sometimes when interactions feel impossible, the answer is not to fight React and not to try to copy a single API from one platform and leave others behind. The answer is to look one level lower and find the missing primitive that all platforms can share. And for us, this primitive is moving UI. That's the idea behind Teleport. But I also don't think this is the end of the story. The patterns that I showed you today are only a starting point. I'm sure there are many more other interactions, use cases, ideas, and maybe even completely new libraries that can be built on top of it. So my hope is that you leave this talk not just knowing about Teleport, but with a slightly different mental model for the how UI can be built. Because once we find the right primitive, the most interesting part is what people can build on top of it. Thank you for your attention.
All right, thank you so much. That was another amazing talk. All right, we've got more content coming up in just a second. Our next speaker is from our good friends over at Software Mansion. We've just had one talk about how we can make our apps feel more performant, do a lot with portals, and there are so many other ways this performance can be optimized in different apps. And I think today, our next talk is going to be about some of that in the world of AI and talking about running AI on device. I feel like compute as a whole question, AI compute, is in the news nearly every single day. And so it's going to be interesting as we learn how to implement these AI compute and put it on the device and working like that, especially with React Native. So I'm really, really excited. I also am pretty sure we're going to get to see some live demos on this. So it's always nice when we get to see speakers with the bravery to come up and to do a live demo. So I'm really excited for this next talk. Hopefully you are as well. I know it's been a long day. Don't worry. After this, we're going to have a coffee break where you can get yourself recaffeinated and ready to close the show. But without further ado, I would like you all to get your hands ready because we are going to give a wonderful round of applause to Software Mansion's Norbert, who's going to give us a nice, wonderful talk. Let's give him a round.
So, hi everyone. I'm Norbert, and I work at Software Mansion in our in-house AI team. And what do I do here? I'm maintaining React Native Executors, which is our library for running AI models on device with React Native. I'm also building a private mind, which is our on-device AI chatbot application. And for the last year and a half, we as a team built a lot of different on-device AI features. And along the way, we encountered a set of quite unique challenges that you will probably hit too. So today, I wanted to share them with you. But first, let's start with some definition. So there are basically two places where the AI model can run: on the cloud or on the edge, which means that it runs on your user's device. And cloud is something that most people reach for first, but on-device gives us three things that we can't fake. Privacy by design, so no data leaves the device. There's no need for a network round trip, and the compute is free, because user already paid for the hardware. Of course, we have to give some things up. So the models that can run on the phone are generally smaller, and because of that, less capable than frontier cloud models. And the performance varies widely across different device tiers. And of course, the model files have to live on user device, which is a storage footprint that user can see. But creating the on-device features gives us a lot of possibilities. And if we will play our cards right, we can build something impressive. Okay, so let's start. Let's assume that you decided to create an on-device AI feature for your React Native application. First step, pick a model. And Hugging Face comes with a help. It's essentially a GitHub for AI models. There's almost 3 million of them right now, and it's still growing. And we, as the developers of the React Native executors, are hosting models that are exported and compatible with React Native executors there. So it's worth a look, because you might find something there that will fit your use case. And that was the easy part. So now we have to run this model on the device. And let's take a look at iOS side. Here we have two ways. MLX, which is Apple's general GPU framework, allows us to run the models on the GPU. And CoreML, which can route the AI model to NPU, Neural Processing Unit. It's simply a smaller CPU, but designed to run AI models. And of course, on Android, that's where it gets messy. Because for every chip vendor, we have a different NPU hardware. So Snapdragon, Exynos, Mediatek, or Tensor. Each of them needs a different acceleration path. Thankfully, there's one option that works on both platforms. It's called XNNPack, which is an optimized library for running AI models on CPU. But we have to leave the GPU and NPU on the table, something we don't want to do. And quick aside, those logos, I will reference them as backends from now. And I might use a term that the model is delegated to some backend in this presentation. For example, this model was delegated to CoreML. And by that, I mean that the model will run on NPU on Apple devices. And one more thing, an inference. If you don't know what inference is, it's basically a process of running the model. Okay, so as you can see, we have a huge fragmentation problem. And it sounds a bit familiar, something that React Native solved like years ago. So maybe we can find something similar for machine learning world. And here we have Executors. It's a framework from PyTorch team, and it's something we're looking for. It gives us a unified C++ runtime, which uses whatever acceleration is available on the device. But there's a catch, because For each backend, we need a different model file. The model that was exported for that backend. So for example, for CoreML, we need a CoreML exported model. And for XNNPAC, we need an XNNPAC exported model. But good news. If you are using models that are shipped with React Native executors, we already took care of that. Because on our Hugging Face, we have different versions of the models. The models that were exported for different backends. So when you're using our model in your application, you can be sure that your user will receive the most optimized version of the model that exists. Okay, so we picked the model and we have a way to run it on the phone. Now we need to get the model files onto the device. And why should we even bother about it? Because it's not that simple. Because the model files have different sizes. We have models that are like 1 megabyte or even a few gigabytes. And for different models, we'll need different strategies. So I will start with the simplest one. Bundle the model with the binary. So the user downloads the app from the App Store, and once they open it, the model will be there, and the feature is ready. But now imagine the situation where you are using larger model, and your app size is like 1 gigabyte. So the moment your user taps install in the App Store, he sees something like this. And if he's not connected to the network through Wi-Fi, he probably clicks later on Wi-Fi. And that's the moment the user starts to searching for different application, and we lost them even before they opened our application. So for large model, in many cases, we have to download the model in the runtime. And here I have two strategies, and we select them based on the type of the feature you created. So the first one, download on the first run. So from the App Store, the user downloads a light version of the app. And this strategy is best for the features that are like hero feature of the application. So it doesn't make sense to use it without this feature. And once the user opens the app for the first time, we start the download in the background. We might hide it behind onboarding or something like this. So user is setting things up, and the model is downloaded. And when user is ready, the model will be ready too. But what if the feature we created is like optional, and not every user might use it? In this case, we can defer the download even further. So we can wait for the user to actually try to use this feature. And then we might prompt him to actually download additional content. And while he's waiting, you might explain to him why on-device AI is amazing. And both download strategies require some plumbing, like fetching, caching the files, and handling partial downloads. And we had that problems, and we created a tool called Resource Fetcher, which is integrated in React Native executors. It gives you all the necessary things that you will need to implement those two strategies without the problems. And what if you decide to change your model? So you are browsing Hugging Face, and you see a brand new model, which was exactly built for your task. And you check the benchmarks, and it's twice as good as the previous model. So if you, in the previous step, you selected the strategy with bundling the model in the binary, you have only one option, which is roll and update. Then you wait for an App Store review, and then you wait for all the users to actually update the application. It's slow. So if you plan to update your models more often, I might have something better for you. But you need to settle to downloading the model in the runtime. OK, so here's how it works. You create an API endpoint, which returns the current version of the model. And you host the model on the server or on Hugging Face. And when the user loads the model in the application, you hit that endpoint and you compare the versions. If they don't match, you ask user to download an update. But you have to pay a lot of attention to making sure that the new model is actually following the same contract as the old model. Because if they won't match, the user will see an error. And you have to update the model once again, and user needs to re-download it, and it can get messy. OK, so we pick the model, we have it on a phone, and now we run it. What can go wrong? OK, so the model didn't fit in RAM. And to be more accurate, the model didn't fit in RAM on some devices. iPhone 70 Pro has 12 gigabytes of RAM, and you can trust me that really large model can fit in there. But iPhone SE3 has only 4 gigabytes. So here the same rule as, for example, for game dev or working with animations in React Native applies here. So we have to set the bar to the worst device that our user might use. But what if you created an AI chatbot application in which user actually picks the model which he will use? We have to stop him from using the model that won't fit on his device. So here's how you do it. First, you estimate how much RAM each model that you offer requires. Step 2, you check how much RAM there is on the user's device. And step 3, you filter out and hide the models that won't fit on the user device. And what will happen if the user tries to load the model that's too big? The app might crash. And yeah, that's like the worst thing that can happen with the application on user's device. And what if you created a feature with a fixed model? So every user will get the same model on every device. So you have to simply make sure that the feature works all right on the worst device from your audience. And if it will work there, you can be sure that it works on the rest. And here's an example. So another big problem, performance gap. So on one side, we have a bit older Android, Motorola Moto G04, and on the second one, iPhone 70 Pro. Both phones are running the same model, and the model on both phones is running on CPU. And as you can see, on the iPhone, the model manages to finish its task at least 5 times before it even finishes on Motorola. And there's no good solution to this, because we can't make the hardware faster. So our only option is making sure that the feature is actually working all right on the Motorola, and then we'll be safe that it will run okay on better phones. And inference. Inference is an expensive operation. And when we run it on a CPU, and if we run it often, it's using a lot of it. And because of that, our phone overheats. And operating system will simply decide to throttle the clock to protect the hardware. And our FPS at that moment go down. And of course, the power for that CPU is coming from the battery. So if we will keep using it that way, we might use all of it in just one afternoon. Definitely not a perfect situation. So what are our options? And there are actually 3. So the problem with the continuous inferences is mostly the problem of processing frames from the camera. So imagine that you are doing that 30 times per second, and in that case, many frames can be in bad quality. So user moved the phone and the frame is blurry, or user covered the camera of the finger and the frame is dark. So in that case, we don't want to run an expensive operation because we'll get a trash output. So we create a cheap pre-filter that checks the quality of the frame, and if it's bad, we simply skip the expensive operation. Second, throttle the rate. It's always cool to run inference 30 times per second, but it might not be that cool if it goes down to 10 after 20 seconds. And in most cases, we don't have to do it that often. We can create features which run in like 5 FPS, and the whole thing will still have that real-time feel, but it has 2 benefits. The first one, we lower the gap between the devices, because we are setting a target for cheaper devices to reach, and the expensive phones actually have more time to rest, meaning that there's less overheat and we use less battery. And third, if it's possible, use a hardware acceleration. So NPU is smaller than CPU, so automatically it uses less power, and it was created to run AI models. So model running on NPU will run faster than on CPU. So we have a faster model, and we are using less power. And as I said previously, if you are using models from React Native executors, you might be safe that if it was possible, the model will use the NPU on the user device. But if you plan to export the models yourself, yeah, that's one of the most important decisions that you will make in the whole thing. And here's another example. On both videos, we have the same phone, iPhone 70 Pro. And on both, the same object detection model is running. Only difference is the hardware. On one side, it's running on CPU, and on the second one, it's running on NPU. And as you can see, the difference is huge. The same model is 2 times faster on the NPU. Okay, so let's sum up the part with the challenges. We started at the point where we picked the model, and then we settled on the runtime. Then we learned how to ship the model files onto the device and how to keep them updated. And last but not least, we learned some optimization techniques. But during our journey, we learned more things. So here comes the hot take. General purpose small language models are for viral demos, not products. And small language models, those are just LLMs, but with fewer parameters. They can fit on the phone. And I don't want to say that on-device LLMs don't make sense and are useless, because they are not. We can still build some amazing features with them. But the hype around them is much bigger than their actual product value. So now I wanted to talk about fine-tuning. So training the model so it's good at just one task. And here for a reference, I picked LFM 2.5, which has 350 million parameters. It uses less than 1 gigabyte of RAM, and it's actually a small language model, the one I just trashed on the previous slide. And out of the box, this model doesn't have too many talents. But if we will train it to do just one thing right, it can match the performance of cloud models like Opus 4.7. In some cases, it can even beat it. And look at the possibilities. It's just a fraction. But things like tool use or intent routing or named entity recognition. If we get the training right, the model can be excellent at any of these. And fine-tuning such a small model is relatively cheap. So tools like Cloud Code or Codex, they can write a training pipeline for you. And then you rent a GPU cluster, and you will be done in hours. And here's a proof, a case study from Liquid AI. They took a 450 million parameters VLM, also a very small model. VLM is Vision Language Model. It's basically an LLM that understands images. And they selected the dataset, wildfire risk predictions, which consisted of satellite images, something like on the slide. And the first step was to run Opus 4.6 on it. And as you can see, it did an incredible job, 99% accuracy. And the out-of-the-box version of the VLM only scored less than 40% of accuracy. But after fine-tuning, the accuracy goes up. And they actually reached an 85% of frontier model accuracy. So my conclusion for fine-tuning would be that the small models that will run on the phone will never match the cloud models on general tasks. But if we have a specific use case for them and we train them to do that one thing right, they can match the performance of cloud models. And we have a performance of cloud model while still having the benefits of on-device AI. And here's some example from me. So we don't have to stick to using just one model. We can build pipelines that are using 2, 3, or 4 models. And it's best for a vision task. So now imagine that you are collecting Funko Pops. And if you don't know, a Funko Pop is just a small figure with large head, and it's generally a character from movie or TV series or games. So yeah, you have a lot of Funko Pops in your room, and you decide to digitalize your collection. So let's see how such a feature can look like. So first step is getting the database, your reference set. It has to have all the Funko Pops that were ever created. And most importantly, for each you need an image. I know, a bit hard requirement. But now let's move to the React Native app part. So the first stage will be finding the Funko Pop on the camera frame. And here we can use an object detection model, best if it was fine-tuned for finding Funko Pops on images. And the first step is actually scanning the Funko Pop. We detect it on the image, and we crop it. And here comes the second step. So image embeddings. Image embeddings model takes an image as an input and translates it into a vector. And this vector will be our mathematical fingerprint of a Funko Pop we just scanned. And most important part is that we need to use the same image embeddings model for each image of Funko Pop we have in our database. And on device, we save only the vectors with some metadata, for example, name for Funko Pop. And first step, we take the vector we just computed from the Funko Pop that was scanned, and we compare it with the vectors from the database. And the one that's most similar will actually be the Funko Pop we just scanned. So we take the name and we save it to our collection. And best part, such a pipeline can be very light. I mean, it can use few hundreds megabytes of RAM, and it runs in less than 200 milliseconds, even on older phones. Okay, so now it wouldn't be a complete presentation about on-device AI without the live demo. So here's something I created with React Native executors. And this library allows you to work with different types of data, which are audio, vision, and language. And the demo I created is actually using all three of them. So yeah. Let's take a look. Oh, so that's how it looks from here. And here's how it works. Tell me what you see.
I see a small stuffed animal being held in someone's hand. The toy appears to be gray and has a tag attached to its chest. It looks like it might be a bear or elephant, but without more details, I can determine its exact species.
Okay, so it's actually a pipeline built from three models. Speech-to-text for transcribing the audio into a text. Then a small VLM, which takes this text and a frame from the camera as an input. And it generates the description. And then we use text-to-speech to generate the audio from the text that was generated by VLM. And if you didn't catch it, the model actually used my voice to read the text. So let me show you once again. What do you see?
I see a laptop on a desk with its screen displaying what looks like a game or application. The room is filled with people seated in rows, suggesting this might be an event or conference.
Right. So the thing with my voice is actually called voice cloning. But yeah, I think the time is up, and the magician never reveals all of his secrets. So that's everything for today. Thank you very much.
Thank you. All right, folks, we are going to have a short break. We'll be back here in about 15 minutes. Go and make sure you have a coffee. We have our wonderful friends upstairs who can have a coffee for you. Also, there will be a live studio interview. You can watch that as well with Flip, who will be joining us as well. All right, see you after the break.
Hello, welcome back at Studio Live, the live interview panel during App.js. Here with us is today Filip Kamiński. He's a creator of Argent. Also, he's a software engineer at Software Mansion. Hi, Filip. What's your favorite talk this evening at App.js so far?
Hi, Kacper. Thank you for having me. I think Ivo Talks was the best. He has an amazing product, and he has this quality that he can lie to the public and still get away with it, like just by showing how it works at the end. It was amazing talk.
Talk about TypeGPU, right?
Yes. He was kind of showing a pseudocode in the middle of the talk, and then he was just like, yeah, it's too simple to be an actual code. Oh, wait, that's actually TypeGPU. You can just use it.
Wow.
Amazing trick.
Cool. Okay, so Filip, as you are the creator of Argent, I have to admit that I haven't used it yet. So, and I'm not completely sure how does it work. So, can you tell us what is it?
Sure. So it's a set of tools that we provide to your agents, either via MPC server or CLI, that allows agents to control the simulators and emulators, test your application, make a profile, use the debugger. Actually, anything you need to verify the results of your agent's work, the agents can now do it themselves via agent.
So in terms of testing and also performance testing, yeah?
Yes, so agent works in multiple ways. It can either perform a performance assessment and check if your application works good or if it has any redundancies in renders, for example, in React. Or it can work as a kind of plugin to your development workflow. When you ask an agent to do something, let's say create a feature that shows a picture, and then an agent creates a code and can test if this code actually works in real time, and you just need to ask it to not come back until it works.
It seems kind of like end-to-end testing. How does it compare with end-to-end tests and Maestro, for example? Is it similar? Is it different?
So it is different because agent does things in real time by checking by clicking through the application after creating a feature, or just because you asked it to reproduce some issue that you never seen before, so there couldn't be any test for it. But we are moving towards each other. So it's kind of like AI glasses and AI goggles. They both want to be small and do everything. And AI glasses start from being small and move towards doing everything. And AI goggles start by doing everything and moving towards being small. We are creating features that allow us to store previous sessions, then check them grammatically, create those flows. But our main focus is to test new issues or new features and move from there. The end-to-end testing world moves from the opposite direction. So you first need to know how something works or should work, and then you can move from there.
But by the nature of agents, the agent has to be non-deterministic compared to end-to-end stuff like Maestro, isn't it? Right?
Yes, sure. So agents are definitely unpredictable by definition. So they create something, they then test something, but it's more about testing if the requirements you provided the agent are actually met before coming back to the developer that maybe needs to fix something, but before using agent, you needed to check that it's completely broke, then tell that to the agent and iterate multiple times until you had actually a working solution. And that's what we are providing.
Okay, and does it work only with React Native applications?
No. It works with any mobile application. Soon it's going to work on physical devices as well. We're thinking about web. So any application you can think of is able to click through it and test it.
Cool.
It's pretty new, I believe. Is this experimental, or can I use it like not maybe on production, but because it's not something you would use on production? It's a local dev tool. But is it stable-ish or just experimental for now?
So we have a bit of an advantage because we work with agents. So it's always stable. If it's not stable, an agent is going to figure it out. But yeah, all the functionality that we ship works. It changes very, very dynamically based on the user feedback. But it just works. You can use it. We actually have almost universal adoption in Software Mention. So internally, we use this tool. We test it. We get feedback from employees at Software Mention. And also, we have a growing base of users outside of Software Mention that heard about Agent and just wanted to use it.
So I have a tricky question. Are you trying to replace the developers at testing?
Wow, Zuza, wow.
Okay, I know why this would be a worry for developers such as us, but no. What we're trying to replace is developers wasting time fighting with something that they don't need to. So agents can perform many things in a sufficient way. They can produce code, they can even produce features for mobile applications, and they sometimes break. And right now, developers waste a lot of time either checking if it works, or they don't believe it's going to work, so they waste time doing it by hand. And we're trying to squeeze that gray area and just replace anything that could be done with agent with agents that can verify their work. And that way, developers can focus on something that is actually undoable by agent.
Which is?
They are more complex stuff. You can have a system that has a lot of moving parts. Maybe you have to integrate with some outside system, or you need to create multiple parts of, I don't know, banking application or something like that. Agents are not very good at coordinating those steps, so you should put your energy into doing that. But with Agent, you can make sure that each of those steps that you defined and have clear requirements for is actually met when Agent works on it.
So to simplify it, very, very simplified, Agent lets your agent click on the simulator, but that's not all out what it does, right?
No. So this is the basic functionality that enables everything else. We can control.
What else can it do? Yeah.
Yeah. We can control the simulator, and during that we can start a profile and do it autonomously. So the developer doesn't need to think about it. He can, but doesn't need to. Use the debugger, inspect the hierarchy view. We are moving towards supporting any developer toolkit that exists for developers today for agents, because those toolkits are very good at capturing what's important in your application. And we just need to take that information that we already are collecting in developer tools, in things like Radon or anything like that, and we can take that and put it into the agent so he or they have context as well.
So how does it work actually? So we know what is it, what it does, but how does it work actually?
So from outside, it's MCP server that you connect to the agent, and MPC servers are just collection of tools. So we have tools like gesture or tools like take a screenshot, and this collection of tools is either a very simple implementation, like in the case of connecting to the debugger. This is a very simple thing. You can use CDP connection. Thanks to folks at Meta, it works universally. And there are some more complicated tools, like gather the profile report. And we have tools such as this. It's actually 3 tools in one. We take native report, React report, React renders report, and the JS CPU usage report, and then we combine them to connect render with the function that triggers this render, or to connect JS function with native function that is connected to it, and flag anything that takes too long or any renders that might worry us and should worry an agent.
So I want to know your personal opinion if testing the application manually is still something that we need, or should we trust the agent completely?
So there are 2 problems with not testing manually. One problem is that you can give requirements to the agent, but like Kacper said, anything that agent does is unpredictable. So it can check it works, but you need to check if it works like you want. And the second connected thing is taste. You always want to check if the results of your work are something that you actually like, you think your users are going to like, and at least right now any model cannot replicate human taste, so you have to just check it by yourself.
Yeah, understandable.
Are there any new features coming? What's your roadmap maybe? I don't know, the AI space is changing so quickly, so maybe not for the next half a year, but something like next weeks or something?
Yeah, so next week we are going to drop screen diffing. It's a visual comparison tool. You have a screenshot of your design or a screenshot of your how the application worked previously before the changes, and we are programmatically comparing it to current state of the application. LLMs sometimes can miss details between pictures that either look the same or are the same. We can actually check it and tell the agent where are the differences. And in like few weeks' time, we are planning on supporting physical Android devices. We are constantly listening to the feedback. So if anybody listening to this wants to give us an idea for a feature or something they use and they want in agent, we are all ears.
And that will be all. Thank you very much, Philip, for being here with us.
Thank you. Thank you so much.
So that will be all for Live Studio. Thank you very much. It was a pleasure being a host. And
thanks so much, everyone, for watching. Bye.
See you next year.
One of the things that I want to tell people is that social connection is important. We all live now in a world where a lot of us work remotely, but there are a lot of things that are baking right now. And coming to a conference is a good way of really getting ahead of the curve. So I definitely recommend properly interacting with people and getting to know the React Native community.
I had a conversation with one developer that was working on something, and I learned a ton about how we could optimize things in my React Native project. I think that's incredible. That access and that community that App.js provides is unparalleled.
Good morning, everyone. It is so good to be back here, App.js 2025.
And you can just feel it. I mean, it's so crazy when we're here because there's so many of these just apps that I use every day. And the author is here. He's talking about like how using React Native has drastically improved their workflow. Exciting time to be an app developer.
All of the engineers that I really admire are here, so it's like a pleasure to learn with them. So yeah, I'm enjoying. It's pretty cool.
A drink.
Wait. One more thing. There's one more group of people we need to thank.
Yes.
It's the audience.
The audience, yes. Can you give yourselves a round of applause?
I know.
You're at
very hard
home.
for your Islamic.
Yeah, a standing ovation for yourselves.
Round of applause.
That is awesome.
All right.
Thank you so much.
Thank you. It's a day of learning, and let's have fun.
There's not enough. Hey.
2 hours later.
Hello, everyone. This is the RTC on 2025.
So it's quite retro, it's quite fun. Let's see whether or not we can kind of make it real time. I don't have any backup here.
I felt kind of compelled like to break more stuff and, you know, in the process of trying to make them work. So, yeah.
I build stupid things for people.
I'm doing Elixir for life. We met the only Elixir developer who's actually paying his bills with Elixir, so it's very impressive.
How do you like the conference?
Very, very interesting stuff. We love Vulkan Video, we love Rust.
Really, really good. It's my first time here.
As a nerd, I have to admit that I'm really keen to this mock thing.
We have a strong team of speakers this year. Everyone's very cool.
A lot of topics during the conference that I really enjoyed.
But here it's very cozy. Everyone's very friendly. It's so cool. Anyone who's working in this field should definitely come.
Forget that. I'll start again. I forgot what I said at the beginning. So, productivity.
Elixir is great technology.
Maintainability.
And we just need to...
And readability.
Do a better job of marketing it.
Okay. Well, definitely what I appreciate the most about Elixir is the Elixir community. Boom. Cut. Yeah.
Modern people don't really want to go deal with all those curly brackets, and Jose, I think, has done everybody a great favor by enhancing the language and making it much more useful in the modern day. So it's going to be an interesting afternoon to figure out how we apply our resources to things.
So we learned all these hard lessons, building software and failing. And you take those lessons and you learn to value a new set of priorities, right? And Elixir sort of embodies those things that people don't know are important when they're first starting out. You know, when you're first learning to program, the properties that Elixir actually provides, it's difficult to explain why those matter. And so that's one of the things that we've seen, is that it's filled with people who have deep experience, deep nuance and understanding of like what goes into good engineering and how we make software that will stand the test of time.
Folks from Software Mansion reached out. They said, look, we do this kind of summit with React Native. It could be interesting to have that for the Elixir community as well. So it was the perfect moment, the perfect place.
This might be the most unusual React Native workshop you'll ever attend. Why? I work in a villa on a Croatian island. Small groups up to 10 devs.
Led by the people building the tools you already use.
You learn how to build Expo modules and master the entire EAS ecosystem.
Then we'll dive into Reanimated, Gesture Handler, and Worklets.
We cover the new architecture, performance profiling, and JSI, and we'll finish with a consulting day to solve your app real problems.
Sounds good? Book your spot and see you by the pool.
Hello guys, today we are at Software Mansion with Meet.js, and this is meetup focused mainly on JavaScript and front-end development, although we have a variety of topics.
We're kind of trying to push the boundary of what's possible on the web. It's always been possible, but we're trying to make it easier than ever.
This meetup is perfect for people to see how their web knowledge can be applied in mobile world.
I love the energy they conveyed in the presentations.
So this is the kind of place where you can do Johnny Slider as a part of your job.
We are at the meetup in Software Mansion office, which is called Build with AI DeepMind Mansion, and this is edition 5. My name is Mateusz Kopciński. I'm the lead software engineer in-house Software Mansion AI team. And we are mostly focused in convincing people that Edge AI is a good idea and that they should consider it in their next product.
I'm Philip. I work here at Software Mansion, and my talk was about the performance on local models. Developers, after my talk, should consider using tools that reduce context use. They should consider either using a sub-agent for gathering this required information or using the dedicated tool. I don't think it was very controversial. Mateusz's talk was very similar and we agreed. So at least in Software Mansion, we have the same mind.
Hello and welcome to the last stretch of day one at App.js Conf. You are the people who have seen us through the whole day. Thank you for joining us for this very last part of the day, whether you're here in the room or you are joining us online. So there are two more talks today before the after party that's being run by CodeRabbit. The next talk is run by two absolutely lovely people who've had a lovely time backstage. Kacper is an open source engineer working at Software Mansion, where he maintains React Native screens, which is the underlying library behind both React Navigation and Expo Router. Jakob is a software engineer who works directly on Expo. And I have it on good authority that during this talk, they're planning an announcement. You want to know what it is? Great. Stay in your seats then and listen to the talk. Heads up. All right, I'm going to hand it over now. Yeah.
Hello, everyone. Yes. Imagine you're creating a new React Native application. First, you make the designs. Then, you hand them over to an agent. And after a moment, you get a set of beautiful... Can we get a slide, please? Yeah. And you get a set of beautiful React Native screens. But now comes a problem. How to connect them all together? You could either implement all the transitions and navigation yourself, adding links, handling state, detecting bug gestures, and so many, many different things. But most developers don't want to implement navigation solutions from scratch. That's where Expo Router comes in. Expo Router is a file-based navigation solution where each file represents a single screen in your application. You can compose them using different layouts and navigate between them using the API the library provides. And what's more, adding it to your React Native project is quite easy. It's just a few simple steps.
Yeah, exactly. You just install a couple of React Native packages, and you are ready to go and create another awesome React Native experience. But have you ever asked yourself, guys, what do you install here exactly? Because if you did, then it's your lucky day today, because I will be talking a bit React Native screens and its place in the ecosystem. Before we introduce ourselves, let me give you a word of introduction. React Native Screens is a collection of building blocks for the navigation solution, giving library authors, such as Expo Router, the opportunity to build a comprehensive navigation solution based on the very same primitives the native application use. We'll talk about it just a bit more in just a minute, but let me reiterate the fact that React Native Screens is not a standalone navigation solution. It's only a set of primitives, building blocks allowing anybody to build a navigation solution. It is not one by itself. It takes two to tango. It takes two to build a fully fledged navigation solution. Hence our cooperation with Downstream, hence our cooperation with Expo Router. Hi everyone, I'm Kacper. I work at Software Mention. I'm maintainer of the React Native Screens project for a couple of years now.
Hello everyone, I'm Jakub, and I'm the maintainer of Expo Router. Today, together with Kacper, we would like to tell you about our cooperation, how we work together to bring native navigation components to React Native. We will tell you what we built in terms of what native components we expose, how these components work under the hood, and at the end, we will tell you about the new features which are coming. Okay, so let's get started. The collaboration between React Native Screens and Expo Router was there from the very beginning. Back when Expo Router was first introduced, our teams were already working together. For many years, that collaboration helped both projects evolve side by side. You, as the users, have shipped many production-grade applications, making Expo Router and React Native Screens the standard for navigation in React Native. And then came the announcement of iOS 26. That's when we realized that the role of native navigation will become even more important. That's when our team started working together to bring more native components to React Native. And we started with bottom tabs. At first glance, bottom tabs look very simple. It's just a few buttons that change screens. But if you zoom in a little, you'll notice a new visual design with the liquid gas. When you scroll, the tab bar collapses. And if you zoom in a little more, you'll notice the subtle blur effect around the edges. All of these behaviors are technically possible to be created in React Native, but the implementation would be complex, and with every minor change in the platform behavior, we would need to adapt our implementation. So instead of reinventing the wheel, we decided to use the native primitives.
Yeah, Kuba has just shown you pretty hard to reproduce visual effects and behaviors the platform provides for you. But on the same note, I would like to show you what actually needs to happen to reconcile platform navigation approach with React Native. Let's take a look what takes place for navigation to happen, what needs to happen for navigation to take place. We'll consider simple scenario. Let's see the setup. Okay, we have a React Native application with simple screen, couple of navigation destinations in the tab bar, and user presses in. The tab changes, no fireworks here, but all it seems is that all we need to keep track of is just what tab is currently selected and what content to show on the screen at the given moment. But we need to start the explanation of what really happens under the curtain with some understanding that React Native is an asynchronous system. Like, high-level overview is that there are two important threads involved. There is the JavaScript thread, and there is the UI thread. The UI thread is, of course, responsible for drawing the views and displaying them on the screen. But importantly, it's responsible for user interaction. So whenever a user touches the screen, it's the UI thread who learns about those events first. It learns about the touches, it learns about the gestures, and that implies it learns about the button presses. And we are able, as programmers, to react to those events on the UI thread synchronously. Okay, so with that knowledge in mind, let's proceed. The user taps. We detect that, and we need to do quite some bookkeeping. We update the native navigation state, and I want to reiterate here that it's navigation state. We need to send an asynchronous event to the JS side of things to notify the JS side of the implementation of user intention to change the tab. We prepare the transition. Clicker, please. We prepare the transition. Oh, yeah, let's swap. We prepare the transition and we prepare the update the appearance of the newly selected tab. As that happens, the asynchronous event reaches the JS side of things. This is exactly where Expo router comes into play. They receive that event, read its payload, they learn about user intention of tab change, and render appropriate content that should be displayed. Likely, in case of Expo router, the content will be already rendered ahead of time, so at the moment of tab change, the content is already there to be visible. But I want to bring your attention to that place in the slide, in the timeline. This is here where you can have different rendering strategies. For example, you can have skeletons, loading screens, etc. Okay, so that's a user-triggered flow. Let's see what happens when you navigate programmatically. This time, it's Expo router who learns about your intention first. This happens on the JS thread. Expo router updates the JS navigation state and decides what to render and how to render. It triggers the React, and when the render finishes, React Native Screen's native implementation observes effects of that render. We notice it, and we do very similar steps I just showed you a minute ago. We prepare the transition, we update the appearance, and most importantly, we send an acknowledgement event back to the JS side, notifying it that the transition has finished. I want you to focus on that confirmation event right now, because it indicates that I have just talked only about the happy path. I want you now to consider what would happen if the timeline instead looked like this. What should happen if at the same time you start to navigate from JS as JS action, user also expresses its intention to change the tab? Of course, on UI thread, we do not know anything about your intention you sent from the JS side yet. Therefore, we need to react to that user tab. It's only information we have. But what should happen? User tabs, we change the tab. What should happen now? Should we acknowledge the JS request? Should we change the tab only a couple of milliseconds after user had already changed the tab? Or should we reject the update? Another question, what should happen here if Expo router, for example, is queried for the navigation state, when already something happened on the UI thread? I want to point out here that there are a couple of questions, maybe more than a couple of questions, that you actually need to answer when implementing state-based navigation solution in an asynchronous communication system. And this is exactly the slice of the complexity that Expo router, together with React Native Screens, handles for you. Okay, that could have been much, but I promise you, I still hope you bear with us, because we're climbing out of this rabbit hole. Back to Kuba.
Thanks, Kacper. Whoa, that was a lot. Let's talk about something a bit lighter now. Let's talk about how native tabs were created. It all started with Kacper and his team implementing the simple proof of concept of native tabs. It was something like similar to what Kacper just described, but a lot simpler. Then we took these proofs of concept and integrated it into Expo router. To do so, we needed to create a navigator. And for those of you who don't know, navigator is a component. It's a component responsible for combining your screens together and allowing for navigation between them. Under the hood, navigator works like a state machine. It has a state which in case of native tabs, is a list of routes and an index of currently focused one. And then it receives actions from users. For example, navigate from home to about. Then, as any state machine, it takes the state and the action and produces the next state. As you can see, the list of routes stay the same, but the index did change. However, this navigation logic is only half of the story. The other responsibility of the navigator is to render the state on the screen. And this rendering pipeline is exactly what Kacper just described. Back to native tabs, though. We implemented the navigator, the native tabs component. Then we started testing. We created several different applications, and whenever we spotted some issue or missing feature, we reported back to screens. Then they improved, and the iteration cycle started again. After a few of these cycles, we decided that we are ready to release. We released native tabs September last year and received feedback. Actually, we received quite a lot of feedback. As you can see, people started opening issues, saying to us that some features are missing or things are just not working in specific edge cases. In case of Expo router and React Native screens, these issues can be grouped into 3 categories. The first category are the JavaScript issues in Expo router. Those can be, for example, that the tint color is not passed from router to screens. Then, there are native issues in React Native screens implementation. This can be, for example, that the icon doesn't render in tabs in some certain build scenarios. And lastly, we have the most annoying group of issues. The platform issues. Those became very apparent with iOS 26, where some animations were not working, or the background of icons were just moving without an icon. When we get a report of such an issue, we usually try to find a workaround. But sometimes, we cannot find a workaround, and the only thing we can do is we can report to the platform vendor, to Apple or Google, and wait for them to fix the issue. So, to recap. So far, we've told you about how we work together and our collaboration on the daily basis, how the native navigation works under the hood, and specifically the protocol we have for the native tabs, and the responsibilities of each of the solutions. And now is the time for the most exciting part, the new features. Since last App.js, we've introduced many new features to our solutions. The first one, the native tabs, we told you about in our talk. Then, the link preview, which allows you to preview the next page you're going to navigate to.
Maybe try this one.
Does it work or not?
I will slide for you.
Thank you. Zoom transitions, which allow you to smoothly navigate from a small element to the whole page. Kacper, can you change? Thank you. And many, many more, like data loaders, middleware, and toolbars. But there's one more big change coming. Since the very beginning, React Expo router was using React navigation under the hood. Thanks to the collaboration with React navigation team, we were able to quickly ship and release Expo router. For many years, this collaboration, thanks to the help and collaboration of the... Anyway, after many successful releases together, we decided that it's time to integrate with React Native screens directly. For you, users, there is not much of a big change coming. The only thing we need to do is change the imports from React navigation to Expo Router. We are also collaborating with the React navigation team to create a standard library for library authors to support both Expo Router and React navigation without an effort. And yeah, lastly, I would like to thank the whole React navigation team, and especially Satya, who is probably somewhere here in the audience, for the great work they put into maintaining React navigation, and for the great collaboration that we have. Let's have a quick round of applause for them. But that's not all. Let me hand it over to Kacper.
Thank you, Kuba. So, last year, around the very same time, we decided to jump on the new tabs, the native tabs implementation train. We also decided that it's high time for some bigger changes in React Native screens. Over the last 8 or so years, the React Native Screens project has evolved much. We started with using crazy hacks like setting position left 9000 to force the native platform to just de-attach the view from native hierarchy. You can ask me about it later. To pretty reasonable usage of native navigation containers exposed by the platforms. I believe as the very first leap back in 2022, we've added support for the new architecture and maintained it side by side with the support for the legacy arch back to a barely month ago when we released the version 4.25.0. And I want to share with you, and that's public, that from this version onwards, we will be supporting only the new architecture, so it's high time to migrate. Moreover, in recent months, in addition to developing the native stacks, we also shipped a couple of new navigators. This includes the native tabs we already showed you, also the split view that was often requested when we talk with you, with community. During this period, we've actually learned so much and noticed that some of the architectural decisions that we made back in the years can be adjusted to the new architecture, and we can get rid of a couple long-standing issues we've been suffering with. That's why we've decided that it's high time to pay the accumulated technical debt we store in our repository and rewrite the native stack. I'm happy to share with you that new native stack will bring better stage management. This especially relates to the asynchronous state management problems that I talked to you about a couple of minutes ago. This is especially important for the downstream. We'll have more reliable view lifecycle events. This is also crucial for the downstream. We'll have predictive bug gesture support for Android, and we are doing overhaul of the models API we expose. I share with you that all of this will be shipped with new release of React Native Screens 5.0, which will be available soon. And most of the APIs are already available for testing in downstream packages, including Expo Router, today. The works are already in very advanced stage. You can expect that soon. Thank you, guys. That's all from us today. We'll see you in the venue. Feel free to ask about anything. Thank you. Peter. Let's go.
Okay, next time. Okay, hello everyone. Right, we are down to our last talk of the day. Before we kick off, those who are able to get up to your feet, just trust me, please. Come on, we can do it together. We can do it. The person next to you's done it. You're like, oh, do I do it? Yeah, the answer is yeah. If you're able to, good. We're just going to do a little stretch up. Come on, we're doing it. You know, I know, just taking a little stretch for your body isn't something we're used to doing. Just a little stretch down towards your feet. I appreciate those of you who kind of really did a half-assed effort there, pretending like I wouldn't notice. You can sit down now. You know what? We like a little stretch. It's about that time of day where we should be doing it. You've been sat for quite a long time. But yeah, those of you who were like, oh yeah, let me just do this. You know what? Power to you. Power to you. Good deception there. We are just about to move on to our last talk with the most gorgeous slides. I'm really, really excited for you to see them. And also an interesting topic. Before that, I want to introduce our speaker, Raphael, who is co-founder of OKThink.ai and has been building software for about 20 years with a pretty long stint in React Native. Now, I think it's fair to say that we kind of understand that chat is like a lowest common denominator interaction for how our users interact with AI. But what happens when we start to move beyond that and think about implementing AI for our users in more creative ways? That's what the talk's about. Now, this is our last talk. So when I say I want a 10 out of 10 clap, I'm not messing around. None of this 8, 9 rubbish, right? We're going to go full on 10. As much energy as you can give Raphael now.
Hi, everybody. How's everybody doing? How's the first day of the conference? Nice. I got the last talk, which means that I can go as long as I want, which is amazing. So if you want like a tight talk, just give me 1 clap. If you want the super long talk, give me two claps. All right, awesome. Let's do it. Yes. All right. So I have gone a little extra with this presentation. So I'll be honest, I spent a lot more time programming it than actually practicing it. So hopefully this will all go really well. I want to thank App.js and Software Mansion for having me. I'm very lucky to be in Krakow here with the best developers in the world. I honestly believe that Poland, everybody should come to Poland and pay pilgrimage and get to meet Polish developers in the React Native community. This is one of the smartest places in the world right now. And if you're watching on the live stream, you should make sure that you come here next year. I've been here 3 years in a row. I absolutely love it. I definitely recommend it. So just so you know, I'm going to be looking at my phone. I'm going to be controlling my presentation from my phone. I might also just be looking at TikToks in the middle of the talk. I'm pretty addicted. But yeah. So before we get started, I want to get you to scan this QR code. You're going to be able to join the presentation live, and we're going to do something pretty fun. Hopefully the Wi-Fi cooperates. This is a very Wi-Fi heavy presentation. But hopefully it's a very light data experience for you as the users, because we're going to be talking about server-driven UI. So we're also going to have, this QR code available throughout the presentation. So you can join right now, or later on when you feel like it, you can also join. Wow, I did not calculate how distracting that might be. But all right, it's great. So I've been a React Native developer for a long time. And with everything happening in AI right now, I've had this question in my mind over the last year and a half, really, which is, are apps dead? Has anybody else been thinking that? Let's see. Most people say that only the boring ones. Yeah. I kind of think that, but I think the way that we make apps is going to significantly change. So we're going to talk about this, and we're going to talk about this in 3 chapters. First, we're going to talk about ancient history, which is like the 70s. Then we're going to talk about the discourse in the industry right now. And then we're going to do like a little technical dive on something cool that we can do with server-driven UI and AI. So I'm going to tell you about who I am, but first we're going to talk about video text. Anybody here familiar with video text? I grew up in the US, so I have no idea about it, but apparently it was a big thing in Europe in the 70s, 80s, and 90s. So yeah, video text is a term that I couldn't find a better term for it, but it kind of, wow, those emojis are very distracting. So it's like the proto-web before the web. So this is an important time in history to pay attention to, because this is when engineers were figuring out how to deliver data to consumer screens. And so these are the direct ancestors. We're going to talk about the direct ancestors of the modern World Wide Web. And these platforms introduced the public the concept of like going online before the web. So first of all, we're going to talk about CFAX. Do we have any British people here? Nice. Nice. I've never seen CFAX in my life, but it sounds really cool. As I was researching it, it's a really, really cool technology. CFAX is a phonetic play on CFAX. And it holds the title for the world's first public teletext service. This was a technology that was invented by the BBC. And, oh yeah, I love how you're showing your British pride right there. It was originally built because, it was accidentally built because engineers were trying to figure out how to deliver closed captions. And then they realized that in TV scans, there's like a little gap in transmission where the TV resets after it draws a frame where they can send like a bunch of data in between video frames. So they leveraged that to be able to deliver actual screens. So these were screens that in your TV you could navigate to. But the way that it worked was that you could pick out of a bunch of screens that were being delivered via the signal, and you weren't really requesting it on demand. The signal was just cycling through all the screens that it was delivering, and then your device at home would cache the screens and let you pick from that cache. So it wasn't two-way, it was just one-way delivery, but it was a really cool technology. And so this is what the CFAX actually looked like. This is, I think, my second time ever seeing a CFAX, but it looks kind of cool. Really, really nice aesthetic. We should bring it back. I'm serious about that. So the important part about CFAX, we start with the idea that your screen is being composed somewhere elsewhere outside of your client device. So do we have any French people here? Yes. I've heard a lot about Minitel. I kind of wish I had experienced Minitel. But Minitel was the internet before the internet. France really pulled one out of the hat here, and they were far ahead the rest of the world when it came to digital communication. So it came out of an effort to try to replace the phone book. So French Telecom wanted to stop sending phone books, as far as I understand. And so what they did was they just started delivering these like reader terminals to homes. And so this is one of the reasons why Minitel had such wide adoption in France. So taking very similar underlying video text technology, they were able to distribute, or they were able to deliver screens into homes. So by 1985, there were about 1 million terminals in homes. By the early 1990s, there were like 6 million terminals connected. And it had something very similar to the App Store, where there were more than 25,000 services. And so this is a picture of the Minitel. It's the object that people had in their homes. It looks like a little computer, but it's not actually a computer. It's like a dedicated reader. So it's not a general PC. But again, the services and the user interface was composed somewhere else, and then the client rendered it according to its rule. So this is what the protocol for Minitel looked like. And so it wasn't actually like delivering apps or anything like that. The client wasn't delivering like an app or anything like that. It was just delivering layout instructions. Very similar to what we do with server-driven UI nowadays. And so the terminal had the ability to receive instructions and to send key presses, and then the servers would determine what needs to be shown to the users next. So this is an important part of server-driven UI history, I think. And then, do we have any Americans here? 1, 2, 3. I'm there. So does anybody remember Prodigy? Yeah, one person remembers here. Yeah, Prodigy was like, a proto-internet in the US, kind of taking after Minitel. But they developed their own kind of, proprietary protocol. And this was called Prodigy Classic. And it lasted until 1999. So they had some actual overlap with the web. But as we know, in the 90s, the web just kind of took over, and it just beat every single service. So teletext proved out this concept that your user interface can be composed remotely, and it can be rendered by a dumb client. Does that sound like server-driven UI? Yes, it does. The interactivity was optional. The important part of this is just the fact that you separate the composition of a screen with the actual rendering. So the composition happened in the server. Some person created that composition, that lived in the server, and it was delivered to the client. And so these systems eventually failed, and they got replaced by the World Wide Web because they had one pitfall. They were closed gardens. And so the limitation of them was just the amount of content that was able to be delivered. And so what happened with the web is that the web gave people the ability to just compose their own web pages and link them to other web pages. And it just happened to have way more content than what a company could deliver. And so that was one of the big success factors of the web. So composition of user interfaces here is a big deal. It's a big reason why the web won. And so I just wanted to share that this whole concept of server-driven UI is not new. It's been kind of a part of early computer history. We use terminals. The fact that we deliver programs over the internet, or that you had to get a program over the floppy disk, that's actually something that comes later on. And right now we still have the web. It's the most successful server-driven UI thing that's out there. And nowadays there are a lot of companies doing mobile SDUI, like Airbnb, Netflix, DoorDash, etc. So this is what modern server-driven UI looks like. These are the companies that have been leading on this forefront. I also worked at a company that did server-driven UI. So, for example, Airbnb, they have the Ghost platform. So from what I remember, they developed this server-driven UI platform after they chose this really controversial mobile framework. I'm actually not sure what happened. They took a huge investment in it, and then they decided not to go with that. They decided to do server-driven UI. And nobody knows what happened because I think they were very quiet about it. They didn't really tell anybody. So why is this an interesting topic for me? Well, I love design. I love building cool things. And I've been a member of the React Native community since 2017, so I have been thinking, this is what I do for a living. What's going to happen next? I want to be, on top of it. I don't want to be caught by it. And so besides UI design, I also love operational efficiency, and I'm really, really into using AI tools. I'm one of the people that was just like, I see the writing on the wall. I'm not going to code anymore. I'm not going to hand code anymore. I'm just going to use AI agents for that. And so recently, a couple of months ago, I quit my job, and I started a company with my co-founder, Margaret Pieczkowski, who's of Polish descent, which is great. And we're creating an AI-native software company called OkThink. And we've been building a lot of really cool products for engineers who want to have the maximum usage of their AI tools. So while I'm here at the conference, I would love to get you to try them out. We have an amazing agent manager. We have a really cool image making tool, which created the backgrounds that you see here on the screen. We also have a language learning app called Itsumo. You can visit it at itsumo.study. And if you're learning Japanese, Polish, English, etc. It's a different experience than what you would get in with Duolingo. And actually, as I've been showing people this presentation framework, they're like, yeah, you should turn this into a service. So we're probably going to build this presentation framework into a product that people can use. And so because we're kind of at the forefront, we have to recognize right now we're in the horseless carriage era of AI. So if you know anything about automotive history, the first cars, they looked like just carriages without horses. Because that is the thing that people imagine came next, because that's, it was based on the context that they had. But we know that decades after, the cars look completely different and they had more features, etc. And so we are right now, this year, like 2025, 2026, we are in the horseless carriage era of AI. And this is a very exciting time to just quit your job and start a company and focus all your time on your agents. So, in 2026, if you're on Twitter all the time, like me, you'll see that there's a lot of discussion about how UI is dead. People are saying that like UI screens are dead. The next interface is just going to be chat. There's been a lot of devices that are essentially screenless AI devices. And we know that those have failed. So I think the naive argument is that AI is just going to be able to communicate with us, through different means than visual UI, and that's going to take over. But I think those people are wrong. I think what's actually happening is that fixed, hand-authored, ship with the client UI screens, it seems like it's a pain in the butt to do it now. We should just be using AI to deliver these user experiences. And if we were building for the web, that's very easy to do. But if you're a mobile development, that's actually very hard to do. A lot of us are still building screens that we need to package up into a bundle that we submit to the app stores, and then we have to wait around for a week or two for that to get approved, and it's just really, really slow. And this is the reason why a lot of companies have been developing server-driven UI, which is essentially just trying to get back to what the web does. So how many of you have been frustrated by App Store timelines? Yeah, I see a lot of hands being raised up, so yeah. So this is why I think this whole idea of like UI is dead is wrong, in terms of like we're just going to be using other things. And it's this idea of the difference between lexical and visual spatial thinking. So your lexical thinking is what you use when you read, when you process information through words, the labels, sentences, name symbols, etc. And visual spatial is what you do when you understand information by just like looking at it, by a glance. And so there are multiple ways in which we take in information. We can hear, we can read, we can just glance at something. And so we, as humans, we still need to be able to do these things. We're not going to let go of them. So here's the same idea rendered visually. So lexical processing is bad when you're trying to understand a city. A map is a lot better. Or when you're trying to understand the trend over time, a graph is a lot better for this. When you want to understand code-based architecture, how many of you are actually reading what AI is writing? Okay, a few people. I'm not. I give up on that. It's just reading a lot more. And we need to switch to like a visual spatial understanding of code now, because there's just so much code that is such a pain to read. And UI layouts, right? It's very easy to see. If you were just reading the code, that would be very hard for you to understand that this is going to yield a hard layout. It's a lot easier to just see it. So as we bring in AI, as we take the horse out of the carriage, which is what we're doing with AI, there are kind of two diverging paths, I think. We can have apps that include AI, or we can have AI systems that include apps. So this is what's in the forefront right now, and which way is it going to happen? I have no idea. one of the features that people talk about is this whole idea of the AI super app feature, where agentic AI just kind of becomes a new layer of access between you and companies and the products that you might be making as a developer. So the primary interface might become ChatGPT, Gemini, Claude, or another assistant. As you've seen, ChatGPT, all these services are including plugins or services into the chat that you can interact with. But if AI kind of becomes the intent router, what's going to happen with people that are building apps right now is that they're going to lose direct access to their consumers. So you might be delivering the service and you had an audience right now, but if AI just kind of becomes the entire interface to this, then you're still providing service, but you're losing the direct relationship with the people who previously installed your app. So I think this might happen. I don't know. I think Apple's probably not going to like this, but I think it's entirely possible that one of the new AI providers might actually do this. And so the whole point is, okay, a lot of stuff is going to happen with AI. We don't know what's going to change. But I have an idea, at least, that we can start doing a lot cooler stuff with the AI and server-driven UI, just by connecting an AI system to allow it to render server-driven UI. I like the idea of text, but we can do server-driven UI. So running a little bit slow, but I'm going to try to hurry up. The idea of a liquid interface is an intent-shaped surface. So it can be something that's like very dynamic, improvised by AI, where there's like a composer that chooses design system pieces, and where like a context can reshape it. Oh my God, what's happening with the emojis? And the design system constrains it. We all know what a design system is, right? We just recently discovered design.md, but design systems have been around for a really long time. And basically, the way that server-driven UI works is that there's a server that delivers a payload, that has a contract, and if the emojis would let me show you there, there's a client that has a design system and a renderer. And the renderer takes that data and uses the design system to render a UI. So right now, we are actually having a very similar bottleneck that video text had, which is this whole idea of the composition of screens is a bottleneck, because we're still making them as people. So we're going to have to replace the people with AI. And I think the audience is making its feelings felt about this. But as developers, I think it's an opportunity to make some really cool stuff. So we can think of the AI as the next composer for server-driven UI. And we can do some really interesting things with the payloads for server-driven UI. So for example, this is just like a simple JSON payload that has consistent IDs. So you can imagine here that the current payload might be what's showing on your screen right now, and then the server sends you what the next screen is supposed to be. And as long as you have consistent IDs for elements between these, you can do some really cool stuff, like shared element transitions. And so having stable IDs between payloads allow you to create kind of like this liquid feeling that I've been trying to express. I want to make apps be more have more ability for expression, because I was a Flash developer and I really miss Flash. So I just want to be making really cool stuff. So right now, what's been happening on your phones is that you've been seeing some content change on your phones. That's all been server-driven UI. So that's all been my server that's running that you connected to, and it's been sending little packets at you, telling you what to do, what to show in the next screen. We can do something more interesting by adding this whole idea of like a liquid layout, which is kind of like a transition manager. So this is the demo. So let's say we have an app, like the app of the future, which is an AI that's helping you arrive at your hotel. So like this might be your assistant. So let's go back here. So I'm going to bring up the device here on the screen. So this is what you're probably seeing in your slides, sorry, in your phones. Let me just go back and try this again. So let's say that this is, the badly designed app of the future or something like that, that is expressing itself through UI, not just through text. So let's say that you're arriving at the hotel, and this AI app has context about when you're actually arriving. And so as you're looking at your phone and you're arriving to the hotel, it just kind of changes the layout. And so one of the interesting things here that you notice is the shared element transitions. My shared element transition engine is not that great. People here, like Enzo, will probably build a much better one. But I'm just going to go back and show you, that there are some elements in here that just kind of stay on the screen, and some appear, some disappear. And then as you keep going through your day, as you get to the hotel, it knows that the app knows that you're at the hotel, and then you can just, it switches context for you so that you can just order noodles right away. And then as your noodles start arriving, the layout of this just kind of changes. So this is a very different dynamic than our typical stacked card-based mobile app interface. And I think if we invested in integrating AI with server-driven UI, we have the ability to make some really, really cool stuff. And so this thing is not that cool. Again, I think Enzo will make something way, way cooler than me. But I just wanted to show you that something like this is possible. And I wanted to open you to the idea that what we do as mobile developers in the future is build more clients, like dumb clients, that render server-driven UI. So this is how the pieces connect. I'm going to take the phone out. And yeah, we're almost at the end of the talk. What I'm hoping that you take away from this is that we, at the frontier of we're kind of like at the singular here for get some really good ideas, get inspired, go home, hack, bring us the next really, really cool demo that blows everybody's mind. And yeah, and that's it. Thank you. Come chat with me. And if you want a sticker, come see me after class. All right. Thank you so much.
Fantastic talk to round out the first day. Those of you who are just standing up, give me 2 more minutes of your time for some housekeeping bits, if that's okay. Thank you for making it with us to the end of today. Now, there are a couple of things I just want to mention before you head off. The first, it's been mentioned a couple of times, but there is an after party being run by Code Rabbit today. There should be information in your inbox, but I believe that's starting before now, so that could be a thing to go to after this. Secondly, please make sure you bring your badges tomorrow. Every single event I go to, doesn't matter what it is, people come on the second day, they don't have a badge, it's just a hassle for everyone. So try and hold on to it, bring it with you tomorrow to keep tomorrow easy. And the third thing is we start tomorrow at 10 o'clock. The doors are going to open at 9:30. And that was all I wanted to say just before you head off. Thank you again for being such a great audience today, and I'll see you tomorrow.